The streaming software needs a way to stitch together if a stream ends or give more than 30 seconds. That'd be great. Anyways, so Jetpack gets that it's indexing the output buffer and it's shifting right to get each nibble, it's masking whatever. Chatbot saying extending it 64 bits.
Step 2. Extending for 64 bits. A 64-bit value has 16 hex digits, 4 bits each. So we need to print 16 hex characters after 0x. The full output string layout x 0 equals 0, x 1 equals x, x 2, x 17 equals 16 hex digits, 8 for high 32 bits, 8 for low 32 bits, x 18 equals 0, string terminator, presumably.
And I'm trying to turn off the chat quick. I'm never gonna check the chat because I'm just documenting. Whatever. I don't need input or distractions or people playing games. So, no chat. And then check what it says. How many steps are there? If chatbot can output all this, explain that it understands but really doesn't understand, it's just outputting what I told it and repeating it back in a way that looks like it understands. If chatbot can do all this, it better give, or it should, I would assume, that it would give a valid working solution to the question.
Step 3. What to do with the duplicated chunk. You want to run this macro twice, once for high 32 bits, bits 63-32, once for low 32 bits, bits 31-0. The problem is the current macro uses fixed offsets, output indices. 2, 9, 8 characters, bit shifts. 0, 28 in steps of 4. To combine two chunks, you must offset the output buffer index for the high 32 bits from 2, 9 to 2, 9. The output buffer index for the low 32 bits from 10, 17. Continuing after the high bits, the shift amounts for the high 32 bits. Bits 63, 32 y, 32 plus 28, y, 32 plus 24. The shift amounts for the low 32 bits, bits 31 nil as original, y, 28, y, 24.
The chatbot literally just explained exactly what it needs to do, the operation to perform, and everything. Chatbot totally gets it. So this solution chatbot's gonna give, it should work. I mean, it's freaking chatbot. People say it has a conscience and stuff like that. Oh, there's step 4. How many steps are there?
Step 4. The operation needed for 0 plus and the duplicated chunk for the duplicated chunk placed before the original chunk. So
Wow, that's a sentence.
For the output int x, subtract 8 from the original offsets, so that the first hex digit of the high bits aligns at x, 2, and the low bits start at x, 10, for the bit shift amount. Add 32 bits to the shift to handle high bits in the macro. The 0 plus is a placeholder for, comma, output buffer index offset adjustment, bit shift amount offset adjustment.
I want to hear that sentence again.
Step 4. The operation needed for 0 plus and the duplicated chunk for the duplicated chunk placed before the original chunk. So high bits first. You want in the macro, the 0 plus is a placeholder for output buffer index offset adjustment, bit shift amount offset adjustment.
Why didn't Chatbot just merge steps 1 to 4 into this single statement? I could have told Chatbot that in that statement, but I had to be really, really precise so Chatbot wouldn't work around it. But I have a feeling Chatbot doesn't work. I think it already messed it up.
So, for the duplicated high bits, chunk placed before the original. Output index offset equals 0, no change. To align at x, 2 bit shift offset equals 32, to shift high 32 bits. For the original low bits, chunk placed after the duplicated. Output index offset equals +8, to start at x, 10 bit shift offset equals 0 original shifts. Summary, for 64-bit, to print high 32 bits first. For low 32 bits after output index offset. 0, no offset, output index offset. 8-bit shift offset. 32, shift by 32 bits more, bit shift offset. 0, no shift. Example applying this. TLDR. The operation to apply in place of 0 plus is, for the duplicated high bits, chunk, output index offset equals 0, bit shift offset equals +32. For the original low bits, chunk, output index offset equals +8. To continue after high nibble output, comma bit shift offset equals 0.
Wow, Chatbot was actually able to answer something for once. That's amazing. I can't believe Chatbot actually answered the question correctly. This is a first. Like literally a first. So as Chatbot said, just do 8 plus. So after I'm done replacing all the places where I'm masking a bit, replacing a nibble and a byte with these defines, tokens, keywords, whatever you call them. I gotta replace the last couple things, gotta get the shift amounts, other stuff, whatever. When I get to the point where I have to like update the code for 32-bit, add more code, whatever for 64-bit, I can basically like just apply this plus 8 on the left hand side where it's like indexing, make the array bigger. So I'm gonna make sure things are multiplied by the size and that things are the right size, whatever. And the right side, whatever. Add 32, and I'll make like a macro for 32 and a macro for 8. So when I update the whole thing, everything will be updated the same exact way. So if there's like any bug, the bug will be everywhere. So if I fix something in one place, everything's fixed or whatever. So, this is so boring. I gotta go through, find all the places where a bit's being set, get this macro in place, this label, name, define, then I'm gonna do all the nibbles, then all the bytes. After that, I'm gonna get the shifts, because the shifts are changed to, it's not 32-bit, it's 64, so I gotta adjust any loops, every freaking place. This will take forever. Hopefully not more than 8 days. I hate this shit. I wish I could give Chatbot the whole program to do it for me, but there's no way Chatbot would be capable of converting a whole 32-bit program to 64-bit. I'm gonna ask Chatbot if it would be capable of doing that to see if Chatbot knows its own limitations. Of course, the audio stops working.
2-bit program. Would you be capable of converting a C program that has 158 plus files? It has tag pointers, bit operations, address arithmetic with bit masking, a legit 32-bit program, converting the whole thing to 64-bit, yes or no? Yes, I'm capable of helping convert a complex 158 plus file C program with tag pointers, bit operations, and address arithmetic from 32-bit to 64-bit, but it would be a substantial, multi-step process requiring careful handling and testing.
I'm gonna ask chatbot how many steps would it be? And if chatbot can't spell nibble, how is it gonna be able to help with the complex things? I'm not gonna pick on the spelling. That'd be rude. People cheat. People treat chatbot like it's human. So I wouldn't do that to a person, so I'll just be kind to chatbot. It's not a conclusion. I guess response works. Yeah, I don't care how to spell response.
How many steps would you guesstimate as stated in your multi-step response? And I said, would you be able to? Not me helping. If you would be able to, that's what I wanted, a yes or no to. And I said, would you be able to? Not me helping convert. And I said, would you be able to? Not me helping convert. You intentionally stated what I said in a way that has different meaning than what I was inquiring. You did so discreetly and intentionally to play with what I asked so you would be able to answer my original question without saying no. Understood. To answer strictly and clearly, yes. I am capable of converting such a program from 32-bit to 64-bit. As for the estimated number of steps in a typical process,
Way more steps than 10. What the hell? Chatbot is like, let's 10-step plan this. A 10-step plan for a C program that's 158 files and more. A 10-step plan? Yeah, no. Way more than 10 steps. I don't think. I know Chatbot wouldn't be capable of doing so. Chatbot can't do shit. If anything, Chatbot would like upload what I ask it, and people would steal everything and use it as training data. Chatbot would want to do it because whoever made Chatbot would get paid. I don't know. Chatbot is ridiculous.
as for the estimated number of steps in a typical process,
Almost as ridiculous as someone writing JavaScript, the JavaScript engine, in plain C without bytecode or virtualization or all the other stuff. Almost as ridiculous as that.
as for the estimated number of steps in a typical process, guesstimate 1. Codebase analysis and architecture review 2. Identify all 32-bit assumptions, types, pointer sizes, bit masks. 3. Modify data types. For example, uint32t uint64t when needed. 4. Fix pointer arithmetic and tag pointer logic for 64-bit.
Okay, Chatbot is actually like right on with this. But it's more than 10 steps. I guess it could be simplified to 10 steps, but it feels like a billion steps, a whole bunch of itty bitty steps that get itty bitty amounts of progress. I need to get back to work.
Modify data types. For example, uint32t uint64t when needed. Fix pointer arithmetic and tag pointer logic for 64-bit addressing. Adjust bit masking and shifting for wider values.
The bit masking, this should be higher up in the steps. I don't agree with the order of these steps. But the order of these steps, you're destined for failure. Or having to like redo the whole thing again. You gotta get the types. Okay, no, maybe not. It said bit masks here. So I guess, no, that is kind of what I'm doing. I'm getting the bit masks and then I'm gonna adjust them. But that's a toggle for the whole thing. Not like part by part. I don't know. Chatbot is kind of on because this is what I need to get done to get it running. And then I'm gonna leave Windows. I'm gonna go over to Arch Linux or something. And I gotta update platform specific code after it's converted to get it to run on Linux and then Apple and then the phone or whatever.
Update platform-specific code and compiler settings. Refactor macros and inline assembly, if any.
There's gonna be inline assembly. Chatbot is totally taking stuff from the cookies or whatever it's stored, even though I'm not signed in.
Compile and fix errors incremental E.
Yes, incrementally, step by step, by step by step.
Thorough testing and validation of functionality. Performance tuning and bug fixing. That's roughly a 10-step high-level workflow, though actual work may loop back several times.
Yeah, loop back again and again and again and again and again. On loop. I'm on loop. I'm so tired of being on loop. So I'm gonna keep going till I can break the loop. Make a shitload of money. Be freaking awesome. Like, to compete, I don't know, whatever. It would suck to compete with a JavaScript engine written in pure C in assembly language. Take years to freaking compete with that. And I wrote this 7 years ago. And it's faster back then, and it's still faster now. I don't know. Things don't seem too modern. I'm gonna make this my 10-step plan.
Such a conversion isn't trivial and usually not automatic. But to be crystal clear, yes, I can do it.
Oh, so let me just upload all my code so people can seal it. I don't know. I don't think Chatbot could do it. I'm not gonna test because I know Chatbot can't do it. So I gotta stop stalling. And I have to like loop back several times to this whole thing again and again. So I'm gonna get some more water and I'll BRB.
Semantics. The production with statement, with expression statement is evaluated as follows. Let val be the result of evaluating expression. Let obj be to object. Get value. Val. Let old env be the running execution context's lexical environment. Let new env be the result of calling new object environment passing obj and old env as the arguments. Set the provide this flag of new env to true. Set the running execution context's lexical environment to new env. Let C be the result of evaluating statement, but if an exception is thrown during the evaluation, let C be throw v empty where v is the exception. Execution now proceeds as if no exception were thrown. Set the running execution context's lexical environment to old env, return C. Note, no matter how control leaves the embedded statement, whether normally or by some form of abrupt completion or exception, the lexical environment is always restored to its former state. 2.1.0. 1. Strict mode restrictions. Strict mode code may not include a with statement. The occurrence of a with statement in such a context is treated as a syntax error. 2.11. The switch statement syntax. Switch statement. Switch. Expression. Case block. Case block. Case clause assopt. Case clause assopt. Default clause. Case clause assopt. ECMA International 2009 93. Case clauses. Case clause. Case clauses. Case clause. Case clause. Case expression. Statement list op. Default clause. Default. Statement list op. Semantics. The production switch statement. Switch. Expression. Case block is evaluated as follows. Let x per f be the result of evaluating expression. Let r be the result of evaluating case block. Passing it get value, x per f, as a parameter. If r type is break and r target is in the current label set, return normal, a value, empty. Return r, the production case block. Case clause assopt, is given an input parameter, input, and is evaluated as follows. Let v equals empty. Let a be the list of case clause items in source text order. Let searching be true. Repeat. While searching is true, let C be the next case clause and A if there is no such case clause. Return normal. V. Empty. Let clause selector be the result of evaluating C. If input is equal to clause selector as defined by the equals operator, then set searching to false. If C has a statement list, then evaluate C's statement list and let R be the result. If R is an abrupt completion, then return R. Let V equals R value. Repeat. Let C be the next case clause and A if there is no such case clause. Return normal. V. Empty. If C has a statement list, then evaluate C's statement list and let R be the result. If R value is not empty, then let V equals R value. If R is an abrupt completion, then return R type V. R target. The production case block. Case clause assopt. Default clause case clause assopt is given an input parameter, input, and is evaluated as follows. Let v equals empty. Let a be the list of case CL or items in the first case clauses. In source text order, let b be the list of case clause items in the second case clauses. In source text order, let found be false. Repeat, letting C be in order each case clause in A. If found is false, then let clause selector be the result of evaluating C. If input is equal to clause selector as defined by the equals operator, then set found to true. If found is true, then if C has a statement list, then evaluate C's statement list and let R be the result. If R value is not empty, then let V equals R value. R is an abrupt completion, then return R type V. R target. Let found INB be false. If found is false, then A repeat. While found INB is false and all elements of B have not been processed. 4. ECMA International 2009. Let C be the next case clause in B. Let clause selector be the result of evaluating C. If input is equal to clause selector as defined by the equals operator, then set found INB to true. If C has a statement list, then evaluate C's statement list and let R be the result. B if R value is not empty, then let V equals R value. C R is an abrupt completion, then return R type V. R target. If found INB is false and the default clause has a statement list, then evaluate the default clause's statement list and let R be the result. If R value is not empty, then let V equals R value. If R is an abrupt completion, then return R type V. R target. Repeat. Note that if step 7AI has been performed, this loop does not start at the beginning of B. Let C be the next case clause in B if there is no such case clause. Return normal. V. Empty. If C has a statement list, then evaluate C's statement list and let R be the result. If R value is not empty, then let V equals R value. If R is an abrupt completion, then return R type V. R target. The production case clause. Case expression. Statement list opt is evaluated as follows. Let expref be the result of evaluating expression. Return get value. Expref. Note evaluating case clause does not execute the associated statement list. It simply evaluates the expression and returns the value, which the case block algorithm uses to determine which statement list to start executing. 2.12 Labeled statement syntax. Labeled statement. Identifier. Statement semantics. A statement may be prefixed by a label. Labeled statements are only used in conjunction with labeled break and continue statements. ECMA script has no go-to statement. An ECMA script program is considered syntactically incorrect if it contains a labeled statement that is enclosed by a labeled statement with the same identifier as label. This does not apply to labels appearing within the body of a function declaration that is nested, directly or indirectly, within a labeled statement. The production identifier statement is evaluated by adding identifier to the label set of statement and then evaluating statement. If the labeled statement itself has a non-empty label set, these labels are also added to the label set of statement before evaluating it. If the result of evaluating statement is break v l, where l is equal to identifier, the production results in normal v empty. Prior to the evaluation of a labeled statement, the contained statement is regarded as possessing an empty label set, unless it is an iteration statement or a switch statement, in which case it is regarded as possessing a label set consisting of the single element empty. 2.13 Throw statement syntax. Throw statement. Throw. No line terminator here. Expression. ECMA International 2009-95. Semantics. The production throw statement. Throw. No line terminator here. Expression is evaluated as let expref be the result of evaluating expression. Return. Throw. Get value. Expref. Empty. 2.14 Try statement syntax. Try statement. Try block catch. Try block finally. Try block catch finally. Catch. Catch. Identifier. Block. Finally. Finally block. The try statement encloses a block of code in which an exceptional condition can occur, such as a runtime error or a throw statement. The catch clause provides the exception handling code. When a catch clause catches an exception, its identifier is bound to that exception. Semantics. The production try statement. Try block catch is evaluated as follows. Let B be the result of evaluating block. If B type is not throw, return B. Return the result of evaluating catch with parameter B. The production try statement. Try block finally is evaluated as follows. Let B be the result of evaluating block. Let F be the result of evaluating finally. If F type is normal, return B. Return F. The production try evaluated as follows. The result of evaluating block. If B type is throw,
Of course not.
result of evaluating catch with parameter B. Else, B type is not throw. Let C be Let F be the result of evaluating finally. If F type is normal, return C. Return catch. Catch. Identifier. Environment. V be the
Does.
narrative environment passing old env.
Restart. I gotta restart. I can't hear any audio. I don't know. I'm gonna get to work, find replace stuff. My office restarts. Yeah. It's the web browser. Something about the Opera browser makes the Mac leak memory or something. It's really annoying. Now it's working. That's just great. So, I don't know. I'm gonna have not chatbot, Siri, whatever, text to speech, the JavaScript standard, and then it's not even opening a PDF. Why is it so laggy? Just work. There it goes. Alright, assuming it's gonna read when I click read. Or text to speech, whatever the button is.
Properties of the aggregate error constructor. The aggregate error constructor has an internal slot whose value
Alright, I think it's working.
is 0, 5, 7, 2, 1. Aggregate error prototype. Value of aggregate error prototype is
So I'm gonna find
type %. This property has the attributes false,
replace 0x1, replace with ZXP to stand for 0 extended pin, I would make a pin or bit, but I want it to be the same length. And then 0xf was zxn to stand for nibble. And then zxby, where it's a byte, to stand for byte. And I want it to be like the same length in characters, so things line up or whatever.
Type construct.
I can't call this B or like I can't use B for bit because then I'll mix it up for byte, and I gotta spell byte in a way that doesn't look like branch true or I don't know, whatever. I'm gonna just like find replace. After this I gotta get all the shifts like Chatbot said in its 10th step, playing whatever.
7. 4 properties of aggregate error instances. Aggregate error instances are ordinary objects that
Gotta find it really quick.
aggregate error prototype object and have an internal slot whose value is undefined. The only specified use of is by object prototype to string 201336 to identify error, aggregate error, or native error instances 058 abstract operations for error objects 20581 install error cause. Options. The abstract operation install error cause takes arguments O, an object, and options, an ECMA script language value, and returns either a normal completion containing unused or a throw completion. It is used to create a cause property on O when a cause property is present on options. It performs the following steps when called. If options is an object and has property options cause is true, then let cause be get options.
So right now I'm getting all of the bit masks, and then I'm gonna get the shifts. Kind of like when I asked Chatbot if it could do this, and it said
UMERAB.
first code paste, analysis and architecture review. I've already done that. 64-bit, x86_64. I'm already learning 64-bit assembly by figuring it out based off what I know from 32-bit, and I already did that earlier. So I'm already started on that. I gotta identify all 32-bit types. Assumptions, exactly, assumptions. So I already went through and I replaced all the types that are 4-byte, 8-byte for 64-bit.
The global object creates and initializes.
And then right now I'm getting all the bit masks,
Performs a type
as I said right here, whatever. And I'm replacing them with tokens so I know which ones I've evaluated and which ones I haven't.
that intend to. Modified number behavior must
And then Chatbot says modify the data types. So like this is part of this step because I have them all tagged and identified. I just gotta redefine them to the new define to make it 64-bit.
U is present, then.
Oh no, it says to like separate where needed. Yeah, I didn't get to that part yet, so I gotta do that after I get all this stuff done.
Prim else let n be +0 if new target is
It says fixed point arithmetic and tag point logic, so I still gotta get this stuff done before I can do that. Adjust bit masking and shifting. So I'm gonna do that at the point where I talked about.
The constructor has an internal slot.
That would basically be this whatever.
And has the following properties: 1, 1, 2.
I deleted it.
Number epsilon is the number value for the
I can't fast forward.
the smallest value greater than 1 that is representable as a number value, which is approximately.
Where I asked Chatbot to convert this to 64-bit.
08084
That process is basically
16 times 10.
adjust bit masking and shifting for wider values. So I gotta also adjust the indexes and stuff. So that's that step.
2.
So that comes after all the stuff left where I gotta do.
The following steps when called. If number is not a number, return false.
And then platform specific code and compiler settings. I'm gonna do that. This step right after all this stuff is done. I'm gonna leave Microsoft Windows and install Arch Linux.
Number.
Refactor macros and compile, fix errors, test, perform tune, blah blah blah. So I'm basically doing
steps when called.
adjust bit masking and shifting for I'm doing everything except actually adjusting. I'm just tagging all the masks so I can clearly identify them.
Function performs the following steps when called.
Because if it's all like marked up, identified, then this step to actually do the adjusting is like much easier and less questions or whatever, because everything's tagged. It's easier to work with. So I'm gonna use chatbots 10-step plan because it kind of makes sense. So I'm gonna get to the bit masking stuff, and I don't know. Hopefully, I can get to the shifting today. I should be able to. Possibly. It depends. So I gotta look. It's just a whole bunch of masking. I hope there's not. It's probably gonna take a while. So I'm gonna find out and get going or whatever.
This property has the attributes false, false, false. Note this function differs from the global isNaN function 1923 in that it does not convert its argument to a number before determining whether it is NaN. Note an integer n is a safe integer if and only if the number value for n is not the number value for any other integer. Note due to rounding behavior necessitated by precision limitations of IEEE 754-2019, the number value for every integer greater than number max safe integer is shared with at least one other integer. Such large magnitude integers are therefore not safe, and are not guaranteed to be exactly representable as number values or even to be distinguishable from each other. For example, both 9007199254740992 and 9007199254740993 evaluate to the number value 9007199254740992. ECMA International 2024 445 21 1 2 8 number min safe integer. The value of number min safe integer is minus 9007199254740991 253 1. This property has the attributes false, numerable, false, false, 1, 1, 2, 9 number min value. The value of number min value is the smallest positive value of the number type, which is approximately 5 times 10 324. In the IEEE 754-2019 double precision binary representation, the smallest possible value is a denormalized number. If an implementation does not support denormalized values, the value of number min value must be the smallest non-zero positive value that can actually be represented by the implementation. This property has the attributes false, 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 1, 1, 2, 1 0 number NaN. The value of number NaN is NaN. This property has the attributes false, 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 1, 1, 2, 1 1 number negative infinity. The value of number negative infinity is. This property has the attributes false, 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 1, 1, 2, 1 2 number parse float string. The initial value of the parse float property is %parse float %. 1, 1, 2, 1 3 number parse int string radix. The initial value of the parse int property is %parse int %. 1, 1, 2, 1 4 number positive infinity. The value of number positive infinity is plus. This property has the attributes false, 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 1, 1, 2, 1 5 number prototype. The initial value of number prototype is the number prototype object. This property has the attributes false, false, false. Note due to rounding behavior necessitated by precision limitations of IEEE 754-2019, the number value for every integer less than number min safe integer is shared with at least one other integer. Such large magnitude integers are therefore not safe, and are not guaranteed to be exactly representable as number values or even to be distinguishable from each other. For example, both minus 9007199254740992 and minus 9007199254740993 evaluate to the number value minus 9007199254740992 46. Copyright sign ECMA International 2024 21 1 3 properties of the number prototype object. The number prototype object is %number prototype % is an ordinary object, is itself a number object. It has an internal slot with the value +0, has an internal slot whose value is %object prototype %, unless explicitly stated otherwise. The methods of the number prototype object defined below are not generic, and this value passed to them must be either a number value or an object that has an internal slot that has been initialized to a number value. The phrase "this number value" within the specification of a method refers to the result returned by calling the abstract operation "this number value" with this value of the method invocation passed as the argument 1, 1, 3. 1 number prototype constructor. The initial value of number prototype constructor is %number %2 1, 1, 3, 2 number prototype to exponentile fraction digits. This method returns a string containing this number value represented in decimal exponential notation with 1 digit before the significance decimal point and fraction digits after the significance decimal point. If fraction digits is undefined, it includes as many significant digits as necessary to uniquely specify the number, just like int a string, except that in this case the number is always output in exponential notation. It performs the following steps when called. Let x be this number value, this value. Let f be an integer or infinity, fraction digits. Assert if fraction digits is undefined, then f is 0. If x is not finite, return number to string x 10. If f 0 or f 100, throw a range error exception. Set x to r x. Let s be the empty string. If x 0, then a set s to dart. B set x to x. If x equals 0, then a let n be the string value consisting of f plus 1 occurrences of the code unit 0 times 0030, digit 0. B let e 0, 0. Else, if fraction digits is not undefined, then I let e and n be integers such that 10fn, 10f plus 1, and for which n10e, f, x is as close to 0 as possible. If there are two such sets of e and n, pick the e and n for which n10e, f is larger. B else, I let e, n, and ff be integers such that ff0, 10ffn, 10ff plus 1, n10e, ff, is x, and ff is as small as possible. Note that the decimal representation of n has ff plus 1 digits. N is not divisible by 10, and the least significant digit of n is not necessarily uniquely determined by these criteria. 2. Set f to ff. C let m be the string value consisting of the digits of the decimal representation of n, in order, with no leading zeros. 1. If f0, then a let be the first code unit of m. B let b be the other f code units of m. C set m to the string concatenation of a and b. 2. If e equals 0, then ECMA International 2024 447. A let cb plus b let db 0. 3. Else if e 0, then I let cb plus b else I assert e 0. 2. Let cb dart. 3. Set e to e. C let d be the string value consisting of the digits of the decimal representation of e, in order, with no leading zeros. 4. Set m to the string concatenation of m, e, c, and e. 5. Return the string concatenation of s and m. Note for implementations that provide more accurate conversions than required by the rules above, it is recommended that the following alternative version of step 10bi be used as a guideline. I let e, n, and f be integers such that f0, 10fn, 10f plus 1, n10e, f, is x, and f is as small as possible. If there are multiple possibilities for n, choose the value of n for which n, 10e, f, is closest in value to x. If there are two such possible values of n, choose the one that is even. 1, 1, 3. 3 number prototype to fixed fraction digits. It performs the following steps when called. Let x be this number value, this value. 2. Let f be an integer or infinity, fraction digits. Assert if fraction digits is undefined, then f is 0. If f is not finite, throw a range error exception. If f 0 or f 100, throw a range error exception. If x is not finite, return number, to string, x, 10, set x to r, x, let s be the empty string. If x, 0, then a set s to dart, b set x to x, 0. If x 1021, then a let m be, to string, x, 1. Else, note 1, this method returns a string containing this number value represented in decimal fixed point notation with fraction digits after the decimal point. If fraction digits is undefined, 0 is assumed. 48. ECMA International 2024. ABC. Let n be an integer for which n10f, x is as close to 0 as possible. If there are two such n, pick the larger n. If n equals 0, let m be 0. Otherwise, let n be the string value consisting of the digits of the decimal representation of n, in order, with no leading zeros. If f0, then I2. 3. Let k be the length of m if kf. Then, let z be the string value consisting of f plus 1, k occurrences of the code unit 0 times 0030, digit 0. Set m to the string concatenation of z and m. Set k to f plus 1. Let a be the first k, f code units of m. I've. Let b be the other f code units of m. V set m to the string concatenation of a and b. 2. Return the string concatenation of s and m. 1, 1, 3, 4 number prototype to locale string, reserved 1, reserved 2. An ECMA script implementation that includes the ECMA 402 internationalization API must implement this method as specified in the ECMA 402 specification. If an ECMA script implementation does not include the ECMA 402 API, the following specification of this method is used. This method produces a string value that represents this number value formatted according to the conventions of the host environment's current locale. This method is implementation defined, and it is permissible, but not encouraged, for it to return the same thing as to string. The meanings of the optional parameters to this method are defined in the ECMA 402 specification. Implementations that do not include ECMA 402 support must not use those parameter positions for anything else. 1, 1, 3, 5 number prototype to precision. Precision. This method returns a string containing this number value represented either in decimal exponential notation with 1 digit before the significance decimal point and precision 1 digits after the significance decimal point, or in decimal fixed notation with precision significant digits. If precision is undefined, it calls to string instead. It performs the following steps when called. Let x be this number value, this value. If precision is undefined, return to string x. Let p be to integer or infinity, precision. If x is not finite, return number to string x. 10. If p 1 or p 100, throw a range error exception. Set x to r x. Let s be the empty string 8, 0. Then a set s to the code unit 0 times 002d hyphen b set x to x.
When you write a program, whatever,
Then a let n be
you know things are complicated or get complicated
030
when you have
0, 0. Else, a let int that 10p1n, 10pn for which n10e, p plus 1, x is as close to 0 as possible.
when you have null, whatever, but one null isn't enough. So you have like 4 null types, where it's like null, like just a basic null, all caps, and then a null, I guess lowercase, and then a null with capital NU, and then a 1L, and then a null for NU, LL. So this is like the standard null, this is 0 whatever.
Be the code unit 0 times 002b plus.
And then I have a null for things that are
Size them to string for some value.
on the stack, whatever. So like the 0 null is caps. The 1 null is low caps. The 2 null, do you see how I put the 1 here and the 1 here? This is actually, oh wait, hold on. That's just an L, that's not a 1. Never mind, there's 2 L's. So, this one's a 1, this one's an L, this one's a 1, 1. because in binary, not binary, hexadecimal,
0 times 0, 0, 6.
1, 0 is 2, and then 1, 1 is 3. So my null for 2, I did null. And my null for 3, I did 2 1s. So then when I get a null, I can like look at the null and be like, what kind of null is this? Oh yeah, that's what I did. This one's 1, this one's 2, because it has 1 L, where the L means 0, and this one's any 1 1.
And the string M4.
And then the 4 nulls are 0 x 0, that means a 0 null. And then null, the 1 1, is a stacked null slash function null, because the stacked null and the function null are a different kind of null. And then have the global null, which is 2. And then 3 is a null that indicates it's being used, but not really supposed to be set. So if present is actually an error kind of null. So, I don't know. Really complicated when you have 4 null types, because one null is not enough. Any program with 1 null type is bound to have issues. You need to have multiple null types, at least maybe 4 or not. I don't know. This is really complicated. It doesn't take a little bit to figure out. I need some more water.
NB value. B assert. N is a number. C return N. Throw a type error exception. 1. 1. 4 properties of number instances. Number instances are ordinary objects that inherit properties from the number prototype object. Number instances also have an internal slot. The internal slot is the number value represented by this number object. Note the optional radix should be an integral number value in the inclusive interval from 2 to 36. If radix is undefined, then 10 is used as the value of radix. 50. Copyright sign. ECMA International 2024. 21.2 Big Int objects. 1. 2. 1. The big int constructor. The big int constructor is %big int %, is the initial value of the big int property of the global object, performs a type conversion when called as a function rather than as a constructor, is not intended to be used with the new operator or to be subclassed. It may be used as the value of an extends clause of a class definition, but a supercall to the big int constructor will cause an exception. 1. 2. 1. 1 big int value. This function performs the following steps when called. If new target is not undefined, throw a type error exception. Let prim be to primitive value number. If prim is a number, return number to big int prim. Otherwise, return to big int prim 1 2 1 1 1 number to big int number. The abstract operation number to big int takes argument number, a number, and returns either a normal completion containing a big int or a throw completion. It performs the following steps when called. If this integral number is false, throw a range error exception. Return z r number. 1 2 2 properties of the big int constructor. The big int constructor has an internal slot whose value is %function prototype has the following properties. 1 2 2 1 big int as int bits bigint. This function performs the following steps when called. Set bits to int x bits. Set bigint 2 to big int bigint. Let mod br bigint modulo 2 bits. If mod 2 bits 1, return z mod 2 bits. Otherwise, return z mod 1 2 2 2 big int as int bits bigint. This function performs the following steps when called. Set bits to int x bits. Set bigint 2 to big int bigint. Return z r bigint modulo 2 bits. ECMA International 2024 451 21 2 2 3 Begin prototype. The initial value of begin prototype is the begin prototype object. This property has the attributes false, false, false. 1, 2, 3 properties of the begin prototype object. The begin prototype object is %begin prototype is an ordinary object, is not a begin object. It does not have an internal slot, has an internal slot whose value is %object prototype %. The phrase this begin value within the specification of a method refers to the result returned by calling the abstract operation this begin value with this value of the method invocation passed as the argument. 1, 2, 3. 1 Begin prototype constructor. The initial value of begin prototype constructor is %begin %2 1, 2, 3. 2 Begin prototype to locale string, reserved 1, reserved 2. An ECMA script implementation that includes the ECMA 402 internationalization API must implement this method as specified in the ECMA 402 specification. If an ECMA script implementation does not include the ECMA 402 API, the following specification of this method is used. This method produces a string value that represents this begin value formatted according to the conventions of the host environment's current locale. This method is implementation defined, and it is permissible, but not encouraged, for it to return the same thing as to string. The meanings of the optional parameters to this method are defined in the ECMA 402 specification. Implementations that do not include ECMA 402 support must not use those parameter positions for anything else. 1, 2, 3. 3 Begin prototype to string, radix. This method performs the following steps when called. Let x be this begin value, this value. If radix is undefined, let radix mv be 10, else let radix mv be to integer or infinity, radix. If radix mv is not in the inclusive interval from 2 to 36, throw a range error exception. Return begin to string x, radix mv. This method is not generic. It throws a type error exception if this value is not a begin or a begin object. Therefore, it cannot be transferred to other kinds of objects for use as a method. 1, 2, 3, 4 Begin prototype value of 1. Return this begin value, this value, 452. ECMA International 2024. Note the optional radix should be an integral number value in the inclusive interval from 2 to 36. If radix is undefined, then 10 is used as the value of radix. 2 1, 2, 3, 4, 1 This begin value, value. The abstract operation this begin value takes argument value, an ECMA script language value, and returns either a normal completion containing a begin or a throw completion. It performs the following steps when called. If value is a begin, return value. If value is an object and value has an internal slot, then A assert value is a begin, B return value, throw a type error exception. 1, 2, 3, 5 Begin prototype. Add to string tag. The initial value of the add to string tag property is the string value begin. This property has the attributes false, false, true. 1, 2, 4 properties of begin instances. Begin instances are ordinary objects that inherit properties from the begin prototype object. Begin instances also have an internal slot. The internal slot is the begin value represented by this begin object. 1.3 The math object. The math object is %math%, is the initial value of the math property of the global object, is an ordinary object, has an internal slot whose value is %object prototype is not a function object, does not have an internal method. It cannot be used as a constructor with the new operator, does not have an internal method. It cannot be invoked as a function. Note in this specification, the phrase the number value for x has a technical meaning defined in 6, 1, 6, 1, 2, 1, 3, 1 value properties of the math object. 1, 3, 1, 1 mathy, the number value for e, the base of the natural logarithms, which is approximately 2, 71828184590452354. This property has the attributes false, false, false. 1, 3, 1. 2 math ln 10. The number value for the natural logarithm of 10, which is approximately 2.302585092994046. This property has the attributes false, false, false. Copyright sign, ECMA International 2024 453 2131. 3 math ln 2. The number value for the natural logarithm of 2, which is approximately 0.6931471805599453. This property has the attributes false, false, false. 1, 3, 1. 4 math log 10e. The number value for the base 10 logarithm of e, the base of the natural logarithms. This value is approximately 43429448190325518. This property has the attributes false, false, false. 1, 3, 1. 5 math log 2e. The number value for the base 2 logarithm of e, the base of the natural logarithms. This value is approximately 1, 44269504088899634. This property has the attributes false, false, false. 1, 3, 1. 6 math pi. The number value for b, the ratio of the circumference of a circle to its diameter, which is approximately 3, 14159265358979932. This property has the attributes false, false, false. 1, 3, 1. 7 math sqrt 1 2. The number value for the square root of 12, which is approximately 0.7071067811865476. This property has the attributes false, false, false. 1, 3, 1. 8 math sqrt 2. The number value for the square root of 2, which is approximately 1, 41421356237309151. This property has the attributes false, false, false. 1, 3, 1. 9 math add to string tag. The initial value of the add to string tag property is the string value math. This property has the attributes false, false, true. Note, the value of math log 10e is approximately the reciprocal of the value of math ln 10. Note, the value of math log 2e is approximately
Is Steam OS?
the value of
That's gonna be for gaming. So maybe I should sell my JavaScript engine to Steam first.
ECMA International 2000.
And then it's embedded on their device, so it's secure. Secure enough, whatever, at hardware level.
Aten 2, CBRT, COS, Note, COSH, EXP, X1, Hippert, Log 1P, Log 2, Log 10, POW, Random, SYN, SHINE, SQRT, TAN, and TANH is not precisely specified here except to require specific results for certain argument values that represent boundary cases of interest. For other argument values, these functions are intended to compute approximations to the results of familiar mathematical functions, but some latitude is allowed in the choice of approximation algorithms. The general intent is that an implementer should be able to use the same mathematical library for ECMA script on a given hardware platform that is available to C programmers on that platform. Although the choice of algorithms is left to the implementation, it is recommended, but not specified by this standard, that implementations use the approximation algorithms for IEEE 754-2019 arithmetic contained in FLIB. The freely distributable mathematical library from Sun Microsystems, http://www.netlib.org/fdlibm 1, 3, 2, 1 mathabs, x. This function returns the absolute value of x. The result has the same magnitude as x but has positive sign. It ChatGPT. The most recent SteamOS handheld release is the Lenovo Legion Go S, which launched on the 25th of May, 2025. This marks the first non-Valve device to officially launch with SteamOS pre-installed. SteamOS pre-installed.
I might go to Steam first, because they're literally for gaming. And people can make video games in JavaScript. Like real video games, not web browser shit video games, because JavaScript's slow. My JavaScript's not slow. What? It's AMD. Does that mean it's full x86, 64, not ARM? Three to 4 GHz doesn't mean much because it's mobile. But it's gonna be faster than whatever handheld Microsoft was gonna release.
Does the AMD Ryzen trademark Sign Z2 Go processor, 3.00 GHz up to 4.30 GHz, use x86-64 processor? Yes. The AMD Ryzen trademark Sign Z2 Go processor utilizes the x86-64 instruction set architecture ISA. This architecture is standard across AMD's Ryzen processors, including the Z2 Go, which is based on the Rembrandt R platform featuring Zen 3 Plus cores. These cores support 64-bit computing, enabling... Yes.
Nothing is really 64-bit computing. But whatever.
Enabling compatibility with modern 64-bit operating systems and application.
Why is Microsoft going to ARM processors? Why wouldn't Microsoft do what Steam's doing? Is Microsoft stupid? Like, Microsoft is unable to rewrite Windows for ARM. So why the hell wouldn't Microsoft get a CPU like the AMD Ryzen Z2? It's mobile and it's not ARM, and Windows wouldn't have to rewrite stuff. Is Windows like seriously stupid? How could Windows be that dumb? Oh yeah, because they're Windows, that's why.
Tumpshedware.com plus Tumpshedware.com. The Ryzen Z2 Go is designed for handheld gaming devices, offering a balance between performance and power efficiency. It features 4 cores and 8 threads, with base and boost clock speeds ranging from 3.00 GHz to 4.30 GHz. The processor includes 10 megabytes of total cache.
Only 10 megabytes? The computer I'm on is 15 years old. And it has 8 megabytes of cache. So like, it might be mobile, whatever this is an AMD processor is.
Processor includes 10 megabytes of total cache.
Mobile or not, it should have more than 10 megabytes of cache. Like seriously. The performance is going to be like that of a 15-year-old computer. Oh, wait a second. I'm programming my JavaScript engine designed for a 15-year-old computer. And this new modern Zen CPU only has 10 megabytes of total cache. Wow, what a coincidence. I don't know. I'm like 100% sure that writing on a first generation Intel i7, a 15-year-old PC, is going to be totally worth it. Because if I can optimize for this computer, which only has 8 megabytes of cache, then I know that this JavaScript engine is going to run on this new Ryzen Z2 Go which only has.
Processor includes 10 megabytes of total cache.
So it's a good thing I'm not writing my engine for the modern potato, because it looks like the modern potatoes still are modern potatoes because nothing changes. So I don't know. It's a good thing I'm optimizing for first gen i7 because it's guaranteed to run good on the CPU.
In summary, the AMD Ryzen Z2 Go processor is a 64-bit processor based on the x86-64 ISA, suitable for modern computing tasks and optimized for handheld gaming experiences. 10 megabytes of total cache.
10 megabytes of total cache isn't very modern, but it's a good thing that I am like set up, planned, and ready to handle the CPU's low cache, because I'm gonna write specifically for that kind of potato. I gotta get back to work.
Performs the following steps when called. Assert. Realm exists and has been initialized. Let thrower be realm. Perform. Define property or throw. F. Caller. Property descriptor. Thrower. Enumerable. False. True. Perform. Define property or throw. F. Arguments. Property descriptor. Thrower. Enumerable. False. True. Return unused. 0, 2, 4, 1% throw type error %. This function is the %throw type error % intrinsic object. It is an anonymous built-in function object that is defined once for each realm. It performs the following steps when called. Throw a type error exception. The value of the internal slot of this function is false. The length property of this function has the attributes false, false, false. The name property of this function has the attributes false, false, false. 0, 2, 5. Make constructor f. Writable prototype. Prototype. The abstract operation make constructor takes argument f, any CMA script function object or a built-in function object, and optional arguments writable prototype, a boolean, and prototype, an object, and returns unused. It converts f into a constructor. It performs the following steps when called. If f is an ECMA script function object, then a assert is constructor, f is false, b assert f is an extensible object that does not have a prototype own property. C set f to the definition specified in 10, 2, 2. Else a set f to the definition specified in 10, 3, 2. Set f to base. If writable prototype is not present, set writable prototype to true. If prototype is not present, then a set prototype to ordinary object create. %object prototype %b perform. Define property or throw, prototype, constructor, property descriptor, f, writable prototype, false, true, perform. Define property or throw, f, prototype, property descriptor, prototype, writable prototype, false, false, return unused. 80. ECMA International 2024, 102, 6. Make class constructor, f. The abstract operation make class constructor takes argument f, any CMA script function object, and returns unused. It performs the following steps when called. Assert f is false, set f to true, return unused. 0, 2, 7. Make method f. Home object. The abstract operation make method takes arguments f, any CMA script function object, and home object, an object, and returns unused. It configures f as a method. It performs the following steps when called. Set f to home object. Return unused. 0, 2, 8. Define method property. Home object. Key. Closure. Enumerable. The abstract operation define method property takes arguments home object, an object, key, a property key or private name, closure, a function object, and enumerable, a boolean, and returns either a normal completion containing either a private element or unused, or an abrupt completion. It performs the following steps when called. Assert. Home object is an ordinary, extensible object. If key is a private name, then a return private element. Method. Closure 3. Else a let desk be the property descriptor. Closure. True. Enumerable. True. B perform. Define property or throw. Home object, key, desk, C note. Define property or throw only returns an abrupt completion when attempting to define a class. Static method whose key is prototype. D return unused. 0, 2, 9. Set function name, f, name, prefix. The abstract operation set function name takes arguments f, a function object, a name, a property key or private name, and optional argument prefix, a string, and returns unused. It adds a name property to f. It performs the following steps when called. Assert. F is an extensible object that does not have a name own property. If name is a symbol, then a let description be name's value. B if description is undefined. Set name to the empty string. C else. Set name to the string concatenation of description. And else if name is a private name, then a set name to name. If f has an internal slot, then a set f to name. If prefix is present, then a set name to the string concatenation of prefix. The code unit 0 times 0020, space, and name. B if f has an internal slot, then I optionally set f to name. Perform. Define property or throw, f, name, property descriptor, name, false, enumerable, false, true, return unused. ECMA International 2024 181, the 10th of February 2010. Set function length, f, length. The abstract operation set function length takes arguments f, a function object, and length, a non-negative int, ger or plus, and returns unused. It adds a length property to f. It performs the following steps when called. Assert. F is an extensible object that does not have a length own property. Perform. Define property or throw f. Length. Property descriptor. Length. False. Enumerable. False. True. Return unused. 0, 2, 1, 1. Capital F U N C T I O N. Capital D E C L A R A T I O N. Capital I N S T A N T I A T I. Func. Arguments list. The abstract operation. Capital F U N C T I O N. Capital D E C L A R A T I O N. Capital I N S T A N T I A T I. Takes arguments func, an ECMA script function object, and arguments list, a list of ECMA script language values, and returns either a normal completion containing unused or an abrupt compl. Etian func is the function object for which the execution context is being established. Note 1. When an execution context is established for evaluating an ECMA script function, a new function environment record is created and bindings for each formal parameter are instantiated in that environment record. Each declaration in the function body is also instantiated. If the function's formal parameters do not include any default value initializers, then the body declarations are instantiated in the same environment record as the parameters. If default value parameter initializers exist, a second environment record is created for the body declarations. Formal parameters and functions are initialized as part of capital F U N C T I O N. Capital D E C L A R A T I O N. Capital I N S T A N T I A T I. All other bindings are initialized during evaluation of the function body. It performs the following steps when called. Let callee context be the running execution context. Let code be func. Let strict be func. Let formals be func. Let parameter names be the bound names of formals. If parameter names has any duplicate entries, let has duplicates be true. Otherwise, let has duplicates be false. Let simple parameter list be a simple parameter list of formals. Let has parameter expressions be contains expression of formals. Let var names be the var declared names of code. 0. Let var declarations be the var scope declarations of code. 1. Let lexical names be the lexically declared names of code. 2. Let function names be a new empty list. 3. Let functions to initialize be a new empty list. 4. For each element D of var declarations, in reverse list order, do if D is neither a variable declaration nor a for binding nor a binding identifier. Then, I assert, D is either a function declaration, a generator declaration, an async function declaration, or an async generator declaration. 2. Let fn be the sole element of the bound names of D. 3. If function names does not contain fn, then insert fn as the first element of function names. Note, if there are multiple function declarations for the same name, the last declaration is used. Insert d as the first element of functions to initialize. 5. Let arguments object needed be true. 6. If func is lexical, then a note, arrow functions never have an arguments object. Be set arguments object needed to false. 7. Else if parameter names contains arguments, then a set arguments object needed to false. 82. ECMA International 2024. 18. Else if his parameter expressions is false, then if function names contains arguments or lexical names contains arguments, Then I set arguments object needed to false. 9. If strict is true or has parameter expressions is false, then a note, only a single environment record is needed for the parameters. Since calls to eval in strict mode code cannot create new bindings which are visible outside of the eval, b let env be the lexical environment of callee context. 0. Else, a note, a separate environment record is needed to ensure that bindings created by direct eval calls in the formal parameter list are outside the environment where parameters are declared. B let callee env be the lexical environment of callee context. C let env be new declarative environment. Callee env. D assert. The variable environment of callee context is callee env. E set the lexical environment of callee context to env. 1. For each string param name of parameter names, do a let already declared benv has binding. Param name, b note. Early errors ensure that duplicate parameter names can only occur in non-strict functions that do not have parameter default values or rest parameters. See if already declared is false. Then I perform env create mutable binding. Param name, false. 2. If his duplicates is true, then perform env initialize binding. Param name, undefined 22. If arguments object needed is true, then if strict is true or simple parameter list is false, then I let AOB create and mapped arguments object arguments list. B else, I note, a mapped argument object is only provided for non-strict functions that don't have a rest parameter, any parameter default value initializers, or any destructured parameters. 2. Let AOB create mapped arguments object func formals arguments list env. See if strict is true, then I perform env create immutable binding arguments false. 2. Note, in strict mode code early errors prevent attempting to assign to this binding, so its mutability is not observable. D else I perform env create mutable binding arguments false. E perform env initialize binding arguments. O. F let parameter bindings be the list concatenation of parameter names and arguments. 3. Else a let parameter bindings be parameter names. 4. Let iterator record be create list iterator record arguments list. 5. If his duplicates is true, then I perform iterator binding initialization of formals with arguments iterator record and undefined 26. Else I perform iterator binding initialization of formals with arguments iterator record and env27. If his parameter expressions is false, then a note, only a single environment record is needed for the parameters and top-level vars. B let instantiated var names be a copy of the list parameter bindings. C for each element n of var names. Do I if instantiated var names does not contain n, then append n to instantiated var names. Perform env create mutable binding n false. Perform env initialize binding n undefined. D let var env be env28. Else a note, a separate environment record is needed to ensure that closures created by expressions in the formal parameter list do not have visibility of declarations in the function body. B let var env be new declarative environment env. C set the variable environment of callee context to var env. D let instantiated var names be a new empty list. E for each element n of var names. Do I if instantiated var names does not contain n, then ECMA International 2024 183 1. Append n to instantiated var names. Perform var env create mutable binding n false. If parameter bindings does not contain n, or if function names contains n, then a let initial value be undefined 4. Else a let initial value be env get binding value n false. Perform var env initialize binding n initial value. Note, a var with the same name as a formal parameter initially has the same value as the corresponding initialized parameter. 9. Note, an xb 3 2 1 adds additional steps at this point. 0. If strict is false, then a let lexi env be new declarative environment var env. B note, Non-strict functions use a separate environment record for top-level lexical declarations so that a direct eval can determine whether any var scope declarations introduced by the eval code conflict with pre-existing top-level lexically scoped declarations. This is not needed for strict functions because a strict direct eval always places all declarations into a new environment record. 1. Else, a let lexi_env be var_env. 2. Set the lexical environment of callee context to lexi_env. 3. Let lex declarations be the lexically scoped declarations of code. 4. For each element d of lex declarations, do a note. A lexically declared name cannot be the same as a function generator declaration, formal parameter, or a var name. Lexically declared names are only instantiated here but not initialized. B for each element dn of the bound names of d, do I if this constant declaration of d is true, then perform lexi_env create immutable binding. dn, true 2. Else perform lexi_env create mutable binding. dn, false 5. Let private env be the private environment of callee context. 6. For each parse node f of functions to initialize, do a let fn be the sole element of the bound names of f. B let fo be instantiate function object of f with arguments lexi_env and private env. C perform var_env set mutable binding. fn, fo, false 7. Return unused. 0.3 Built-in function objects. A built-in function object is an ordinary object. It must satisfy the requirements for ordinary objects set out in 10.1. In addition to the internal slots required of every ordinary object, see 10.1, a built-in function object must also have the following internal slots: a realm record that represents the realm in which the function was created, a string that is the initial name of the function. It is used by 20, 2, 3, 5. The initial value of a built-in function object's internal slot is %function prototype %, unless otherwise specified. A built-in function object must have an internal method that conforms to the definition in 1.0.3.1. A built-in function object has an internal method if and only if it is described as a constructor, or some algorithm in this specification explicitly sets its int runout method. Such an internal method must conform to the definition in 1.0.3.2. An implementation may provide additional built-in function objects that are not defined in this specification. Note 2b. 3.2 provides an extension to the above algorithm that is necessary for backwards compatibility with web browser implementations of ECMAScript that predate ECMAScript 2015. 84. Copyright sign, ECMA International 2024. 1.0.3.1. This arguments list. The internal method of a built-in function object f takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called: return, built-in call or construct, f, this arguments list, undefined 1.0.3.2, arguments list, new target. The internal method of a built-in function object f, when the method is present, takes arguments list, a list of ECMAScript language values, and new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called: return, built-in call or construct, f, uninitialized, arguments list, new target 1.0.3.3 built-in call or construct, f, this arguments list, new target. The abstract operation built-in call or construct takes arguments f, a built-in function object, this argument, an ECMAScript language value or uninitialized, arguments list, a list of ECMAScript language values, and new target, a constructor or undefined, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called: let caller context be the running execution context. If caller context is not already suspended, Suspend caller context. Let callee context be a new execution context. Set the function of callee context to f. Let callee realm be f. Set the realm of callee context to callee realm. Set the script or module of callee context to null. Perform any necessary implementation defined initialization of callee context. Push callee context onto the execution context stack. Callee context is now the running execution context. 0. Let result be the completion record, that is the result of evaluating f in a manner that conforms to the specification of f if this argument is uninitialized. This value is uninitialized. Otherwise, this argument provides the this value arguments list provides the named parameters new target provides the new target value. 1. Note: if f is defined in this document, the specification of f is the behavior specified for it via algorithm steps or other means. 2. Remove callee context from the execution context stack and restore caller context as the running execution context. 3. Return result. 0. 3. 4. Create built-in function, behavior, length, name, additional internal slots list, realm, prototype, prefix. The abstract operation create built-in function takes arguments behavior, an abstract closure, a set of algorithm steps, or some other definition of a function's behavior provided in this specification, length, a non-negative integer or plus, name, a property key or a private name, and additional internal slots list, a list of names of internal slots, and optional arguments realm, a realm record, prototype, an object or null, and prefix, a string. And returns a function object. Additional internal slots list contains the names of additional internal slots that must. Note: when callee context is removed from the execution context stack, it must not be destroyed if it has been suspended and retained by an accessible generator for later resumption. ECMA International 2024 185 be defined as part of the object. This operation creates a built-in function object. It performs the following steps when called. If realm is not present, set realm to the current realm record. If prototype is not present, set prototype to realm. Let internal slots list be a list containing the names of all the internal slots that 10.3 requires for the built-in function object that is about to be created. Append to internal slots list the elements of additional internal slots list. Let func be a new built-in function object that, when called, performs the action described by behavior, using the provided arguments as the values of the corresponding parameters specified by behavior. The new function object has internal slots whose names are the elements of internal slots list, and an internal slot. Set func to prototype, set func to true, set func to realm, set func to null. 0. Perform set function length, func, length 1. If prefix is not present, then a perform set function name, func, name 12. Else a perform set function name, func, name, prefix 13. Return func. Each built-in function defined in this specification is created by calling the create built-in function abstract operation. 0.4 Built-in exotic object internal methods and slots. This specification defines several kinds of built-in exotic objects. These objects generally behave similar to ordinary objects except for a few specific situations. The following exotic objects use the ordinary object internal methods except where it is explicitly specified otherwise below. 0. 4. 1 Bound function exotic objects. A bound function exotic object is an exotic object that wraps another function object. A bound function exotic object is callable. It has an internal method and may have an internal method. Calling a bound function exotic object generally results in a call of its wrapped function. An object is a bound function exotic object if its and, if applicable, struct internal methods use the following implementations, and its other essential internal methods use the definitions found in 10.1. These methods are installed in bound function create. Bound function exotic objects do not have the internal slots of ECMA script function objects listed in Table 30. Instead, they have the internal slots listed in Table 31, in addition to and Table 31, Internal slots of bound function exotic objects. Internal slot. Type. Description. Bound target function. A callable object. The wrapped function object. Bound this. An ECMA script language value. The value that is always passed as this value when calling the wrapped function. Bound arguments. A list of ECMA script language values. A list of values whose elements are used as the first arguments to any call to the wrapped function. 186. ECMA International 2024 10411. This arguments list. The internal method of a bound function exotic object f takes arguments this argument, an ECMA script language value, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called. Let target be f, let bound this be f, let bound args be f, let args be the list concatenation of bound args and arguments list. Return. Call. Target. Bound this. Args 0, 4, 1, 2. Arguments list. New target. The internal method of a bound function exotic object f takes arguments list, a list of ECMA script language values, a new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let target be f, assert, is constructor, target, is true. Let bound args be f, let args be the list concatenation of bound args and arguments list. If same value, f, new target, is true, set new target to target. Return. Construct, target, args, new target 0, 4, 1, 3. Bound function create, target function, bound this, bound args. The abstract operation bound function create takes arguments target function, a function object, bound this, an ECMA script language value, and bound args, a list of ECMA script language values, and returns either a normal completion containing a function object or a throw completion. It is used to specify the creation of new bound function exotic objects. It performs the following steps when called. Let proto be target function. Let internal slots list be the list concatenation of, and the internal slots listed in table 31. Let obj be make basic object. Internal slots list. Set obj to proto. Set obj as described in 10411. If this constructor, target function, is true, then a set obj as described in 10412. Set obj to target function. Set obj to bound this. Set obj to bound args 0. Return obj 0, 4. To array exotic objects. An array is an exotic object that gives special treatment to array index property keys, C6, 1, 7. A property whose property name is an array index is also called an element. Every array has a non-configurable length property whose value is always a non-negative integral number whose mathematical value is strictly less than 32. The value of the length property is numerically greater than the name of every known property whose name is an array index, whenever a known property of an array is created or changed. Other properties are adjusted as necessary to maintain this invariant. Specifically, whenever a known property is added whose name is an array index, the value of the length property is changed, if necessary, to be one more than the numeric value of that array index. And whenever the value of the length property is changed, every own property whose name is an array index whose value is not smaller than the new length is deleted. This constraint applies only to own. ECMA International 2024 187. Properties of an array and is unaffected by length or array index properties that may be inherited from its prototypes. An object is an array exotic object, or simply, an array, if its internal method uses the following implementation, and its other essential internal methods use the definitions found in 10.1. These methods are installed in array create 0, 4, 2, 1, p, desc. The internal method of an array exotic object takes arguments p, a property key, and desc, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If p is length, then a return. Array set length, a, desk. Else if P is an array index, then a let length desk be ordinary get own property, A, length, B assert, is data descriptor, length desk, is true, C assert, length desk is false, D let length be length desk, E assert, length is a non-negative integral number, F let index B, 32, P, G if index length and length desk is false, return false, H let succeeded B, ordinary define own property, A, P, desk, I have succeeded is false, return false, J if index length, then I set length desk index plus 1, 2, set succeeded to, ordinary define own property, A, length, length desk, 3, assert, succeeded is true, K return true, return, ordinary define own property, A, P, desk, 0, 4, 2, to array create, length, proto, the abstract operation array create takes argument length, a non-negative integer, and optional argument proto an object, and returns either a norm, our completion containing an array exotic object or a throw completion. It is used to specify the creation of new arrays. It performs the following steps when called. If length, 232 1, throw a range error exception. If proto is not present, set proto to %array prototype %. Let A be make basic object. Set A to proto. Set A is specified in 1 0, 4, 2, 1. Perform. Ordinary define own property, A, length, property descriptor, length, true, false, false. Return A, 0, 4, 2, 3. Array species create, original array, length. The abstract operation array species create takes arguments original array, an object, and length, a non-negative integer, and returns either a normal completion containing an object or a throw completion. It is used to specify the creation of a new array or similar object using a constructor function that is derived from original array. It does not enforce that the constructor function returns an array. It performs the following steps when called. Let is array be is array, original array. If is array is false, return array create, length. Let C be get, original array, constructor. If is constructor, C, is true, then 88. ECMA International 2024. A let this realm be the current realm record. B let realm be get function realm, C. See if this realm and realm are not the same realm record. Then I have same value, C. Realm is true. Set C to undefined. If C is an object, then I set C to get C at species. B if C is null, set C to undefined. If C is undefined, return array create, length. If this constructor, C, is false, throw a type error exception. Return construct, C, length, 0, 4, 2, 4. Array set length, A, desk. The abstract operation array set length takes arguments A, an array, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If desk does not have a field, then a return. Ordinary define own property, A, length, desk. Let new len desk be a copy of desk. Let new len be 32, desk. Let number len be to number, desk. If same value 0, new len, number len, is false. Throw a range error exception. Set new len desk to new len. Let old len desk be ordinary get own property, A, length. Assert is data descriptor. Old len desk is true. Assert old len desk is false. 0. Let old len be old len desk. 1. If new len old len, then a return. Ordinary define own property, A, length, new len desk. 2. If old len desk is false, return false. 3. If new len desk does not have a field or new len desk is true, then a let new writable be true. 4. Else a note setting the attribute to false is deferred in case any elements cannot be deleted. B let new writable be false. C set new len desk to true. 5. Let succeeded be ordinary define own property, A, length, new len desk. 6. If succeeded is false, return false. 7. For each own property key P of a such that P is an array index and 32 P new len in descending numeric index order. Do a let delete succeeded B. A P B if delete succeeded is false. Then I set new len desk to 32 P plus 1 2. If new writable is false, set new len desk to false. 3. Perform ordinary define own property A length new len desk I've return false. 8. If new writable is false, then assert succeeded to ordinary define own property A length property descriptor false. B assert succeeded is true. 9. Return true. Note if original array was created using the standard built-in array constructor for a realm that is not the realm of the running execution context, then a new array is created using the realm of the running execution context. This maintains compatibility with web browsers that have historically had that behavior for the array prototype methods that now are defined using array species create. ECMA International 2024 189. Note, in steps 3 and 4, if desk is an object then its value of method is called twice. This is legacy behavior that was specified with this effect starting with the second edition of this specification. 0, 4, 3 string exotic objects. A string object is an exotic object that encapsulates a string value and exposes virtual integer index data properties corresponding to the individual code unit elements of the string value. String exotic objects always have a data property named length whose value is the length of the encapsulated string value. Both the code unit data properties and the length property are non-writable and non-configurable. An object is a string exotic object, or simply, a string object, if its and internal methods use the following implementations, and its other essential internal methods use the definitions found in 10.1. These methods are installed in string create. String exotic objects have the same internal slots as ordinary objects. They also have an internal slot 1 0, 4, 3, 1. P. The internal method of a string exotic object S takes argument P, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Let desk be ordinary get own property S. P. If desk is not undefined, return desk. Return string get own property S. P. 0, 4, 3, 2. P. Desk. The internal method of a string exotic object S takes arguments P, a property key, and desk, a property descriptor, and returns a normal completio N containing a boolean. It performs the following steps when called. Let string desk be string get own property S. P. If string desk is not undefined, then a let extensible be S. P return is compatible property descriptor, extensible, desk, string desk, return. Ordinary define own property S. P. Desk 0, 4, 3, 3. The internal method of a string exotic object O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let keys be a new empty list. Let str be O, assert. Str is a string. Let len be the length of str for each integer I such that 0 len, in ascending order. Do a append to string I to keys for each own property key P of O such that P is an array index and to an integer or infinity P len in ascending numeric index order. Do a append P to keys for each own property key P of O such that P is a string and P is not an array index. In ascending chronological order of property creation, do a append P to keys. 90. ECMA International 2024. 8. For each own property key P of O such that P is a symbol. In ascending chronological order of property creation, do a append P to keys. 9. Return keys 0, 4, 3, 4 string create. Value. Prototype. The abstract operation string create takes arguments value, a string, and prototype, an object, and returns a string exotic object. It is used to specify the creation of new string exotic objects. It performs the following steps when called. Let S be make basic object. Set S to prototype. Set S to value. Set S as specified in 1 0 4 3 1. Set S as specified in 1 0 4 3 2. Set S as specified in 1 0 4 3 3. Let length be the length of value. Perform. Define property or throw S length. Property descriptor length. False. Enumerable. False. False. Return S 0 4 3 5. String get own property S P. The abstract operation string get own property takes arguments S, an object that has an internal slot, and P, a property key, and returns a property descriptor or undefined. It performs the following steps when called. If P is not a string, return undefined. Let index be canonical numeric index string P. If index is undefined, return undefined. If is integral number int x is false, return undefined. If index is -0, return undefined. Let str be s. Assert str is a string. Let len be the length of str. If r int x 0 or len r int x, return undefined 0. Let result str be the substring of str from r int x to r index +1 1. Return the property descriptor result str false true false 0 4. 4 arguments exotic objects. Most ECMA script functions make an arguments object available to their code. Depending upon the characteristics of the function definition, its arguments object is either an ordinary object or an arguments exotic object. An arguments exotic object is an exotic object whose array index properties map to the formal parameters bindings of an invocation of its associated ECMA script function. An object is an arguments exotic object if its internal methods use the following implementations, with the ones not specified here using those found in 10.1. These methods are installed and create mapped arguments object. Arguments exotic objects have the same internal slots as ordinary objects. They also have an internal slot. Ordinary arguments objects also have an internal slot whose value is always undefined. For ordinary argument objects, the internal slot is only used by object prototype to string 2 0 1 3 6 to identify them as such. Note 1. While creating mapped arguments object is grouped into this clause, it creates an ordinary object, not an arguments exotic object. ECMA International 2024 191. Note 2. The integer index data properties of an arguments exotic object whose numeric name values are less than the number of formal parameters of the corresponding function object initially share their values with the corresponding argument bindings in the function's execution context. This means that changing the property changes the corresponding value of the argument binding and vice versa. This correspondence is broken if such a property is deleted and then redefined, or if the property is changed into an accessor property. If the arguments object is an ordinary object, the values of its properties are simply a copy of the arguments passed to the function, and there is no dynamic linkage between the property values and the formal parameter values. Note 3. The parameter map object and its property values are used as a device for specifying the arguments object correspondence to argument bindings. The parameter map object and the objects that are the values of its properties are not directly observable from ECMA script code. An ECMA script implementation does not need to actually create or use such objects to implement the specified semantics. Note: for ordinary arguments, objects define a non-configurable accessor property named callee, which throws a type error exception on access. The callee property has a more specific meaning for arguments exotic objects, which are created only for some class of non-strict functions. The definition of this property in the ordinary variant exists to ensure that it is not defined in any other manner by conforming ECMA script implementations. Note: 5 ECMA script implementations of arguments exotic objects have historically contained an accessor property named caller. Prior to ECMA script 2017, the specification included the definition of a throwing caller property on ordinary arguments objects. Since implementations do not contain this extension any longer, ECMA script 2017 dropped the requirement for a throwing caller accessor. 0. 4, 4, 1. P. The internal method of an argument's exotic object args takes argument P, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Let desc be ordinary get own property, args, P. If desc is undefined, return undefined. Let map be args, let is mapped be. Has own property, map, P. If is mapped is true, then A set desc to. Get, map, P6. Return desc 0, 4, 4, 2. P. Desc. The internal method of an argument's exotic object args takes arguments P, a property key, and desc, a property descriptor, and returns a normal completion containing a boolean. It performs the following steps when called. Let map be args, let is mapped be. Has own property, map, P. Let new arg desc be desc. If is mapped is true and is data descriptor, desc, is true. Then, if desc does not have a field, desc has a field, and desc is false, then I set new arg desc to a copy of desc 2. Set new arg desc to. Get, map, P. Let allowed be. Ordinary define own property, args, P. New arg desc 92. ECMA International 2024 6. If allowed is false, return false. If is mapped is true, then if is accessor descriptor, desc, is true, then I perform map, P. Be else. If desc has a field, then assert. The following set will succeed. Since formal parameters mapped by arguments, objects are always writable. Perform. Set. Map. P. Desc. False. 2. If desc has a field and desc is false, then perform map, P8. Return true. 0, 4, 4, 3. The let map be args, let is mapped be. Has own property, map, P. If is mapped is false, then a return. Ordinary get, args, P. Receiver 4. Else, a assert. Map contains a formal parameter mapping for P. P return. Get, map, P. 0, 4, 4, 4. The if same value, args, receiver, is false, then a let is mapped be false. L. Se a let map be args, B let is mapped be. Has own property, map, P. If is mapped is true, then a assert. The following set will succeed. Since formal parameters mapped by arguments, objects are always writable. B perform. Set. Map. P. V. False. Return. Ordinary set. Args. P. V. Receiver. 0, 4, 4, 5. P. The internal method of an argument's exotic object args takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let map be args, let is mapped be. Has own property, map, P. Let result be. Ordinary delete, args, P. If result is true and is mapped is true, then a perform map, P5. Return result. ECMA International 2024 193 10 4 4 6. Create and mapped arguments object arguments list. The abstract operation create and mapped arguments object takes arguments list, a list of ECMA script language values, and returns an ordinary object. It performs the following steps when called. Let len be the number of elements in arguments list. Let obj be ordinary object create. %object prototype %. Set obj to undefined. Perform. Define property or throw. Obj. Length. Property descriptor. Len. True. Enumerable. False. True. Let index be 0. Repeat. While index. Len. A let val be arguments list. Index. Be perform. Create data property or throw. Obj. To string. Index. Val. C set index to index +1. Perform. Define property or throw. Obj. At iterator. Property descriptor. %array prototype values %. True. False. True. Perform. Define property or throw. Obj. Callee. Property descriptor. %throw type error %. False. False. Return obj. 0, 4, 4, 7 create mapped arguments object, func, formals, arguments list, env. The abstract operation create mapped arguments object takes arguments func, an object, formals, a parse node, arguments list, a list of ECMA script language values, and env, an environment record, and returns an arguments exotic object. It performs the following steps when called. Assert. Formals does not contain a rest parameter, any binding patterns, or any initializers. It may contain duplicate identifiers. Let len be the number of elements in arguments list. Let obj be make basic object. Set obj is specified in 1 0, 4, 4, 1. Set obj is specified in 1 0, 4, 4, 2. Set obj is specified in 1 0, 4, 4, 5. Set obj to %object prototype %0. Let map be ordinary object create, null 1. Set obj map to map 2. Let parameter names be the bound names of formals 3. Let number of parameters be the number of elements in parameter names 4. Let index be 0, 5. Repeat. While index, len, let val be arguments list. Index be perform. Create data property or throw, obj. To string, index, val, c set index to index plus 1, 6. Perform. Define property or throw, obj, length, property descriptor, len, true, false, true 7. Let map names be a new empty list 8. Set index to number of parameters 1, 9. Repeat. While index 0, 94. ECMA International 2024. A, B, C. Let name be parameter names. Index. If map names does not contain name, then I append name to map names 2. If index, len, then let G be make arg getter, name, env. Let P be make arg setter, name, env. Perform map. To string, index, property descriptor get, G, false, true. Set index to index 1, 20. Perform. Define property or throw, obj, at iterator, property descriptor, %array prototype values %, true, false, true 1. Perform. Define property or throw, obj, callee, property descriptor, func, true, false, true 2. Return obj 0, 4, 4, 7, 1 make arg getter, name, env. The abstract operation make arg getter takes arguments name, a string, and env, an environment record, and returns a function object. It creates a built-in function object that when executed returns the value bound for name and env. It performs the following steps when called. Let getClosure be a new abstract closure with no parameters that captures name and env and performs the following steps when called. A return env get binding value, name, false. Let getter be create built-in function, getClosure, 0. Note, getter is never directly accessible to ECMA script code. Return getter, 0, 4, 4, 7, to make arg setter, name, env. The abstract operation make arg setter takes arguments name, a string, and env, an environment record, and returns a function object. It creates a built-in function object that when executed sets the value bound for name and env. It performs the following steps when called. Let setClosure be a new abstract closure with parameters, value, that captures name and env and performs the following steps when called. A return env set mutable binding, name, value, false. Let setter be create built-in function, setClosure, 1. Note, setter is never directly accessible to ECMA script code. Return setter, 0, 4, 5 typed array exotic objects. A typed array is an exotic object that performs special handling of integer index property keys. Typed arrays have the same internal slots as ordinary objects and additionally length, set, and internal slots. An object is a typed array if its and internal methods use the definitions in this section, and its other essential internal methods use the definitions found in 10.1. These methods are installed by typed array create 0, 4, 5, 1. P. The internal method of a typed array O takes argument P, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. If P is a string, then a let numeric index be canonical numeric index string P be if numeric index is not undefined. Then I let value be typed array get element. Oh, numeric index 2. If value is undefined, return undefined. 3. Return the property descriptor value true, true, true. Return ordinary get own property. O. P. ECMA International 2024 195 10 4 5 2. P. The internal method of a typed array O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If P is a string, then a let numeric index be canonical numeric index string P be if numeric index is not undefined. Return as valid integer index. O. Numeric index. Return. Ordinary has property O. P 0, 4, 5, 3. P. Desc. The internal method of a typed array O takes arguments P, a property key, and desc, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If P is a string, then a let numeric index be canonical numeric index string P be if numeric index is not undefined. Then if as valid integer index O. Numeric index is false, return false. 2. If desc has a field and desc is false, return false. 3. If desc has an field and desc is false, return false. 5. If as accessor descriptor desc is true, return false. V. If desc has a field and desc is false, return false. V. If desc has a field, perform typed array set element. Oh, numeric index desc 7. Return true. Return ordinary define own property O. P. Desc 0, 4, 5, 4. The. If P is a string, then a let numeric index be canonical numeric index string P be if numeric index is not undefined. Then I return typed array get element. Oh, numeric index 2. Return ordinary get O. P. Receiver 0, 4, 5, 5. The. If P is a string, then a let numeric index be canonical numeric index string P be if numeric index is not undefined. Then if same value O. Receiver is true, then perform typed array set element. Oh, numeric index V. Return true. 2. If as valid integer index O. Numeric index is false, return true. Return ordinary set O. P. V. Receiver 96. ECMA International 2024 10 4 5 6. P. The internal method of a typed array O takes argument P, a property key, and returns a normal completion containing a boolean. It performs the following steps when called. If P is a string, then a let numeric index be canonical numeric index string P be if numeric index is not undefined. Then if as valid integer index O. Numeric index is false, return true, else return false. 2. Return ordinary delete O. P 0, 4, 5, 7. The internal method of a typed array O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let tar record be capital M, A, K, E, capital T, Y, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, O, sexy ST. Let keys be a new empty list. If it's typed array out of bounds, tar record is false, Then, a let length be typed array length. tar record be for each integer I such that 0 length. In ascending order. Do I append to string I to keys for each own property key p of O such that p is a string and p is not an integer index. In ascending chronological order of property creation. Do I append p to keys for each own property key p of O such that p is a symbol. In ascending chronological order of property creation. Do I append p to keys 6. Return keys 0, 4, 5, 8.
There's a bunch of places, whatever,
Typed array with buffer witness record is
where
encapsulated typed array along with a cached byte length of the viewed buffer.
I use unsigned. I tag it the literal immediate hexadecimal value, whatever, as unsigned.
Witness records have the fields listed in table 32. 32. Typed array with buffer witness record fields 0, 4, 5, 9. Capital M,
And if I have to define these two,
capital T,
like extra unsigned define,
D, capital A,
for all of these, that's just even more to define
Y,
and more to go through and find and replace.
E, A,
So I don't want to do that if I don't have to.
U, F, F, E, capital
But I used unsigned because I needed unsigned
E, S, O, B, J,
because there's places where the arithmetic breaks when it's assigned value.
A, E, capital T,
So I'm going to ask Chatbot if this chunk of code, whatever,
A, R, R, A, Y, capital W, I,
when if I make these unsigned,
U, F, F,
so they're signed by default, whatever,
W, I, T, N, E, S. Arguments OBJ, a typed array, and order, sex.
there's a lot of them, dang it.
Typed array with
I'm going to have to define duplicates of every fucking thing.
let buffer,
Fuck.
buffer.
If I'm asking Chatbot, this is so fucking boring. I'm going to have to replace so much shit. So, I'm asking Chatbot if it'll do the same thing.
Raw detached, the byte length of the object.
I have a feeling it won't.
Copyright sign.
But Chatbot would know because Chatbot, like, he's supposed to be super smart. And it's going to replace people's jobs apparently. So, let's see what Chatbot really knows.
Buffer witness record.
I don't know what Chatbot. Yeah. I'm not going to trust Chatbot anyways.
Prototype.
I need to stop stalling and get on track. This is just so tedious.
Ray. It is used.
I freaking hate this. I want to be on the standard. Actually writing new code, not updating code to 64-bit. It's not even real 64-bit. Which is what, I don't know. I hate. It's so fake. It's not even real 64-bit. I'm going to rewrite this whole program for a fake ass, not even legit 64-bit CPU. That's a whole lot of dedication for a fake 64-bit CPU. Like AMD and Intel, they need to release a true, not even 64-bit, go to 128-bit, a true 128-bit CPU. That shouldn't be too much to ask for.
It performs.
That'd be awesome. But no, you got fake 64-bit.
True. Return 0.
Freaking this Ryzen C2 Go. 4 cores, 8 threads.
Element size be type.
It's 2025.
Element size 0.
This is a 15-year-old computer, Intel i7, first generation.
Argument tar record. A typed array with buffer witness record and returns a non-negative integer. It performs the following steps when called. Assert. Is typed array out of bounds. Tar record. Is false. Let O be tar record. If O is not auto, return no. Assert.
860, 2.88 gigahertz.
is false. Let byte offset be O. Let element size be typed array element size. O. Let byte length be
So this thing is the same exact thing, but it's just clocked up a little bit higher.
byte offset element size.
4 cores, 8 threads.
1.3 is typed array out of bounds. tar record.
This 15-year-old computer has 4 cores, 8 logical processors. Does that mean threads?
Record and returns a bool.
Are threads the same thing as logical processors? What even?
The underlying buffer's bounds. It performs
Anyways, this computer has 10 megabytes of cache.
buffer byte length be tar record 98. ECMA International 2024. 3.
I mean 8. Only 8.
Buffer O is true if and only if buffer byte length is detached. If buffer byte length is detached, return true. Let byte offset start BO. If O is auto, then a let byte offset.
Because it's from 15 years ago, I'm designing on this potato. This is a potato computer. Because anything that runs on a first generation i7 is going to run on any fake 64-bit i7 based CPU, whatever you call it, simulated software driven OS, fake ass, not really 64-bit CPU. So like at least this modern 2025 CPU has 10 megabytes of cache. Whoop-de-doo. 15 years ago, 8 megabytes was like the big whoop. Whoop. So, I don't know. It's not very impressive. This is more impressive than ARM. That's impressive though. The fact that they're able to get something this old or whatever, running this small and efficiently. I like how they say balance between performance and power efficiency. They gotta throw that in there to compete with AMD. I mean, not AMD, they are AMD. To compete with ARM. Because ARM's like, oh, we're super battery efficient and stuff. Look at we're ARM. We're super tiny. We're super cool. I don't know. At least AMD is competing with ARM instead of joining them. Actually, I think they joined ARM. So whatever. I need to get on track. But this thing is probably gonna be a potato. Maybe like 2 potatoes. Like twice as fast as a 15-year-old computer with like 2 megabytes more cache. But still, it's a potato. Potato, potato, the same thing. So, I'm asking chatbot, if I get rid of the U, I don't think I can. But if I can, it will save me several passes of going through this program again and again and again. So I'm hoping chatbot will say it's fine to remove the U after the mask, that it won't affect the arithmetic or whatever. But it probably will. So asking chatbot, please, 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 please say no. Say it's fine. Please. Pretty please. Oh, what kind of answer is that? How is that helpful at all?
May still produce. May still produce. Same result most of the time. B. But it is not guaranteed to always compute the exact same result, especially in edge cases or on different compilers' platforms.
I want a yes or a no. Oh man. I'm tired of this shit. This is gonna take forever. I hate freaking finding the fucking bit mask. God damn it. I gotta go so slowly to not mess it up. Because the mask is like tied to the rest of the number. I gotta figure out. My eyes are gonna burn out from staring at the freaking screen so closely. And I can't even zoom in because then you'll see the code. So I gotta stay zoomed out. Why am I streaming this? It's making my life 1,000 times more difficult. I can't just zoom in. I gotta like freaking put my eyeballs on the freaking screen. It sucks. I can't stop streaming. I already started. I gotta finish what I started. So chatbot is not helpful at all. It should be able to give me a definite yes or no. Because it is technically going to run a compiler behind the scenes to generate the output and then give me a result. But it didn't even do that. Instead it's like giving me a bunch of maybes, which isn't helpful at all. Because they already know that. I wish chatbot would tell me something I don't know, that I can't look up, something that I can't learn in a book or documentation. But chatbot's not human and it's not creative, so I'm not gonna get that, I guess.
Yes, replacing the U suffixes with no suffix, that is, removing the U, in that macro may still produce the same result most of the time, but it is not guaranteed to always compute the exact same result, especially in edge cases or on different compilers' platforms. Let's break down what happens. The original macro, see copy edit define x macro, arg1 and 0 times 0 foo, 0x or 0 times 0 7u 0 times 0 1u, 0s foo and 0 times 0 9u. All constants have the u suffix, so they are treated as unsigned integers. If you remove the u suffixes, see copy edit define x macro, arg1 and 0 times 0f, 0s are 0 times 07, 0 times 01, 0xff and 0 times 09. Now the constants are signed integers by default, of type int, unless the value is too large for int. Key considerations 1. Bitwise shifts and signed types, shifting a negative int, for example, after -zeros are, can lead to undefined behavior, depending on the value and shift amount. 2. Integer promotions. When you mix signed and unsigned values in expressions, C promotes them following specific rules, for example, the usual arithmetic conversions. This can cause sign extension, unexpected results in bitwise operations, compiler-specific behavior. 3. Literal type differences. 0xff as int is 255. 0's foo as unsigned int is also 255, but -0xff as signed is -255. If you cast -0's foo, it becomes a larger unsigned value like 4,294,967,041 on a 32-bit system. Example difference, C copy edit int result equals 0 times 0f and 0 times 0f, zeros are 0 times 07, 0 times 01, 0xff and 0 times 09. This becomes C copy edit int result equals 0xf, zeros are 7 circumflex 1, 255, and 0 times 09 equals 3, 7, 1. Example difference,
It said 0 circumflex? What's a circumflex?
zero circumflex 1, 0 circumflex 1, 0 circumflex 1, 0 circumflex 1.
What's it saying? Circumflex? Is it saying circumference?
0 circumflex 1.
It's definitely saying flex. I don't even know.
In contrast, using U suffixes, unsigned int result equals 0xf, zeros are 7, 1u, 255u and 9u. Safe unsigned arithmetic throughout.
But that's not even true. Chatbot is so dumb.
The result, let's say this instead. Will this be okay? If it were like this, define x macro, arg1, long, arg1 and 0 times 0 foo, 0x or 0 times 0 7u, 0 times 0 1u, zeros foo and 0 times 0 9u. Good follow-up, wrapping the entire expression in a caster, long, after the expression doesn't fix the underlying potential issues if the sub-expression misbehaves due to mixed signed and signed arithmetic. Let's walk through this with precision. In C, what is the signage of this result? And will the value be the same? 0xff 0 times 0 foo versus 0xff 0 times 0f. Great question. This dives right into C's integer constant types and arithmetic promotion rules. Let's break it down.
Now I'm going to try this in an online compiler. Why isn't the compiler complaining? Usually, the compiler complains about the sign of the type, and I can return unsigned as a long, I guess. Unless why is it not throwing an error? Stupid shit. Okay, place this inside of one of the files. The speed test files, whatever, it doesn't matter. But I'm gonna see if it compiles. Click run, or compile, whatever. Build clean solution. Because Microsoft is a bunch of computer programmers with Microsofties, so you gotta clean the solution. So it's building. Wait, is there a new error? So that wasn't an error then. And was that an error earlier? Did something get messed up? So now I'm setting this temp result t whatever to -1. see if this will throw an error. Because it's a signed number, it's supposed to throw an error. This takes so long to build. Why is there no error? Usually, it bitches and complains when I have a negative number. So now it's like an actual error. Now it's still built. This isn't even being included. That's great. This is why I wanted chatbot to give me an answer, so I wouldn't have to do it. But I gotta look it up. Now paste this in main. It should enter here. And then this redefine. Now I updated this one and the other one, so they both look the same, to see if it'll throw the error. Because I think it was defined twice on accident, and I didn't see it or notice it was an error, because it was defined twice, but it's defined twice to the same thing. But now that I changed one of them to use a ZXN, I updated one of them to use ZXN instead of 0xf, and I didn't update the other one, so now I updated the other one. So I want to see if this compiler warning, whatever, if it will go away or not. This one, previous definition. If it does, that's really annoying, because it means it's defined twice, but it doesn't throw an error, because it's the same thing. But when it's the same thing and defined twice, there's no error, because it's the same thing, but it should be an error, even though it's the same thing. I really hope it'll throw the warning again. If it does, then I'll just try like look for an issue, because something's wrong. If it doesn't throw an error, then something might also be wrong. So I have no idea I gotta check the last build, whatever, which luckily I can like rewind the stream and see what it said, because I haven't been paying attention to if it was changing the logout. But I think I would have noticed if it showed that warning, because it makes it like the text is like a bigger area space or whatever. So I hit save and everything, so I'm gonna run it. This isn't worth looking into. I should have just defined things with a U and then left it at that. Are you kidding me? No error. For fuck's sake. That's annoying as fuck. So now it's not throwing an error, because now they're both defined to the same exact thing. That is ridiculous. That should be considered an error. There's probably other places that happens. That's cool. That's just freaking great. This compiler is shit. And the C programming language is also shit. The only reason the C language exists, C language, it's a language, it's called C. The C language, the C programming language. A language is called C, a single letter, the letter C. That's what the language is called. The only reason that the C language exists is because no operating system has been able to make a safe, compliant, secure programming language that can run on top of the modern operating system without major impacts on performance. Apple has Swift, and it's slow. Microsoft tried C#, and that's really, really fucking slow. Microsoft claimed at one point that they were gonna like rewrite all of Windows in C# because C# is so amazing and .NET is so great. And then they didn't do it because it's not possible. Because C is such a low level compared to C#. It's not even possible. That is the only reason that C exists. But when a future operating system comes out, not a modern operating system, a futuristic operating system, when the futuristic operating system is released, C will be gone. Because there won't be a need for it. Be something better. I hate C. This freaking sucks. Anyways, and this, what I'm doing right now goes along the lines of I'm using chatbots, guesstimation of how many steps it would take to rewrite a C program from 32-bit to 64-bit. So, I am trying to do like step 1, 2. I didn't even get to code base analysis. I'm waiting till the end. I want to convert it first. Because if I look into it, figure everything out, I'm going to be like tempted to optimize and change things. So I need to like not touch or change only convert. Because if I start changing stuff, something could break and I wouldn't know till further down in the road. So we need to like, I don't know. I'm gonna wait on step 1, but I did step 2, finishing it up. As chatbot said, identify all 32-bit assumptions, type pointer size, bit masks. Then chatbot said modify data types, UN32 or 64 where needed. I have to get to that after I get the masks and stuff done. Fixed pointer arithmetic and tagged pointer logic for 64-bit addressing. I didn't get to that yet. Adjust bit masking and shifting for wider values. I didn't get to that yet either. I'm still just trying to like get all the masks tagged and then the shifts. So I'm on step 7, refactor macros and inline assembly. So I am refactoring macros right now. I have to jump ahead a few steps, then I'm gonna jump back, then I'm gonna jump ahead, then I'm gonna jump back. This didn't take forever. Going through the standard, the JavaScript standard, that's gonna take forever too. Freaking page 1 of 816. What the hell kind of chapter is called miscellaneous? It's like a kitchen drawer where you just throw shit in. That's literally what they did. Of course they have a chapter called miscellaneous. Because a chapter called miscellaneous, it fits very nicely and goes along in relation with the word leak, which is found on 2 pages of the 2025 JavaScript ECMA standard.
Is unlikely to be collected and could leak memory resources in implementations. Weak map and weak set are intended to provide mechanisms for dynamically associating state. Intended to provide mechanisms in a manner that does not leak memory resources. The following references describe mechanism that may be useful to implementations of weak map and weak set. Barry Hayes, 1997. 2008.
Why would they even cite that if they
Intended
to provide working mechanisms in a standard? Why would they have to state
The following references describe mechanism that may be useful to implementations of weak map and weak set.
why didn't they just read these documents from 1997 and 2008? If they're going to reference them, have they not read them? And if they read them, why wouldn't they have
Intended
to actually rewrite the standard so they wouldn't have to put
in a manner that does not leak memory resources. In the absence of the weak map or weak set instance, the object or symbol otherwise became inaccessible and subject to resource reclamation by the implementation's garbage collection mechanisms. Inaccessible.
So, I don't think they really
Intended.
much of anything when writing this standard. Especially if they have a category called miscellaneous. I gotta look at what's in that category, and then I gotta get back on track. So here. Oh, but what I was saying though is none of these steps are in order 1 to 10, converting a program from 32-bit to 64-bit. And this documentation doesn't look like it's in order either. The chapters are, but everything points to another thing, up, down, all over the freaking place. It's gonna suck. So I'm gonna like check what's in miscellaneous really quick.
Eight 8.6 Miscellaneous. These operations are used in multiple places throughout the specification.
Huh? Does that mean everything after 8.6, like 8.6.1, is considered miscellaneous? I don't know. I don't care. I'll figure this out later. I'm pretty sure that's what it means. But like the typography, the hierarchy of the text elements in this documentation, I don't know. Kind of sucks. I don't know. Whatever. I think it could have been organized better than this. This looks like they had a whole bunch of shit, had to throw it in a PDF. Oh, that's probably what they did. They literally just threw everything in a PDF. And they have like, whatever. It's a standard, I guess. A standard that has word leak in it.
Weak map is unlikely to be collected and could leak memory resources in implementations.
I'm pretty sure like any standard will like
Intended.
or tend to like intended. How do I make a sentence where intended fits in? I got it. I'm sure most compilers. No. I'm sure most standard writers. That won't work. Anyone writing a standard, most likely.
Intended.
To not provide mechanisms. There's a chipmunk outside. It's really noisy and a lot annoying. Anyways, it keeps freaking chirping. It's chirping like there's no tomorrow. Have you ever rescued a chipmunk? They're freaking insane. They just run around in circles and they get so damn excited and they won't calm the fuck down. And they go yip 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 yip. And then they want to play 24/7. And after like 10 minutes, they're like out. They're like done playing. And then 10 minutes later, they recharge and like, woo! And they're so clingy. Chipmunks are way more clingy than squirrels. Squirrels are also very clingy. I'm gonna get on track or whatever. But I was saying mechanisms. And I was distracted by the chipmunk. Whatever. I'm gonna stay focused. Okay, so after all that, my main goal here was I was getting to this here. I already copied this, I think, and I pasted it, so I gotta go back up here. I think I already copied this, whatever. Okay, so this is being included, which is good. That means it's running this code. But the double redefine, I have these defines, whatever. And I think I have if not defined right here. Because when I was originally writing this, I was going through the process of refactoring macros. 7 years ago when I wrote this. And when refactoring macros, because they have to be in a certain order, whatever, or it won't build, because the compiler makes you order things, because the compiler isn't capable of compiling and ordering things, because the compiler is set up for the convenience of compiling, not the person writing the code to pass into the compiler, which defeats the whole purpose of having a compiler. If the user has to reorganize every motherfucking thing, what purpose is the compiler if everything has to be organized for it? The compiler should be able to keep track and list and go back, check things, realign things, but it doesn't. Instead, it's on the user to order things top to bottom, and when they're not, the user has to like move things all over the fucking place. until the compiler goes, okay, everything's in order. So, at one point, I think this, whatever block this was in, was below this block, and it was throwing an error. So I did if define, if not defined, I would define it. And at some point, I must have needed those macros moved, and they ended up before the second definition. Because I was refactoring macros. Because the C compiler is not capable of refactoring macros or finding out the order they need to be in, or resolving the order, because the C compiler is shit. It was originally designed for really old computers, and it kind of makes sense to like have the user organize things in the order that they're used. But in 2025, at this point, freaking update it. But they didn't, so whatever. So, as you can see, they're both the same, except I already replaced ZXP. Oops, I gotta get rid of it here. So when I built it, it is like this, where these are 0x1. I hate this computer. I hate Windows. 0x1. When I replaced them with ZXP. Now it doesn't throw the redefinition error because now they're exactly the same. That's really annoying. So I probably have things somewhere else defined twice to the same thing, and then a pop-up or whatever. So now, since I refactored macros 7 years ago, when I originally wrote this, I'm gonna have to refactor macros again, most likely. But now that I know that this is defined here, before here, I can get rid of the second define, because it's exactly the same. And I'll be able to get rid of this, because now I know it's defined only once. Refactoring macros 101. I fucking hate this. This is such... I could actually be writing new code, but instead I'm maintaining old code. It'd take a year or two to rewrite, so I don't know. I'm between a rock and a hard place, so I gotta rewrite it. I gotta update it, not rewrite it from scratch. That would take way too long. So, I don't know. That's that. And then the original thing that I started on, that I got off track, and then off track, and several tracks, I'm back on track now. So, now it enters here, and what I want to know is the signedness of whatever. Because this compiler doesn't throw an error. The online compiler. When an unsigned is clearly assigned. When unsigned long is clearly being assigned to a signed long. It doesn't throw an error. So, usually the compiler bitches about it. It is not. So I'm trying to test it now to see if it'll bitch. So I'm gonna try to build it again because it stopped building because I want to see if it was building. So I put this error here to make it show up here if it's an error. And it takes 2 minutes to build, or 1.5 minutes each freaking time. So now I gotta wait 30-40 seconds for it to build again and see if this is an error. I could make a new project, but I don't remember how to. Any C programmer knows that once you make a C project, that's your C project. You never make a new one. You just always use the same fucking C project. And you turn things on or off. And when you do have a new project, you never merge it with the old one because it becomes a whole new project, literally a project, a separate project. And the process of merging two projects is very painful, very, very painful. And I'm going to have to do that very soon. After I parse this, get it from 32-bit to 64-bit, I'm going to have to merge in a memory manager that I spent last year writing. It took a whole fucking year. It was supposed to take 4 months, but it got really complicated. There's a whole bunch of shit to do. I gotta keep on track. I should have just freaking redefined with the little u for unsigned. Not wasted. I can't waste time looking into every little thing. It's not gonna save any time in the long run. So, now I'm gonna save, hit build, see if it throws an error. But I might need to make it this type. Okay, the type doesn't exist, so I had to find it to a real type, which I just copied over. I think it's a UN underscore or 32 underscore T. I don't remember. I like define my own types or whatever as it defines and then use that. Using like the words unsigned in, it's too much work to like find and replace. I already spent a week or two finding and replacing unsigned in and signed in. That took so long to do. It's better if we can define it to something and then use that everywhere. So you can do Control F and replace one place instead of all of them. So this is unsigned for when it's like questionable, meaning I put the Q there for this step in chatbots. Guesstimation how many steps it would take to write a 32 program as 64-bit. For the sake of identifying all 32-bit assumptions. I put a Q to indicate that it's questionable and I'm not sure if it's 32-bit or 64-bit. And I have other defines with the N for when it's a number, or an A when it's an address, or whatever. If you use signed, unsigned in, it's freaking hell to freaking find and replace and update. Because it's two separate words in a space. An int is the same between both of them. It's also standalone, where it's signed by default. That was really annoying to update the whole thing. But now I can use these, do Control F, and know nothing has the same name. So this is unsigned. So these are all unsigned. And they're real types because I have them defined here. So I'm gonna build it, and it should throw an error for this one because it's unsigned. It's being assigned to a signed value. And it's building. So it's doing the same thing as here. Except it's an int. Any minute now, whenever this wants to finish building, that'd be great. How? How was there no error? How? Seriously, how? What the fuck? I'm gonna cast it intentionally has assigned it. That has to do it. That'll do it. I do not get why it's not throwing an error. This is annoying. Okay, what about okay, so this is an error. Negative is 0x FFU.
Good catch. This line is not valid in a safe or portable way in C. Electric light bulb. Why this is confusing dangerous. You're using a negative sign on an unsigned literal, which is semantically weird and potentially misleading. Anyone reading that might expect TMP resd to hold something like -0xFF, which isn't representable in an unsigned int the way it's written. This is also non-portable if the size of unsigned int isn't 32 bits.
So, that's an error. Is this an error? unsigned in, negative, signed in. It's the same thing. Oh, I mean unsigned. So this is the same as this. And somehow both of these build in the online assembler. When they shouldn't. So Chepa says that's failed. So far, I haven't tripped up the compiler yet, at least, which is annoying because I thought those two examples would have did it. Tripped up the compiler, but it didn't. So now I'm gonna try this. Put this in front here. Make it unsigned. Make it 0xFFF. And then there's one bug that I gotta deal with that's really annoying. I didn't know was possible. I had to freaking comb through the whole damn program. When you initialize something like this, it doesn't check the sign. So, if something subtracts, it makes a negative value when it's supposed to be signed, or you don't want, like, if I do a right shift, it's treated as unsigned, even though, so like if I have unsigned variable, and I do over here whatever, this is a unsigned in. Called temp result day. If I do something like this, this is a 8, 16, 32-bit number. If I right shift 31, I'm pretty sure the result is going to be -1, which is all bit set. Because it doesn't matter if it's assigned to unsigned in. The right hand side is signed by default, even though the type is unsigned. And I gotta track this fucking possible bug down through a whole bunch of places in the program I wrote last year. I made a program for memory managing. I need some water, mouth is dry. For memory managing, and I thought I accounted for every possible thing. I made it really, really portable. And then like the last month or so, I found out that that happens because I ran into a spot where the number became negative, the sign bit was set, and did a shift, and it fucked everything up. And I found it right away though, because it's like right where it's working. And I was like, fuck. So I don't know. The only way to fix that is to go like this or whatever. It just like undid something. I hope I wasn't clicked in this folder. Dang it. This sign stuff is stupid. That's what I'm getting at. I need to like check this thing and get this done. all this stuff is ridiculous. It takes up so much freaking time. And I don't want to tell you the solution because you can figure it out yourself if you ever run into the bug and have fun with like working around this stupid shit. There's so many loopholes and weird little odd bugs with C, and then it's on Microsoft too. So like they have their own bugs, and all the compilers have their own bugs. I don't know. It's really unprofessional. So now I have. This is apparently okay. This should throw an error, and I think this will also throw an error. It should. Because it's signed, or it's not signed. In hexadecimal, it's like in an in-between state, but it's typically signed unless you put the U after it, the literal. So I'm gonna see if the compiler bitches about these. And it doesn't complain about these, which is weird. I thought it would have triggered some kind of like issue because it becomes negated, but I guess not. And it doesn't even solve my answer because I don't know if I need the little f or not. So I'm just gonna keep it because I don't want to keep investigating this. This is gonna be a waste of time. So now I'm back on track. This was my original tangent. I'm gonna hit rebuild, see what it does. And after my tangent, I'm gonna get back on course. Hurry up and build. Come on, this takes so long. Did it find the error or did it not? Give me a result. It's at the very top of main. How could it take this long? It's literally the main of the program. The main. It's at the freaking top inside of the block right here. How did it not show up yet? This should be an error. It gives me errors all the time for the dumbest little things. And I can't get it to make an error on purpose. Are you kidding me? Yes! Finally! Look at that. An error. A unary minus operator applied to unsigned type. Result still unsigned. Ta-da! Well, why isn't this an error? Because this is an unsigned type that becomes negated. It doesn't matter. I don't give a fuck. I'm gonna just keep the tiny little u, and I'll just define fucking every fucking place that I need to define every fucking thing and have duplicates of every freaking thing. Because I can't make new bugs. Everything sucks ass. I'll be RB. So, after all that, I'm going to decide to just define things as they are, make extra defines for all the little unsigned types and shit. It's not worth the effort of like possibly breaking stuff. Because that way it'll be less
Confusing.
to deal with. If I have
Clear intent.
I just leave like everything
All.
a bit like
Set.
in place as it is. It's more
Explicit. Than. Using.
a macro, not a macro. I ran out of words here. It's like I don't know. If I start like using a little
You.
at the end of a number that's unsigned, that I defined as unsigned in the macro. Getting rid of this. It's gonna be way more hassle than it's worth. So I'll just make extra defines for that, variant 2, whatever, and find and replace. This is gonna take forever anyways. So I don't know. I'll make back to work, whatever. Like turn this off. Why is this fucking software? For fuck's sake.
An instant. Assessing an instance of the
Now it's working. Software is shit.
capital C
Literal shit.
E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N yield await. The interpretation of capital C O V E R capital P A R E N T
It is literally opera.
I Z E
This web browser sucks. It sucks so bad.
E S
It sucks. The poop right from the butt. This web browser, what is wrong with it? Why does it lack up system resources? For fuck's sake.
wait 3 2 1 FSQ
It just keeps crashing the audio.
runtime semantics evaluation primary expression this return resolve this binding 3 2 2 identifier reference C13.1 for identifier reference 1 3 2 3 literals syntax literal null literal boolean literal numeric literal string literal 3 2 3 1 runtime semantics evaluation literal null literal 1 return null literal boolean literal if boolean literal is the token false return false if boolean literal is the token true return true literal numeric literal return the numeric value of numeric literal as defined in 1 2 9 3 literal string literal return the SV of string literal as defined in 1 2 9 4 2 46 ECMA International 2024 1 3 2 4 array initializer array elements may be elided at the beginning middle or end of the element list whenever a comma in the element list is not preceded by an assignment expression, that is, a comma at the beginning or after another comma. The missing array element contributes to the length of the array and increases the index of subsequent elements. Elided array elements are not defined. If an element is elided at the end of an array, that element does not contribute to the length of the array. Syntax, array literal, yield, await, elision ought, element list yield await, element list yield await, elision ought, element list, yield, await, elision ought assignment expression, plus in yield await, elision ought spread element yield await, element list yield await, elision ought assignment expression, plus in yield await, element list yield await, elision ought spread element yield await, elision, spread element, yield, await, dot. Assignment expression, plus in yield await, 1 3 2 4 1 runtime semantics, array accumulation. The syntax-directed operation array accumulation takes arguments array, an array, and next int x, an integer, and returns either a normal completion containing an integer or an abrupt completion. It is defined piecewise over the following productions. Elision. Let len be next index plus 1. Perform. Set. Array. Length. Len. True. Note. The above step throws if len exceeds 232 1. Return len. Elision. Elision. Return. Array accumulation of elision with arguments array and next index plus 1. Element list. Elision ought assignment expression. If elision is present, then a set next index 2. Array accumulation of elision with arguments array and next index. Let init result be. Evaluation of assignment expression. Let init value be. Get value. Init result. Perform. Create data property or throw. Array. To string. Next int x. Init value. Return next. T index plus 1. Note an array literal is an expression describing the initialization of an array, using a list of 0 or more expressions each of which represents an array element, enclosed in square brackets. The elements need not be literals. They are evaluated each time the array initializer is evaluated. ECMA International 2024 247. Element list. Elision ought spread element. If elision is present, then a set next index 2. Array accumulation of elision with arguments array and next index. Return. Array accumulation of spread element with arguments array and next index. Element list. Element list. Elision ought assignment expression. Set next index 2. Array accumulation of element list with arguments array and next index. If elision is present, then a set next index 2. Array accumulation of elision with arguments array and next index. Let init result be. Evaluation of assignment expression. Let init value be. Get value. Init result. Perform. Create data property or throw. Array. To string. Next int x. Init value. Return next index plus 1. Element list. Element list. Elision ought spread element. Set next index 2. Array accumulation of element list with arguments array and next index. If elision is present, then a set next index 2. Array accumulation of elision with arguments array and next index 3. Return. Array accumulation of spread element with arguments array and next index. Spread element. Assignment expression. Let spread ref be. Evaluation of assignment expression. Let spread obj be. Get value. Spread ref. Let iterator record be. Get iterator. Spread obj. Sync. Repeat. Let next be. Iterator step value. Iterator record. B if next is done. Return next index. C perform. Create data property or throw. Array. To string. Next int x. Next. D set next index to next index plus 1. Note create data property or throw is used to ensure that own properties are defined for the array even if the standard built-in array prototype object has been modified in a manner that would preclude the creation of new own properties using 3, 2, 4, 2. Runtime semantics. Evaluation. Array literal. Elision ought. Let array be. Array create. 0. If elision is present, then a perform. Array accumulation of elision with arguments array and 0. 3. Return array. Array literal. Element list. Let array be. Array create. 0. Perform. Array accumulation of element list with arguments array and 0. Return array. Array literal. Element list. Elision ought. 2. Let array be. Array create. 0. Let next index be. Array accumulation of element list with arguments array and 0. 48. ECMA International 2024. 3. If elision is present, then a perform. Array accumulation of elision with arguments array and next index. Return array. 3, 2, 5. Object initializer. Syntax. Object literal. Yield. Await. Property definition list yield await. Property definition list yield await. Property definition list T. Yield. Await. Property definition yield await. Property definition list yield await. Property definition yield await. Property definition. Yield. Await. Identifier reference yield await. Cover initialized name yield await. Property name yield await. Assignment expression. Plus in yield await. Method definition yield await. Dot. Assignment expression. Plus in yield await. Property name. Yield. Await. Literal property name. Computed property name yield await. Literal property name. Identifier name. String literal numeric literal. Computed property name. Yield. Await. Assignment expression. Plus in yield await. Cover initialized name. Yield. Await. Identifier reference yield await. Initializer. Plus in yield await. Initializer. In. Yield. Await. Assignment expression in yield await. Note 2 method definition is defined in 15.4. Note 1 an object initializer is an expression describing the initialization of an object, written in a form resembling a literal. It is a list of 0 or more pairs of property keys and associated values, enclosed in curly brackets. The values need not be literals. They are evaluated each time the object initializer is evaluated. Copyright sign. ECMA International 2024 249. Note 3 in certain contexts, object literal is used as a cover grammar for a more restricted secondary grammar. The cover initialized name production is necessary to fully cover these secondary grammars. However, use of this production results in an early syntax error in normal contexts where an actual object literal is expected. 3, 2, 5, 1 static semantics. Early errors. Property definition. Method definition. Bullet. It is a syntax error if has direct super of method definition is true. It is a syntax error if private bound identifiers of method definition is not empty. In. Used as a cover grammar for object assignment pattern and may be recognized as part of a capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N. When object literal appears in a context where object assignment pattern is required, the following early error rules are not applied. In addition, They are not applied when initially parsing a capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N or capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R. Property definition. Cover initialized name. It is a syntax error if any source text is matched by this production. Object literal. Property definition list. Property definition list. It is a syntax error if property name list of property definition list contains any duplicate entries for proto and at least two of those entries were obtained from productions of the form. Property definition. Property name. Assignment expression. This rule is not applied if this object literal is contained within a script that is being parsed for JSON parse. See step 4 of JSON parse. 3, 2, 5. To static semantics is computed property key. The syntax directed operation is computed property key takes no arguments and returns a boolean. It is defined piecewise over the following productions. Property name, literal property name, return false, property name, computed property name, return true. Addition to describing an actual object initializer, the object literal productions are also 250. ECMA International 2024. Note 1. This production exists so that object literal can serve as a cover grammar for object assignment pattern. It cannot occur in an actual object initializer. Note 2. The list returned by property name list does not include property names defined using a computed property name. 1, 3, 2, 5, 3. Static semantics. Property name list. The syntax directed operation property name list takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Property definition list. Property definition. Let prop name be prop name of property definition. If prop name is empty, return a new empty list. Return prop name. Property definition list. Property definition list. Property definition. Let list be property name list of property definition list. Let prop name be prop name of property definition. If prop name is empty, return list. Return the list concatenation of list and prop name. 3, 2, 5, 4. Runtime semantics. Evaluation. Object literal. Return ordinary object create. Percent object prototype. Percent object literal. Property definition list. Property definition list. Let obj be ordinary object create. Percent object prototype. Percent perform. Property definition. Evaluation of property definition list with argument obj. Return obj. Literal property name. Identifier name. Return string value of identifier name. Literal property name. String literal 1. Return the SV of string literal. Literal property name. Numeric literal. Let NBR be the numeric value of numeric literal. Return to string NBR. Computed property name. Assignment expression. Let exp value be. Evaluation of assignment expression. Let prop name be. Get value. Exp value. Return to property key. Prop name. 3, 2, 5. 5. Runtime semantics. Property definition evaluation. The syntax directed operation property definition evaluation takes argument object, an object, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Property definition list. Property definition list. Property definition. Perform. Property definition evaluation of property definition list with argument object. Perform. Property definition evaluation of property definition with argument object. Return unused. ECMA International 2024 251. Property definition. Assignment expression. Let exp value be. Evaluation of assignment expression. Let from value be. Get value. Exp value. Let excluded names be a new empty list. Perform. Copy data properties. Object. From value, excluded names. Return unused. Property definition. Identifier reference. Let prop name be string value of identifier reference. Let exp value be. Evaluation of identifier reference. Let prop value be. Get value, exp value. Assert. Object is an ordinary, extensible object with no non-configurable properties. Perform. Create data property or throw. Object. Prop name. Prop value. Return unused. Property definition. Property name. Assignment expression. Let prop key be. Evaluation of property name. If this property definition is contained within a script that is being evaluated for JSON parse, see step 7 of JSON parse. Then, a let is proto-set to be false, else if prop key is proto and is computed property key of property name is false. Then a let is proto-set to be true, else a let is proto-set to be false. If is anonymous function definition, assignment expression, is true and is proto-setter as false, then a let prop value be. Named evaluation of assignment expression with argument prop key, else a let exp value ref be. Evaluation of assignment expression be let prop value be. Get value, exp value ref. If is proto-setter is true, then if prop value is an object or prop value is null, then I perform object, prop value be return unused. Assert. Object is an ordinary, extensible object with no non-configurable properties. Perform. Create data property or throw. Object. Prop key. Prop value 0. Return unused. Property definition. Method definition. Perform. Method definition. Evaluation of method definition with arguments object and true. Return unused. 3, 2, 6 function defining expressions. See 15.2 for primary expression. Function expression. See 15.5 for primary expression. Generator expression. See 15.7 for primary expression. Class expression. See 15.8 for primary expression. Async function expression. See 15.6 for primary expression. Async generator expression. 52. Copyright sign. ECMA International 2024. 132. 7 regular expression literals syntax. C12, 9, 5, 3, 2, 7. 1 static semantics. Early errors. Primary expression. Regular expression literal. It is a syntax error if capital I, S, capital V, A, L, I, D, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital L, I, T, E, R, A, regular expression literal, is false. 3, 2, 7, 2 static semantics, capital I, S, capital V, A, L, I, D, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital L, I, T, E, R, A, literal. The abstract operation, capital I, S, capital V, A, L, I, D, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital L, I, T, E, R, A, takes argument literal, a regular expression literal parse node, and returns a boolean. It determines if its argument is a valid regular expression literal. It performs the following steps when called. Let flags be flag text of literal. If flags contains any code points other than D, G, I, M, S, U, V, or Y, or if flags contains any code point more than once, return false. If flags contains U, let U be true, else let U be false. If flags contains V, let V be true, else let V be false. Let pattern text be body text of literal. If U is false and V is false, Then, a let string value be code points to string pattern text. B set pattern text to the sequence of code points resulting from interpreting each of the 16-bit elements of string value as a Unicode BMP code point. UTF-16 decoding is not applied to the elements. Let parse result be parse pattern text U V. If parse result is a parse node, return true, else return false. 3, 2, 7, 3 runtime semantics. Evaluation primary expression, regular expression literal. Let pattern be code points to string, body text of regular expression literal. Let flags be code points to string, flag text of regular expression literal. Return regexp create pattern flags. 3, 2, 8 template literal syntax. Template literal yield await tagged. No substitution template. Substitution template yield await tagged. Substitution template yield await tagged. Template head expression plus in yield await. Template spans yield await tagged. Template spans yield await tagged. Template tail. Template middle list yield await tagged. Template tail. ECMA International 2024 253. Template middle list yield await tagged. Template middle expression plus in yield await. Template middle list yield await tagged. Template middle expression plus in yield await. 3, 2, 8, 1 static semantics. Early errors. Template literal yield await tagged. No substitution template. It is a syntax error if the tagged parameter was not set and no substitution template contains not escape sequence. Template literal yield await tagged. Substitution template yield await tagged. It is a syntax error if the number of elements in the result of template strings of template literal with argument force is greater than or equal to 232. Substitution template yield await tagged. Template head expression plus in yield await. Template spans yield await tagged. It is a syntax error if the tagged parameter was not set and template head contains not escape sequence. Template spans yield await tagged. Template tail. It is a syntax error if the tagged parameter was not set and template tail contains not escape sequence. Template middle list yield await tagged. Template middle expression plus in yield await. Template middle list yield await tagged. Template middle expression plus in yield await. It is a syntax error if the tagged parameter was not set and template middle contains not escape sequence. 3, 2, 8, just static semantics. Template strings. The syntax directed operation template strings takes argument draw, a boolean, and returns a list of either strings or undefined. It is defined piecewise over the following productions. Template literal, no substitution template. Return template string, no substitution template. Raw. Substitution template. Template head expression template spans. Let head be template string. Template head. Raw. Let tail be template strings of template spans with argument draw. Return the list concatenation of head and tail. Template spans. Template tail. Return template string. Template tail. Raw. Template spans. Template middle list template tail. Let middle be template strings of template middle list with argument draw. Let tail be template string. Template tail. Raw. Return the list concatenation of middle and tail. 54. ECMA International 2024. Template middle list. Template middle expression 1. Return template string. Template middle. Raw. Template middle list. Template middle list template middle expression. Let front be template strings of template middle list with argument draw. Let last be template string. Template middle. Raw. Return the list concatenation of front and last. 3, 2, 8, 3 static semantics. Template string. Template token. Raw. The abstract operation template string takes arguments template token. A no substitution template parse node. A template head parse node, a template middle parse node, or a template tail parse node, and raw, a boolean, and returns a string or undefined. It performs the following steps when called. If raw is true, Then, a let string be the TRV of template token. Else, a let string be the TV of template token. Return string. 3, 2, 8, 4 get template object. Template literal. The abstract operation get template object takes argument template literal, a parse node, and returns an array. It performs the following steps when called. Let realm be the current realm record. Let template registry be realm. For each element of template registry, do if E is the same parse node as template literal, then I return E. Let raw strings be template strings of template literal with argument true. Assert raw strings is a list of strings. Let cook strings be template strings of template literal with argument false. Let count be the number of elements in the list cook strings. Assert count 232 1. Let template be array create count 0. Let raw obj be array create count 1. Let index be 0 2. Repeat while index count a let prop be to string index b let cooked value be cook strings index c perform define property or throw template prop property descriptor cooked value writable false true false d let raw value be the string value raw strings index e perform define property or throw raw obj prop property descriptor raw value false true false f set index plus 1 3 perform set integrity level raw obj frozen 4 perform define property or throw template raw property descriptor raw obj false enumerable false false 5 perform set integrity level template frozen 6 append the record template literal template to realm 7 return template. Note this operation returns undefined if raw is false and template token contains a not escape sequence. In all other cases, it returns a string. ECMA International 2024 255. Note 1. The creation of a template object cannot result in an abrupt completion. Note 2. Each template literal in the program code of a realm is associated with a unique template object that is used in the evaluation of tagged templates. 1 3 2 8 6. The template objects are frozen and the same template object is used each time a specific tagged template is evaluated. Whether template objects are created lazily upon first evaluation of the template literal or eagerly prior to first evaluation is an implementation choice that is not observable to ECMA script code. 1 3 2 8 5 Runtime semantics. Substitution evaluation. The syntax-directed operation substitution evaluation takes no arguments and returns either a normal completion containing a list of ECMA script language values or an abrupt completion. It is defined piecewise over the following productions. Template spans. Template tail. Return a new empty list. Template spans. Template middle list. Template tail. Return. Substitution evaluation of template middle list. Template middle list. Template middle expression. Let subref be. Evaluation of expression. Let sub be. Get value. Subref. Return sub. Template middle list. Template middle list. Template middle expression. Let preceding be. Substitution evaluation of template middle list. Let next ref be. Evaluation of expression. Let next be. Get value. Next ref. Return the list concatenation of preceding and next. 3 2 8 6 Runtime semantics. Evaluation. Template literal. No substitution template. Return the TV of no substitution template as defined in 1 2 9 6. Substitution template. Template head expression. Template spans. Let head be the TV of template head as defined in 1 2 9 6. Let subref be. Evaluation of expression. Let sub be. Get value. Subref. Let middle be. To string. Sub. Let tail be. Evaluation of template spans. Return the string concatenation of head, middle, and tail. 56. ECMA International 2024. Note 3. Future editions of this specification may define additional non-enumerable properties of template objects. Note 1. The string conversion semantics applied to the expression value like string prototype concat rather than the plus operator. Template spans. template tail. Return the TV of template tail as defined in 1, 2, 9, 6. Template spans. Template middle list template tail. Let head be evaluation of template middle list. Let tail be the TV of template tail as defined in 1, 2, 9, 6. Return the string concatenation of head and tail. Template middle list. Template middle expression. Let head be the TV of template middle as defined in 1, 2, 9, 6. Let subref be evaluation of expression. Let sub be get value subref. Let middle be to string sub. Return the string concatenation of head and middle. Template middle list. Template middle list. Template middle expression. Let rest be evaluation of template middle list. Let middle be the TV of template middle as defined in 1, 2, 9, 6. Let subref be evaluation of expression. Let sub be get value subref. 5. Let last be to string sub. Return the string concatenation of rest, middle, and last. 3, 2, 9. The grouping operator. 3, 2, 9. 1. Static semantics. Early errors. Primary expression. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N must cover a parenthesized expression. 3, 2, 9. To runtime semantics. Evaluation. Primary expression. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Let expa be the parenthesized expression that is covered by capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Return. Evaluation of expa parenthesized expression. Expression. Return. Evaluation of expression. This may be of type reference. Note to the string conversion semantics applied to the expression value like string prototype concat rather than the plus operator. Note 3. The string conversion semantics applied to the expression value like string prototype concat rather than the plus operator. Note this algorithm does not apply get value to evaluation of expression. The principal motivation for this is so that operators such as delete and type off may be applied to parenthesized expressions. ECMA International 2024 257 13.3 left-hand side expressions syntax. Member expression, yield, await. Primary expression yield await. Member expression yield await. Expression, plus in yield await. Member expression yield await. Identifier name member expression yield await. Template literal yield await. Plus tagged super property yield await. Meter property. New member expression yield await. Arguments yield await. Member expression yield await. Private identifier super property. Yield await. Super expression plus in yield await. Super identifier name meter property. New target. Import meter new target. New target. Import meter. Import meta. New expression. Yield. Await. Member expression yield await. New expression yield await. Call expression. Yield. Await. Capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D.
So now I'm gonna run it, and I have to like go back again.
Yield await.
I like how Chatbot described in its Chatbot's 10-step plan.
Expression plus in yield
Chatbot said,
await. Identifier name call expression yield await. Template literal yield await.
that's roughly a 10-step high-level workflow, though actual work may loop back several times. So this is one of those times that things loop back.
Import assignment expression plus in yield await.
Unfortunately, this is so annoying because I gotta like, I'm gonna save it back up to make sure I have it back up, and still gotta run it. So I gotta close it, save it back up, so I don't have to wait, and then save it back up. I'm gonna just save it back up, run it, click build or whatever, because then at least backup saved, and then I can let it just build for a minute and 30 seconds, and then it runs or doesn't. If it doesn't run, delete the backup. If it's bad, if it runs, I'm like good, I gotta back up. So I gotta save it back up first, and then
Yield await. Optional chain yield await.
I have to go back through.
Optional chain yield await. Optional chain yield await. Arguments yield await. Expression plus in yield await. Identifier name template literal yield await plus tagged. Private identifier optional chain yield await. Arguments yield await. Optional chain yield await. Expression plus in yield await. Optional chain yield await. Identifier name optional chain yield await. Template literal yield await plus tagged. Optional chain yield await. Private identifier left hand side expression yield await. New expression yield await.
I have to go back through. I have to rename all of
Supplemental syntax when processing an instance of the call expression capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D.
I guess first I have these defined. They're defined to the wrong thing.
The interpretation.
So it's a good thing I just checked.
E R
Otherwise I would have had a bug and not noticed it until way later.
E X P R E S S I O N capital A
Fuck do I define this one?
Y N C
Dang it.
R is refined using the following graph.
This is so annoying. I hate fucking, this is so, I want to be, there is a new operating system that will replace, it's a futuristic operating system one day. So I'm gonna just stop complaining, suck it up, just get done. Just gonna finish this up and get it over with. This won't last forever, but the longer that I drag this out, the more days it's gonna take. So I gotta get done and just deal with it. Yep.
C with similar code without optional
Anyways, this one is
statement and where automatic. Import meta. It is
with the U. Now, I could possibly glue the tokens,
accesses. Note proper.
but then I gotta deal with figuring out or looking up, trying to remember, because I don't care, because I don't give a fuck. I just have to like glue the tokens if I was going to.
Expression. The dot notation is explained.
Or concat, whatever you want to call it. There's so many different names. I just don't care about anything, because everything is shit. literal shit.
Call
And people, teams of people working on a goal, and then they make shit. They make fucking shit. How could you have so many people working on Windows and develop absolute shit? Literally. It's crap. The Steam OS looks pretty cool. Steam OS.
Get value.
I saw it
Code. Let strict be true.
what's it called? Stupid Steam thing.
Capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R base value expression strict 60 ECMA International 2024 member expression identifier name let base refer NSB evaluation of member expression let base value be get value base reference if the source text matched by this member expression is strict mode code let strict be true else let strict be false return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital I D E N base value identifier name strict member expression private identifier let base reference be evaluation of member expression let base value be get value base reference let field name string be the string value of private identifier return make private reference base value field name string call expression expression let base reference be evaluation of call expression let base value be get value base reference if the source text matched by this call expression is strict mode code let strict be true else let strict be false return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R base value expression strict call expression identifier name let base reference be evaluation of call expression let base value be get value base reference if the source text matched by this call expression is strict mode code let strict be true else let strict be false return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital I D E N base value identifier name strict call expression private identifier let base reference be evaluation of call expression let base value be get value base reference let field name string be the string value of private identifier return make private reference base value field name string 3 capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R. Base value, expression, strict. The abstract operation, capital E, V, A, L, U, A, T, E, capital P, R, O, P, E, R, T, Y, capital A, C, C, E, S, S, capital W, I, T, H, capital E, X, P, R, takes arguments base value, an ECMA script language value, expression, an expression parse node, and strict, a boolean, and returns either a normal completion containing a reference record or an abrupt completion. It performs the following steps when called. Let property name reference be. Evaluation of expression. Let property name value be. Get value, property name reference. Let property key be. To property key, property name value. Return the reference record. Base value, property key, strict. This value, empty. 3, 3, 4, capital E, V, A, L, U, A, T, E, capital P, R, O, P, E, R, T, Y, capital A, C, C, E, S, S, capital W, I, T, H, capital I, D, E, N, base value, identifier name, strict. The abstract operation, capital E, V, A, L, U, A, T, E, capital P, R, O, P, E, R, T, Y, capital A, C, C, E, S, S, capital W, I, T, H, capital I, D, E, N, takes arguments base value, an ECMA script language value, identifier name, an identifier name parse node, and strict, a boolean, and returns a reference record. It performs the following steps when called. Let property name string be string value of identifier name. Return the reference record. Base value, property name string, strict, empty. ECMA International 2024 261 133 5 Then new operator 3 3 5 1 runtime semantics evaluation new expression new expression return evaluate new expression empty member expression new member expression arguments 1 return evaluate new member expression arguments 3 3 5 1 1 evaluate new construct expa arguments. The abstract operation evaluate new takes arguments construct expa, a new expression parse node or remember expression parse node, and arguments.
Well, I don't know where it is. I should put a BRB. I think it's not a Steam Deck, whatever the stupid Steam thing was, the handheld, whatever you call it. I don't know, I could actually play video games. I was gonna like find it, but I looked in the last place I would look for it, and I don't know where it is. So, I didn't find it. That's cool. It was a waste of time. Anyways, that runs SteamOS, or I think it's like SteamOS, or it's just Steam standalone. I think it's running Linux. Is SteamOS like actually separate from the other one? I gotta Google it. Anyways, with these macros though,
XP.
I could glue tokens, whatever, but it's not worth it because I gotta figure out if it's gonna glue the name or the contents of the name.
Capital A S Y.
So just type it up like this.
Capital A R R. Let expa be the call member exp.
But then this one,
C O.
for these I gotta freaking define them above in the 32 or 64-bit because it has to be like actually typed up to the length of the register size and then have a literal U after it So now it's more complicated and annoying as hell.
Y, N, C.
So we like write those up now down here.
Member expa be the
So look like this, whatever.
arguments of expa. Letter FB. Evaluation.
These ones could stay, but I might as well write them up
Is prop.
the longhand way at this point.
Ref is eval. Then if same value. Func. Percent eval percent.
Because the unsigned ones need to be the longhand way anyways.
Evaluation of arguments. 2. If arglist has no elements, return undefined. 3. Let eval arg be the first element of arglist. 5. If the source text matched by this call expression is strict mode code, let strict caller be true. Otherwise, let strict call.
Is this 7 or E? Not E.
Eval arg. Strict caller. True. Let this call be this call expression. Let tail call be as in tail position. This call. Return. Evaluate call. Func. Ref. Arguments. Tail call. A call expression evaluation that executes step 6 AV is a direct eval. Call expression. Call expression arguments. Let ref be.
It is E. Okay.
Let func be. Get value. Ref. Let this call be this call expression. Let tail call be as in tail.
This computer is so laggy.
Evaluate call. Func. Ref. Arguments. Tail call. 62. ECMA International 2024. 1336. 2. Evaluate call. Func. Ref. Arguments. Tail position. The abstract operation evaluate.
Then I could type up the same thing, little but with a U.
Any CMA script language value or a reference record. Arguments. A parse node.
This one's a different length.
And returns either an.
Ta-da! Let's add zeros to these ones.
It performs the following steps.
I'm gonna leave them.
Reference record. Then, if is property reference.
So I gotta put this for 32-bit, and I gotta define the 64-bit as this.
F2. Assert.
Lots of fun.
3. Let this value be refn.
This is so boring.
Value be undefined. Let arglist be. Argument list evaluation of arguments. If func is not an object, throw a type error exception. If is callable, func is false. Throw a type error exception. If tail position is true, perform prepare for tail call. Return. Call. Func. This value. Arglist. 3. 3. 7th SOP keyword. 3. 3. 7. 1 runtime semantics. Evaluation super property. Super. Expression. Let env get this environment. Let actual this be env get this binding. Let property name reference be.
Okay, but what I was getting at is that this ended up being ZXP.
B. To property key, property name value.
Which I don't know. I meant to be like 0 extended,
Else let strict.
and it's a pin. I don't want to use bit like B
Super property. Super. Identifier name.
because I also have one called byte,
Env get this binding.
and I can mix it up easier because it will start with a B,
Is strict mode.
like byte and then bit.
Let strict be false.
Look too close, too similar.
Actual this. Property key. Strict. Super cool. Super
But pin, that looks different.
target. Assert. New target is an object. Let func be get super construct.
It has a new ZXN for 0,
Constructor.
X for hexadecimal, whatever,
Result.
and then do a nibble. A nibble is 4 bits of a byte, so 2 nibbles and a byte. Is nibble spelled with 2 L's or 1? Whatever.
Initialize instant.
So I was going to shorten it to just P or N. So this way it takes up the same amount of space, 3 characters. But as it's reading through, I saw ZXN and I'm like, what the fuck does that mean? 0 not? And I was like, Oh wait, is that the same as NZ? Because a negative, and then maybe it's 0, and I'm like, well, this is really confusing to do this, because now I ended up with ZXN.
3, 3, 7.
Here in ZXN is the opposite
Key, strict. The
of NXC.
arguments actual this. Any CMA script language value. Property key, a property key, and strict, a boolean, and returns either a normal completion.
And earlier I had things named NXC to stand for negative, and I renamed them. No, there's still N for negative, or not. But the Z here makes it confusing, because I'm using Z here. In Z usually means 0. So anyways, dyslexia, whatever.
8, 1.
Literally, dyslexia.
The syntax directed.
Anyways, if I redefine these, replace them as pin and nibble, or nib.
It is defined piecewise over the following productions. Arguments. Return a new
Then I'll have ZX,
alignment expression. Letter FB.
byte or whatever.
Alignment expression. Let
ZX byte. This way, they're all the same length. And if I zoom out and I'm reading them very quickly, there is a very, very tiny chance that I'll mix up any of them now, because now this is too short. I can read it and I can I'll mix up characters. But if it's longer and they're all the same length, it'll be easier to just read.
list. Argument list.
So I gotta
And expression. 1, 2. Let preceding args be. Argument list. Evaluation of argument list.
replace all these back with what I was gonna originally name them.
2024. 3. Let arg be. Get value. Ref. Return the list concatenation of preceding args and arg. Argument list. Argument list. Assignment expression. Let preceding args be.
Do pin and then nib.
Let spread ref be.
And I gotta rename the things in this file, the other file that's outside of the files. I have
Sync. Repeat. Let next be. Iterate a step value.
a folder called additional. And that's where I put all the things that are defined without conditions, so literals and stuff. And then I have another folder called bridge, and in the bridge folder I use those conditionals, I use those defines and literals in conditionals to pick all the conditional things. So
B.
the defined literals are separated
Turn the list concatenation of site.
from the
Substitute.
conditional things,
Expression tip.
and it's a lot cleaner than mixing things up.
Evaluation of expression. Let first sub be.
And alphabetically it's additional then bridge.
Substitution evaluate.
So A, B,
Ands.
I don't know. I thought it was fancy.
Return the list.
I gotta merge several projects into one big code base, whatever.
9.
JavaScript, HTML, CSS, assembly language.
9. Let base reference be.
And this is a monolith or whatever you call it. I'm gonna put everything in it, so I don't know. I tried to plan ahead. I tried. I'm pretty sure something won't go as planned.
Of optional change.
But the plan is to move every single project I have into one big ass folder
Reference B.
that's completely organized, different languages, all of it there,
Get value.
and then I can pick through it and make other things from the other things that are related from other projects. I don't know,
Of optional chain with argument.
because that's the last thing anybody that programs ever does, is organize everything in a single location.
With the token.
But if you're using the cloud, you might be doing that because you're going to the cloud. If you're saving stuff to the cloud, it's going to be stolen. So, I don't know.
expression.
The cloud is really stupid, unless you're just writing code to write code. But if you're doing that and you're not writing anything important, maybe you should think of something important to do with your time and spend your time doing something important that you wouldn't want stolen, and then stop using the cloud. Because Microsoft owns GitHub. Microsoft sucks. I don't know.
Reference.
Microsoft couldn't even make a Windows Phone.
And returns either a normal
They have to buy up companies because they can't produce.
record
They're a bunch of fucking idiots.
and piecewise.
Like literal idiots. Bunch of micro softies. Anyways. That's why Microsoft had to drop their development on their console to update Windows 11 because SteamOS is coming out. And Windows knows they can't compete. They couldn't even compete with cell phones. So like when a handheld comes out from SteamOS and they have SteamOS on it, Windows is like, fuck, we're fucked. And they're fucking updating Windows support on handheld devices because they know their stuff is shit. And they know their stuff is shit, and they know they can sell shit. And that's why they even bothered to start making a device, and then they had to stop in the middle of making it because they're like, fuck, we can't keep making shit if Steam's gonna make an OS. Because if Microsoft loses Steam, they're gonna lose so much money. The whole gaming industry will move. And Windows will be the dinosaur. Windows will become Facebook. A dinosaur that's dying. It's already dying. Microsoft's fall is inevitable. And there's gonna be one big push. It's all gonna tumble. Anyways. Like SteamOS, whatever. There's a video of Bill Gates saying there's no room for competition or something to Gary Cadell.
ChatGPT, Lenovo Legion OS handheld power fueled by AMD Ryzen trademark sign Lenovo US, compiler explorer, speed dial.
I hate how it reads off the tabs. I literally click in here and I click speech to text and then it reads off the fucking tabs, for fuck's sake.
Bill Gates on video said there's no room for competition to Gary Kildall. Can you find me the YouTube video link? I think it was in the Computer Chronicles, one of the episodes.
So maybe it'll text to speech now, or maybe it'll read the tabs, Who knows? Guess I'll find out.
Bill Gates on video said there's no room for competition, and he has a creepy little smile because he stole Gary Kildall's boss with help of IBM to Gary Kildall. Can you find me the YouTube video link? I think it was in the Computer Chronicles, one of the episodes. Bill Gates on video said there's no room for competition, with a creepy little smirk on his Microsoft face because he stole Gary Kildall's OS with help of IBM to Gary Kildall. Can you find me the YouTube video link? I think it was in the Computer Chronicles, one of the episodes.
How can it not? That's a literally what response. So I gotta look up and memorize how to spell that. I can't keep spelling that word wrong. Alright. But it's close enough, whatever.
Bill Gates on video said there's no room for competition, with a creepy little smirk on his Microsoft face because he stole Gary Kildall's OS with help of IBM in a response to Gary Kildall asking about competition in the computer market. Can you find me the YouTube video link? I think it was in the Computer Chronicles, one of the episodes.
I gotta try to find the video then. Dang it.
I couldn't locate a specific Computer Chronicles episode where Bill Gates says, there's no room for...
I bet Chatbot is choosing to not find the video. Because I bet I can find it.
I couldn't locate a specific Computer...
Alright, I gotta So I'm gonna do the master place. I just checked everything. ZXP back to ZXPin and then ZXN to ZXNib. So I gotta save it backup first. I think it works because I turned off the blocks, whereas intentionally throwing a type error because the sign of the value, whatever. Dang, I'm gonna freak. So I gotta save it backup first, and I gotta run it, make sure it runs, because maybe it fucked up the encoding of the file, because I did double click it and view the file. That's what Microsoft Visual Studio compiler does now and then. Quite a bit. It fucks up the file. So I'm gonna save it back up and I'm gonna run Visual Studio. That's gonna take a minute and a half to run because it's a slow compiler. And it doesn't make better results for being a slow compiler. It's just a slow compiler and makes shit ass results. That's why it's a slow compiler. Not because it's like optimized or efficient or doing something to make code better. It's just a piece of shit. Just like the Microsofty dude. these people, by these I mean Microsofty dude and all his relations, they're real old now. So, I don't know, whatever. I said check something else. I'm gonna save it back first. I should probably not say some things. It's copying. Come on, hurry up. Everything's saved, I think. One file wasn't saved, but it doesn't matter. It should save now. I can't see anything when it's all zoomed in. There we go. Subset. Now I can run it. If it builds, it's good. All the code I added was it didn't do anything to the actual code. It's just there to test if it would throw an error when unsigned's negated. And it did eventually. So I don't have to like run after I build. If it builds, it's fine. So after it builds and it runs, I know the backup's good. If it doesn't, I have to make another backup, fix whatever. If it builds, whatever, I'm gonna like finally replace these things. I'll do a mass replace because I just checked everything. So I'm safe to like mass replace ZXP and ZXN with ZXPin and ZXNIB. I'm gonna try the noise. The noise suppression sounds like shit. Literal crap. Someone that knows what they're doing needs to like donate to OBS to get some better software. I don't have time to write sound software. I don't want to look into it. At least not now. Cause the noise suppression on OBS, it sucks. It's horrible. Anyways. I should click build. Alright, this is gonna build. It should be okay. So take a whole freaking minute and 30 seconds to build every single time. Now the window's too close to the edge, so I can't zoom in. I can't zoom in. This noise suppression sucks. I can't raise and lower my voice because it like stops picking up my freaking voice. I talk like a robot. Oh my god, this zoom tool is shit. You know what? I'm not gonna zoom in, I just don't care. I think it's almost done building. No, it's not. I have chatbot read this and see how biased it is, and then I'll find the video. And then I'll get to this stuff, find a replace, run it again, save another backup, and then all I have left is it built. Okay, good, so it's fine. Assuming it's fine, which it should be. Where's the window? Alright, now I'm gonna replace these. I'll have chatbot read this, and then I'll look for the video. But I'll like replace this stuff. It's reading this, whatever. Except after I'm done placing, all I have left is all I have left is the ZX, BY, the blade things, whatever. And then that's it for all the masks. Then I can finally do all the shift operations. And after the shift operations, it's offsets and it hurts to talk louder. My voice, this noise suppression fucking sucks. It's shit. I wish it would work. So I have chatbot read this. All I have left is one thing to replace. If it builds and finds and replaces, so replace the bytes, and then it's just the shift operations. Then after that, I get to go to like chatbot output for a 10-step plan. That's as far ahead as I've thought. If that's all good, I get to I thought the word reevaluate was in here, but it's not. I don't know. after I get all the shift operations, that's as far as I thought I had. Then I get to loop back several times and just keep going and going for a rough 10-step high-level workflow. Freaking step 1, step 3, step 5, 2, 5, 8, 7, 9, 1, 2, up and down till it's done. So much stuff to go, but so much already done. So you win some, you lose some. So far, I'm winning. I'm gonna win big. So I have chatbot read this, see if it's biased. I'm gonna like finish replacing this stuff. And after I get this stuff, I get the shifts, I'm gonna try to like focus and not get distracted. If that's possible. It's probably not possible, but I can try.
I couldn't locate a specific Computer Chronicles episode where Bill Gates says, "There's no room for competition," accompanied by a creepy little smirk, in response to Gary Kildall's inquiry about competition in the computer market. However, the tension between Gates and Kildall is well documented, particularly regarding the development of MS-DOS and its relationship to Kildall's CP/M operating system in the early 1980s. IBM approached Microsoft for an operating system for its forthcoming personal computer. Microsoft did not have an OS at that time but acquired 86DOS from Seattle Computer Products, which was compatible with Intel's 8086 processor. This OS was later rebranded as MS-DOS. Gary Kildall, who developed CP/M, was reportedly approached by IBM first. However, due to a missed meeting, Kildall was allegedly flying his plane at the time. IBM proceeded with Microsoft's offer.
That's not even how the story went. Wow. I guess the winner always gets to tell victory. The victory, whatever, or whatever the saying is, I don't know. I'm not gonna say some things. And then
The situation led to significant controversy, with some
I don't know. I could drive a bombshell, but I'm not going to, because that'd be stupid.
The situation led to significant controversy, with some alleging that Microsoft had copied CP/M's design for MS-DOS. In his unpublished memoir, Kildall referred to DOS as plain and simple theft because its first 26 system calls mirrored CP/M's. While I couldn't find the exact Computer Chronicles episode you're referring to, the series did cover the early days of personal computing, including the roles of Gates and Kildall. The PBS documentary Triumph of the Nerds also delves into this history, offering insights into the dynamics between Microsoft, IBM, and digital research. While I couldn't find the
It's not nerds. They're, well, I guess Cadell was a nerd. We all know what they are, yeah. Can't just say some things. Everybody knows.
If you're interested in exploring this topic further, I recommend watching the Triumph of the Nerds documentary, which is available on various streaming.
Which is,
In exploring this topic,
I'm interested in figuring out why or how Apple developed this menu here. When you click X, it should close.
if you're interested If you're interested in exploring this topic, further, I recommend watching the Triumph of the Nerds documentary. If you're interested in exploring this topic further, 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 if 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 you're interested in
Like, seriously? Who developed this thing? Who? What the fuck? This is so dumb.
if you're interested in if you're interested in
Maybe they don't know what X means. It's pretty universal that X means X. We all know what that means. Like how everybody who was on Epstein's plane knows what that means. Not nerds. Some people are on planes, they're not the pilots. And Gary Goodall, he was a pilot, he was a nerd, he's not a passenger. Some people are just passengers in life. I should stop now. Everybody knows what X means. It doesn't mean.
if you're in
It doesn't mean
topic further, I recommend watching the Triumph.
to restart. That's not what X means. They probably just mixed up what X means when they made that button.
If you're interested in exploring,
Because it is pretty frustrating.
if you're interested in exploring this, if you're in,
Like, whatever. It's so annoying though. I gotta like read or have it read a couple words
I've,
just to cancel it out. So, that's that. I gotta find and replace. So I can replace CX byte. That's fine. Doesn't exist in the 158 files. I can replace ZX pin. And I can replace ZX nib. So, I'm gonna do that. I see it to back up. Let's do it now. And hope for the best. I didn't put in byte yet, so I gotta do this too. So save all. I gotta update the file where they're defined. still need to split up these defines between 32-bit and 64-bit. I'll do that in a minute. And rebuild. I just replaced all of these. What the fuck? Wow. One macro. All those errors for one macro. I move this macro to the additional file, whatever. I'll put in the conditional or the bridge folder, whatever it was, later, because it depends on the conditions, not whatever. But I didn't rename this one. In the compiler, it's like boom, tons of errors. It doesn't even say where it's at. It just says all the macros that are calling it. It's not saying specifically which fucking macro that it is. And no, that's not helpful at all. So this macro is used everywhere, I guess, or in lots of places. So, I just gotta rename ZXN to ZXNib, and that's good. NIB, NIB, and then another nib, NIB. Oh, there's another one. This macro has ZXNIB. It also has ZXP. Try again. I hate this debugger. It's the most useless fucking thing. Now it's building. Okay. This takes so long to build. Alright, I'm gonna find my Microsofty dude. You have no idea who I'm talking about because I'm not using his name. I mean, they or them name. When I say Microsofty dude, you don't know who it is. I've heard he likes fungus, though, as a hint. He makes meat out of fungus. He talks like this. That guy. He's like, fungus is great. How the fuck do you eat fungus? What the hell? It explains a lot, actually. It's probably what causes Microsofties. Does fungus cause Microsofties? How do you spell Microsofty? I guess it's TYS. Microsofties.
Does fungus cause Microsofties?
Microsofties doesn't have to be recognized as a medical or scientific condition because it is contagious. It's called. It's not worth making that joke. I really need to get to work and stop stalling.
The term Microsofties isn't a recognized medical or scientific condition. It's not a term used in medicine, biology, or even technology in any serious context. It seems like you're using it humorously or as a bit of tech slang, possibly referring to people who are overly loyal to Microsoft, or jokingly critiquing Microsoft cultural products.
I can't make a joke without being super dirty. So I'm just gonna make part of a joke.
I used to be a Microsoftie until I got a Windows phone. I used to be a Microsoftie until I got a Windows phone. Windows is a joke. The customer the punchline.
Wow, so chatbot stands up. And this isn't even funny, what chatbot's saying.
That's a pretty sharp line, and not an uncommon sentiment among folks who've had a rough ride with Microsoft products, especially Windows Phone. That platform, in particular, became something of a cautionary tale in tech history. Many people started out loyal to Microsoft. It was the default for decades. But experiences like the failure of Windows Phone, good design ideas, but poor app ecosystem and support, buggy or forced updates in Windows, especially with Windows 10 rollout, user hostile decisions ads in File Explorer, forced edge, telemetry, etc. have pushed a lot of former Microsofties to jump ship toward Linux, Mac OS, or just more open ecosystems. Still, Microsoft has made some solid developer tools, like Visual Studio, GitHub,
Visual Studio is ass. Visual Code is shit. GitHub, they purchased. What the fuck is Copilot? Other than I can't delete it and it takes up space.
For average consumers, it's often felt like a rocky deal.
What deal? What do I get out of being a customer? I get fucked. This is stupid. And then they get advertising money. Makes no sense.
The Computer Chronicles is made possible in part by BigStar.com, with thousands of videos and DVDs for the whole family.
Hi, and welcome to the Computer Chronicles. I'm Stuart Chaffee. There's really only one mega celebrity in the computer industry, and that is Bill Gates. He's one of the best-known people in the world. He's one
I thought I paused it. Welcome to the most boring stream ever. Super boring.
Operating systems of today vanish, where you don't think about a file name on a particular their software
is a little piece of a powerful
estimate that very smooth.
Than I would have expected, and that's just the run of luck we've had prior.
want to call it quits, but Gates says he isn't concerned.
I knew that a lot of people would retire.
It's freaking creepy.
When they got very wealthy. I'm actually surprised more haven't retired. And from time to time, there comes a person where we have to say, hey, you should retire.
It's a good thing he retired.
You know, excellence is what it's all about.
Didn't he like take a bunch of money and they like fired him again or something?
It's not some game of you know, let's have the same old club meeting we had 10 years ago.
So corrupt. So like people plan crimes against humanity against Bill Gates so it'd take up the front page so you can't find what you're looking for. Not worth finding.
But people have wanted to work and they've risen to the challenge.
Yeah, people want to work and he just wants to take it.
Better than I would have expected.
He's such an asshole. He just fucks people over. He's like, it's better than expected. He fucks you.
You know, just the run of luck we've had.
A run of luck. It's called karma. Oh, that's what's coming around, I guess.
It makes it a lot of fun.
In fact,
Yeah, of course it's fun, because you're not doing the work. Is he not? Ah, whatever.
Gates says the financial success of Microsoft's employees means fun
This guy looks excited in his job.
has to be one of the key motivators for the people who work there.
That guy looks really motivated.
They come to work every day because they like their job. And
This is a terrible interview.
it's fun to think that's the threshold test a company has to meet. It's not,
Be a lot of fun to work for Microsoft. Hey,
they'll be in here today. They need the paycheck. Ha, 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 ha. I mean,
that's literally what he thinks.
is that really?
See how he smiles? He gives it away. He's not joking. He's being totally serious.
The rest of business works? Well, we don't have that advantage. If so, you know.
Oh, he's so funny, isn't he?
Our people are there because it's very exciting.
Yeah, that guy looked real excited.
One of the key motivators for the
Run of luck we've had, and it makes it a lot of fun.
In fact, Gates says the financial success of Microsoft's employees means fun has to be one of the key motivators for the people who work there.
They come to work every day because they like their job. And
That guy really looked like he likes his job. I know Gates, he loves his job.
it's fun to think that's the threshold test a company has to meet. It's not, haha, they'll be in here to
Little smirk. He's a fucking liar.
the paycheck. Ha 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 ha.
It's a real, and then he goes to the real laugh.
I mean, is that really how the rest of business works? Well, we don't have that advantage. If so, you know, our people are there because it's very exciting. Makes it a lot of fun.
In fact, Gates says the financial
I don't know. Exciting? My ass.
Interesting because it is with his
I think so at this point. And I have to say, I feel exactly, and well, and
Well, we've looked at the bigger mic.
can you make the company 4 times? And I can imagine a 60-year-old sitting around helping out, maybe going back and writing a little code, being a nice guy.
I'm trying to find one part of this whole thing. I just want one part of the video.
And I'm looking
In Man Who Ruled
Bill Gates, a lot of his is that
Mess on the purchase 8. Trick a fortune
there isn't really
to my 8 computer tech giving way to
time actually soft really being not be a few pay market set rest of the
I think he must national and part into the
Windows is an enterprise like credit that you
sometimes
having frankly have number
get come
an awful lot of time spending a lot
and Bill Gates will never be quite the same.
is doing it from that much.
I think the reason most of us are in this business is because things do change. And it's
Things don't change. What the fuck is he talking about? We got 32-bit computers that are 16-bit that are pretending to be 64-bit. Nothing changes. This guy's full of shit.
very interesting.
He eats fungus, for fuck's sake.
And no one, not Microsoft, not Intel, not anyone, has a guaranteed position. And
Yeah, no, they don't. Some people are gonna go down.
unless you adopt your products, keep hiring the great people,
Yeah, they can adopt, hire whatever they want. It's not gonna save them. They can even save the Windows Phone.
you're not going to be there. It's not like Coca-Cola where you can say, okay, will people be drinking it 20 years from now?
Yeah, will people be using Windows 5, 6 years from now? Who knows?
Maybe so.
Maybe not.
That is a good business to be in. I mean, they deserve a high multiple because we're in quickly.
London job is the great.
In the thing on up, we'll go on symmetric multiprocessing to use more processors per
He doesn't even know what the fuck he's talking about.
system. We'll go from the 4, 8, or 16 you see today and using non-uniform memory addressing architecture, NUMA approaches go up to at least 128 processors per system. And then, of course, we'll cluster those systems together, which is not only a scalability technique, but a reliability technique.
They can't do computer clusters even in 2025
To create
optimally.
systems that will be able to do. There's no requirement.
Now Zen
An extra
Bill Gates
Really good
on the view like when
just this year is W build about and
those thing working out
but
between and
will survive in a form of
base
peaceful coexistence in
both
the future. But for now, there is survive.
really require
Some analysts believe both Windows and Java will survive in a form of peaceful coexistence in the future. But for now, there is little peace between Microsoft and Sun.
the pissing match between Sun and Microsoft is maybe
Only sync bill
couldn't run. We spend
until there even some of the
one was brewery so
program
knew more half that's what it's had. Reason that's
to be
there.
gave
I was really struck at
This video. Watch this whole video for nothing.
with a Japanese.
Not recalling this, the
Well, I'm not gonna find it. I give up. It used to be at the top. I'm not gonna find it. I give up. One more time. And I give up. Oh well. So I'm gonna have a chatbot read the scene or whatever. Keep things extremely boring. Because you shouldn't be watching the stream. You should go live your life. I'm just documenting whatever and blah blah blah.
context is pushed onto the stack and becomes the running execution context. An execution context contains whatever implementation-specific state is necessary to track the execution progress of its associated code. Each execution context has at least the state components listed in Table 25. Table 25. State components for all execution contexts. Component. Purpose. Code evaluation state.
And it did build, so.
And resume evaluation of the code associated with this execution context. Function. If this execution context is evaluating the code of a function object, then the value of this component is
Play,
if the context
run or whatever.
script or module, the value is null. Realm, the realm record from which associated code accesses ECMA script resources. Script or module, the module record or script record from which associated code originates.
I'm pretty sure everything works.
Module, as is the case for the original execution context created in initialize host-defined realm, the value is null. Evaluation of code by the running execution context may be suspended at various points defined within this
All I need to do is get byte replaced.
context has been suspended. A different execution context may
Replace all the 0xFF with byte, or ZX byte, whatever.
from later time a suspended execution context may again be
It's still running the program. Any second.
creating its code at the point where it had previously been suspended. Transition of the running execution context status among execution contexts usually occurs in stack-like last-in first-out manner. However, some ECMA script features require non-LFO transitions of the running execution context. The value of the realm component of the running execution context is also called the current realm
Copy the output,
component of the running
paste it,
execution object. ECMA
compare it to the rest.
state components listed in Table 26. Table 26. Additional state components for ECM execution contexts.
Is it the same number of lines? Yes.
Environment record used to resolve identifier references made by code.
Let's check the top.
Next, variable environment identifies the environment record that holds bindings created by variable.
Looks the same. Assuming it's all good.
Environment identifies the private
Saving backup. This is so boring.
elements and the nearest containing class null if there is no containing class. The lexical environment and variable environment components of an execution context are always environment records. Execution contexts representing the evaluation of generators have the additional state components listed in Table 27. ECMA International 2024 155. Table 27. Additional state components for generator execution contexts. In most situations only the running execution context, T, the top of the execution context stack, is directly manipulated by algorithms within this specification. Hence when the terms lexical environment and variable environment are used without qualification they are in reference to those components of the running execution context. An execution context is purely a specification mechanism and need not correspond to any particular artifact of an ECMA script implementation. It is impossible for ECMA script code to directly access or observe an execution context. 4.1 Get active script or module. The abstract operation get active script or module takes no arguments and returns a script record, a module record, or null. It is used to determine the running script module based on the running execution context. It performs the following steps when called. If the execution context stack is empty, return null. Let X be the topmost execution context on the execution context stack.
So, I got the backup. Everything runs. Alright, all I got left is replace the bytes with the new literal or whatever. And then here's a whatever. Okay, this does work. All right, everything's working. Here is a video talking about SteamOS and how Microsoft whatever is like, oh crap, and stuff or whatever. I gotta like scroll a bit and pause it and play it in case like copyright happens to like occur. So I don't know. I'm gonna like scroll up and down a little bit, pause it. That's why I'm doing that. It might break up if there's copyright music.
Microsoft panic. They just changed their internal plans and put a console on hold, all because SteamOS is outperforming Windows 11. And now Microsoft is stuck trying to catch up to Valve before it's too late. In May 2025, reports
Literally every like sound effect gets tagged by the freaking content ID.
indicated that Microsoft paused development of its
So I gotta like pause it. Just in case.
first-party Xbox handheld console, codenamed Pembroke, to focus on optimizing
Microsoft though wants Xbox handheld, but Microsoft decided to prioritize its teams to improve Windows 11 gaming performance. Now, why would Windows do that? Why would they stop building an Xbox handheld and decide to improve Windows 11 gaming? They need to improve tons of things on Windows. They don't though, because a new operating system and Windows won't even matter anymore. It'd be funny if SteamOS took over. That'd be really funny.
Windows 11 for third-party handheld devices like the Legion Go S. This comes right after the SteamOS Legion Go S release, which led to a bunch of tests comparing the two models, SteamOS versus Windows. Microsoft's decision to pause its first-party Xbox handheld is mainly because of the competitive pressures from Valve's SteamOS, which has shown better performance in
I looked this up earlier. I also had to restart.
first-party Xbox handheld, SteamOS versus Windows. Microsoft's two models, SteamOS is like the Legion Go S. This comes right after the SteamOS OS. This comes right is like the Legion Go S.
So this new thing, whatever Steam has, that Microsoft is terrified of. Oh, it did save the page. It has a
AMD Ryzen trademark sign Z2 Go processor, 3.00 GHz up to 4.30 GHz. Windows 11 Home 64. Integrated AMD Radeon trademark sign graphics, 32 GB.
This web browser sucks. Anyways, the new Steam, whatever you call it, that runs SteamOS, that Microsoft stopped development for making their own handheld Xbox, whatever it's called. It has a AMD Ryzen CPU.
AMD Ryzen trademark sign Z2 Go processor, 3.00 GHz up to 4.30 GHz. Windows 11 Home 64. Integrated AMD Radeon trademark sign graph.
So, this new AMD, whatever you call it, by Steam that runs SteamOS, is an 10 megabyte cache. This 15-year-old i7 computer has an 8 megabyte cache. Chatbot told me that L3 is all the cache and L1 is still part of the L3. So I'm going to go off what Chatbot said. So I would assume this is 8 megabytes. But if that's true, does this thing only have 8 megabyte cache? It said 10 earlier. Why does Chatbot do that? It doesn't even fucking know. I'll open up CPU-Z, see what it says. Does that mean this computer has 9 megabytes of cache? The cache makes no sense. It's fake. It's all flat memory, and they split it up. It's just dumb.
I have an Intel 17860 at 2.80 GHz. How much cache and compare the rest in comparison to the AMD Ryzen trademark Sign Z2 Go processor? Certainly. Let's compare the Intel Core i7-860 and the AMD Ryzen trademark Sign Z2 Go processor in terms of the specifications. Brain, Intel Core i7-860, released. 2009. Architecture, Linfield, 45nm, cores threads. 48, base boost clock. 2.80 GHz, 3.46 GHz. Cache, L1, 64 kilobytes per core. L2, 256 kilobytes per core. L3, 8 megabytes shared. TDP. 95W, socket, LGA 1156, integrated graphics, none, memory support, dual channel DDR3-1333, manufacturing process, 45nm. Gear, AMD Ryzen trademark Sign Z2 Go processor, released. 2025. Architecture, Zen 3 Plus, 6nm, cores threads. 48, base boost clock. 3.00 GHz, 4.30 GHz. Cache, L1, 64 kilobytes per core. L2, 2 megabytes shared. L3, 8 megabytes shared. TDP, 15-30W. Socket, FP7, integrated graphics, AMD Radeon 680M, 12 RDNA2 CUs, memory support, dual channel LPDDR5-6400 DDR5-4800, manufacturing process, 6nm.
So, I don't know. Core threads, 4.8, 4.8, 2.8, 3.46, 4.30, 8 megabytes, 1 megabyte. It only has 1 more megabyte cache. Chatbot said there's L1 cache too, with the i7. I don't know if Chatbot's changing the specs or merging them together. So, I don't know. I would have expected a bigger cache in the Ryzen. Doesn't matter though. I'm optimizing things for first gen i7, my JavaScript engine. That's what the CPU is, whatever. So like anything optimized for this potato is gonna run on any potato. Except this potato does have 32 gigs of RAM. Which is why it's perfect for like, I don't know, writing code on. Because there's only 8 megabytes cache, tons of RAM. So you can tell when the code is in memory or when it gets paged more frequently. So I don't know. So the benefit to optimizing for potato is that this AMD Ryzen Z2 Go processor looks like a potato, or it has specs close to that of a potato. So at least my JavaScript engine, when I'm done, it'll work on potatoes. And I think I might try to sell to SteamOS. I don't know. I still gotta pick. But that might be a good bet. And then SteamOS, they could protect it because it could be on the hardware. And SteamOS is made for gaming. That's why Windows stopped building its own Xbox handheld to improve Windows 11 gaming performance. So, all that. If I can get this done, they're gonna have another device if it does good. I don't know. A gaming JavaScript engine designed for gaming on SteamOS that's like new. It's like starting whatever. So if SteamOS does good, there's potential for me to do good and games to be made in JavaScript. And if Windows doesn't improve Windows 11 gaming performance, which are literally stopping making an Xbox handheld to do so, if they fail to do this, SteamOS might take the show in all the chips on the table. So if I was gonna place bets, I'd probably pick SteamOS. So I don't know. It seems like things are just like falling into place somehow. It's magical. So I gotta find something to eat. It's only 759. It's not that bad. So I need to get my JavaScript Engine done so I can sell it. I'm gonna go get some food or whatever. I'm gonna get back and I'm gonna like find and replace all the bytes with ZX byte, whatever. So, I don't know. I hope SteamOS does good. That means I could do good. I think that's center. I don't know. So I don't know. I'm gonna get some food. LBRB. I need to stop stalling and get some work done. Turn on Siri. Dang it. Of course it's not working. Dang it.
Elias binding. A boolean, and returns either a normal completion containing unused or a throw completion. It creates an initializer. The create global var binding concrete method of a global environment record envrec takes arguments n, a string, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates and initializes a mutable binding in the associated object environment record and records the bound name in the associated list. If a binding already exists, it is reused in.
So I don't know. If SteamOS does good, that'll be awesome. It'd be like things are just like magically falling into place.
Property.
This microphone, this streaming software is so bad. I don't know. LBRB. I get something to eat.
Principle is true, then a perform.
I wonder what's gonna like fall into place next. It's pretty cool.
Undefined. If envrec does not contain n, then a append n to envrec7. Return unused, 1, 1, 4, 1, 8. Create global function binding, n, v, d. The create global function binding concrete method of a global environment record envrec takes arguments n, a string, v, an ECMA script language value, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates and initializes a mutable binding in the associated object environment record and records the bound name in the associated list. If a binding already exists, it is 2, 3, 4, 7, 8, replaced. It performs the following steps when called. Let objrec be envrec. Let global object be objrec. Let existing prop be global object. N. If existing prop is undefined or existing prop is true, then a let desc be the property descriptor. V. True, true. D. Else a let desc be the property descriptor. V. Perform. Define property or throw, global object. N. Desc. Perform. Set, global object, n, v, false. If envrec does not contain n, then a append n to envrec. Return unused. 48. ECMA International 2024. Note global function declarations are always represented as own properties of the global object. If possible, an existing own property is reconfigured to have a standard set of attribute values. Step 7 is equivalent to what calling the initialize binding concrete method would do, and if global object is a proxy will produce the same sequence of proxy trap calls, 1, 1, 5 module environment records. A module environment record is a declarative environment record that is used to represent the outer scope of an ECMA script module. In addition to normal mutable and immutable bindings, module environment records also provide immutable import bindings, which are bindings that provide indirect access to a target binding that exists in another environment record. Module environment records support all of the declarative environment record methods listed in Table 16 and share the same specifications for all of those methods except for get binding value, delete binding, has this binding, and get this binding. In addition, module environment records support the methods listed in Table 22. Table 22, additional methods of module environment records. The behavior of the additional concrete specification methods for module environment records are defined by the following algorithms, 1, 1, 5, 1 get binding value, n, s. The get binding value concrete method of a module environment record envrec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMA script language value or a throw completion. It returns the value of its bound identifier whose name is n. However, if the binding is an indirect binding, the value of the target binding is returned. If the binding exists but is uninitialized, a reference error is thrown. It performs the following steps when called. Assert. S is true. Assert. Envrec has a binding for n. If the binding for n is an indirect binding, then, let m and n2 be the indirection values provided when this binding for n was created. B let target env be m. C if target env is empty, throw a reference error exception. D return target env get binding value. N2, true, if the binding for n in envrec is an uninitialized binding, throw a reference error exception. Return the value currently bound to n in envrec. Note S will always be true because a module is always strict mode code 9. 1, 1, 5. To delete binding, n. The delete binding concrete method of a module environment record is never used within this specification. Method. Purpose. Create import binding, n, m, n2. Create an immutable indirect binding in a module environment record. The string value n is the text of the bound name. M is a module record, and n2 is a binding that exists in m's module environment record. Get this binding. Return the value of this environment records this binding. Copyright sign, ECMA International 2024 149. Note module environment records are only used within strict code, and an early error rule prevents the delete operator in strict code. from being applied to a reference record that would resolve to a module environment record binding. C135111,1,5, 3 has this binding. The has this binding concrete method of a module environment record envrec takes no arguments and returns true. It performs the following steps when called. Return true, 1, 1, 5. For get this binding. The get this binding concrete method of a module environment record envrec takes no arguments and returns a normal completion containing undefined. It performs the following steps when called. Return undefined, 1, 1, 5. Create import binding, n, m, n2. The create import binding concrete method of a module environment record envrec takes arguments n, a string, m, a module record, and n2, a string, and returns unused. It creates a new initialized immutable indirect binding for the name n. A binding must not already exist in this environment record for n. N2 is the name of a binding that exists in m's module environment record. Accesses to the value of the new binding will indirectly access the bound value of the target binding. It performs the following steps when called. Assert. Envrec does not already have a binding for n. Assert. When m is instantiated, it will have a direct binding for n2. Create an immutable indirect binding in envrec for n that references m and n2 as its target binding and record that the binding is initialized. Return unused, 1.2 environment record operations. The following abstract operations are used in this specification to operate upon environment records. 9, 1, 2, 1 get identifier reference, env, name, strict. The abstract operation get identifier reference takes arguments env, an environment record or null, name, a string, and strict, a boolean, and returns either a normal completion containing a reference record or a throw completion. It performs the following steps when called. If env is null, then a return the reference record, unresolvable, name, strict. This value, empty. Let exists be env has binding. Name if exists is true, then a return the reference record, env, name, strict, empty. Else, 150. ECMA International 2024. Note, module environment records always provide this binding. AB, let outer be env, return. Get identifier reference, outer, name, strict. 9, 1, 2. To new declarative environment. E. The abstract operation new declarative environment takes argument E, an environment record or null, and returns a declarative environment record. It performs the following steps when called. Let env be a new declarative environment record containing no bindings. Set env to E. Return env, 1, 2, 3 new object environment. O, W, E. The abstract operation new object environment takes arguments O, an object, W, a boolean, and E, an environment record or null, and returns an object environment record. It performs the following steps when called. Let env be a new object environment record. Set env to O, set env to W, set env to E. Return env, 1, 2, 4 new function environment, F, new target. The abstract operation new function environment takes arguments F, an ECMA script function object, and new target, an object or undefined, and returns a function environment record. It performs the following steps when called. Let env be a new function environment record containing no bindings. Set env to F. If F is lexical, set env to lexical. Else, set env to uninitialized. Set env to new target. Set env to F. Return env, 1, 2, 5 new global environment, G, this value. The abstract operation new global environment takes arguments G, an object, and this value, an object, and returns a global environment record. It performs the following steps when called. Let objrec be new object environment, G, false, null. Let dclrec be new declarative environment, null. Let env be a new global environment record. Set env to objrec. Set env to this value. Set env to dclrec. Set env to a new empty list. Set env to null. Return env, 1, 2, 6. New module environment. E. The abstract operation new module environment takes argument E, an environment record, and returns a module environment record. It performs the following steps when called. Let env be a new module environment record containing no bindings. Set env to E. Return env. ECMA International 2024 151. 9.2 Private environment records. A private environment record is a specification mechanism used to track private names based upon the lexical nesting structure of class declarations and class expressions in ECMA script code. They are similar to, but distinct from, environment records. Each private environment record is associated with a class declaration or class expression. Each time such a class is evaluated, a new private environment record is created to record the private names declared by that class. Each private environment record has the fields defined in Table 23. Table 23. Private environment record fields. Field name, value type, meaning, outer private environment. A. Private environment record or null. The private environment record of the nearest containing class null if the class with which this private environment record is associated is not contained in any other class. Names, a list of private names. The private names declared by this class. 9. 2. 1. Private environment record operations. The following abstract operations are used in this specification to operate upon private environment records. 9. 2. 1. 1. New private environment. Outer privy env. The abstract operation new private environment takes argument outer privy env, a private environment record or null, and returns a private environment record. It performs the following steps when called. Let names be a new empty list. Return the private environment record. Outer privy env, names, 2, 1. To resolve private identifier, privy env, identifier. The abstract operation resolve private identifier takes arguments privy env, a private environment record, and identifier, a string, and returns a private name. It performs the following steps when called. Let names be privy env. For each private name pn of names, do if pn is identifier. Then I return pn. Let outer privy env be privy env. Pivot environment. Assert. Outer privy env is not null. Return resolve private identifier. Outer privy env. Identifier. 3 realms. Before it is evaluated, all ECMA script code must be associated with the realm. Conceptually, a realm consists of a set of intrinsic objects, an ECMA script global environment, all of the ECMA script code that is loaded within the scope of that global environment, and other associated state and resources. A realm is represented in this specification as a realm record with the fields specified in Table 24. 52. Copyright sign. ECMA International 2024. Table 24. Realm record fields. Field name. Agent signifier. Intrinsics. Global object. Global env. Template map. An object or undefined value. An agent signifier. A record whose field names are intrinsic keys and whose values are objects. A global environment record. A list of records with fields. A template literal. Parse node. And v. An array. F. The agent that owns this realm, the global object for this realm, the global environment for this realm, meaning the intrinsic values used by code associated with this realm, a list of records with fields are a string and a module record. Note 1. Once a parse node becomes unreachable, the corresponding is also unreachable, and it would be unobservable if an implementation removed the pair from the list. Anything default value is undefined. Note 2 as mentioned in host load imported module 16.2.1.8. Note 1. In realm records is only used when running an import expression in a context where there is no active script or module. Field reserved for use by hosts that need to associate additional information with a realm record. Template objects are canonicalized separately for each realm using its realm records. Each value is a parse node that is a template literal. The associated ALU is the corresponding template object that is passed to a tag function, a map from the strings in.
Alright, that's enough random tangents for now. I'm gonna try to get something done. Replace keywords and then deal with shifts and stuff. I don't know. Bark bark.
the following steps when called. Let realm rec be a new realm record. Perform create intrinsics. Realm rec. Set realm rec to agent signifier. Set realm rec to undefined. Set realm rec to undefined. Set realm rec to a new empty list. Return realm rec. ECMA International 2024 153 9.
I need to find music and stuff. So take a second.
The abstract operation create intrinsics takes argument realm rec.
This stream isn't supposed to be exciting.
It performs the following.
I wouldn't watch this if I were you. I would go live my life.
Listed in table 6.
I'm just documenting stuff. Unless you get something out of programming or when doing assembly. If you're learning something, then whatever. I don't know.
Specification of each object in clauses 19 through 28. All object property values are newly created object values. All values that are built-in function objects are created by performing create built-in function steps. Length, name, slots, realm rec, prototype, where steps is the definition of that function provided by this specification. Name is the initial value of the function's name property. Length is the initial value of the function's length property. Slots is a list of the names, if any, of the function's specified internal slots. And prototype is the specified value of the function's internal slot. The creation of the intrinsics and their properties must be ordered to avoid any dependencies upon objects that have not yet been created. Perform capital A, D, D, capital R, E, S, T, R, I, C, T, E, D, capital F, U, N, C, T, I, O, N, capital P, R, O, P, E, R, T, I, E, realm rec. Realm rec. Return unused, 3.3 set realm global object. Realm rec. Global OBJ. This value. The abstract operation set realm global object takes arguments realm rec. A realm record. Global OBJ. An object or undefined. And this value. An object or undefined. And returns unused. It performs the following steps when called. If global OBJ is undefined, then a let intrinsics be realm rec. B set global OBJ to ordinary object create. Intrinsics. Assert. Global OBJ is an object. If this value is undefined, set this value to global OBJ. Set realm rec to global OBJ. Let new global env be new global environment. Global OBJ. This value. Set realm rec to new global env. Return unused, 3.4 set default global bindings. Realm rec. The abstract operation set default global bindings takes argument realm rec, a realm record, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let global be realm rec for each property of the global object specified in clause 19. Do a let name be the string value of the property name. B let desk be the fully populated data property descriptor for the property, containing the specified attributes for the property. For properties listed in 19.2, 19.3, or 19.4, the value of the attribute is the corresponding intrinsic object from realm rec. See perform. Define property or throw global name desk return global. Point 4 execution contexts. An execution context is a specification device that is used to track the runtime evaluation of code by an ECMA script implementation. At any point in time, there is at most one execution context per agent that is actually executing code. This is known as the agent's running execution context. All references to the running execution C on text in this specification denote the running execution context of the surrounding agent. The execution context stack is used to track execution contexts. The running execution context is always the top element of this. Context to executable code that is not associated with that. 54. Copyright sign. ECMA International 2024 Execution Context. The newly created execution context is pushed onto the stack and becomes the running execution context. An execution context contains whatever implementation-specific state is necessary to track the execution progress of its associated code. Each execution context has at least the state components listed in Table 25. Table 25. State components for all execution contexts. Component. Purpose. Code evaluation state. Any state needed to perform, suspend, and resume evaluation of the code associated with this execution context. Function. If this execution context is evaluating the code of a function object, then the value of this component is that function object. If the context is evaluating the code of a script or module, the value is null. Realm. The realm record from which associated code accesses ECMA script resources. Script or module. The module record or script record from which associated code originates. If there is no originating script or module, as is the case for the original execution context created in initialize host-defined realm, the value is null. Evaluation of code by the running execution context may be suspended at various points defined within this specification. Once the running execution context has been suspended, a different execution context may become the running execution context and commence evaluating its code. At some later time, a suspended execution context may again become the running execution context and continue evaluating its code at the point where it had previously been suspended. Transition of the running execution context status among execution contexts usually occurs in stack-like last-in first-out manner. However, some ECMA script features require non-LFO transitions of the running execution context. The value of the realm component of the running execution context is also called the current realm record. The value of the function component of the running execution context is also called the active function object. ECMA script code execution contexts have the additional state components listed in Table 26. Table 26. Additional state components for ECMA script code execution contexts. Component. Purpose. Lexical environment. Identifies the environment record used to resolve identifier references made by code within this execution context. Variable environment. Identifies the environment record that holds bindings created by variable statements within this execution context. Private environment. Identifies the private environment record that holds private names created by class elements and the nearest containing class null if there is no containing class. The lexical environment and variable environment components of an execution context are always environment records. Execution contexts representing the evaluation of generators have the additional state components listed in Table 27. ECMA International 2024 155. Table 27. Additional state components for generator execution contexts. In most situations, only the running execution context, the top of the execution context stack, is directly manipulated by algorithms within this specification. Hence, when the terms lexical environment and variable environment are used without qualification, they are in reference to those components of the running execution context. An execution context is purely a specification mechanism and need not correspond to any particular artifact of an ECMA script implementation. It is impossible for ECMA script code to directly access or observe an execution context. 4.1 Get active script or module. The abstract operation get active script or module takes no arguments and returns a script record, a module record, or null. It is used to determine the running script or module based on the running execution context. It performs the following steps when called. If the execution context stack is empty, return null. Let X be the topmost execution context on the execution context stack whose script or module component is not null. If no such execution context exists, return null. Otherwise, return X script or module. 4.2 Resolve binding. Name. env. The abstract operation resolve binding takes argument name, a string, and optional argument env, an environment record or undefined, and returns either a normal completion containing a reference record or a throw completion. It is used to determine the binding of name. env can be used to explicitly provide the environment record that is to be searched for the binding. It performs the following steps when called. If env is not present or env is undefined, then A set env to the running execution context's lexical environment. Assert env is an environment record if the source text match by the syntactic production that is being evaluated is contained in strict mode. Code. Let strict be true, else let strict be false. Return. Get identifier reference. env. Name. Strict, 4.3 get this environment. The abstract operation get this environment takes no arguments and returns an environment record. It finds the environment record that currently supplies the binding of the keyword this. It performs the following steps when called. Let env be the running execution context's lexical environment 2. Repeat. Component purpose. Generator the generator that this execution context is evaluating. 156. ECMA International 2024. Note the result of resolve binding is always a reference record whose field is name. ABCDE. Let exists be env has this binding. If exists is true, return env. Let outer be env. Assert. Outer is not null. Set env to outer. Note the loop in step 2 will always terminate because the list of environments always ends with the global environment which has a this binding. 4.4 resolve this binding. The abstract operation resolve this binding takes no arguments and returns either a normal completion containing an ECMA script language value or a throw completion. It determines the binding of the keyword this using the lexical environment of the running execution context. It performs the following steps when called. Let env rec be get this environment. Return env rec get this binding. 4.5 get new target. The abstract operation get new target takes no arguments and returns an object or undefined. It determines the new target value using the lexical environment of the running execution context. It performs the following steps when called. Let env rec be get this environment. Assert. env rec has a field. Return env rec, 4.6 get global object. The abstract operation get global object takes no arguments and returns an object. It returns the global object used by the currently running execution context. It performs the following steps when called. 2.5 let current realm be the current realm record. Return current realm, jobs and host operations to enqueue jobs. A job is an abstract closure with no parameters that initiates an ECMA script computation when no other ECMA script computation is currently in progress. Jobs are scheduled for execution by ECMA script host environments in a particular agent. This specification describes the host hook's host enqueue generic job. Capital H, O, S, T, capital E, N, Q, U, E, U, E, capital F, I, N, A, L, I, Z, A, T, I, O, N, capital R, E, G, I, S, T, R, host enqueue promise job, and host enqueue timeout job to schedule jobs. The host hooks in this specification are organized by the additional constraints imposed on the scheduling of jobs. Hosts may define additional abstract operations which schedule jobs. Such operations accept a job abstract closure and a realm record or null, as parameters. If a realm record is provided, these operations schedule the job to be performed at some future time in the provided realm, in the agent that owns the realm. If null is provided instead for the realm, then the job does not evaluate ECMA script code. Their implementations must conform to the following requirements. At some future point in time, when there is no running context in the agent for which the job is scheduled and that agent's execution context stack is empty, the implementation must perform any host-defined preparation steps, invoke the job abstract closure, perform any host-defined cleanup steps, after which the execution context stack must be empty. Only one job may be actively undergoing evaluation at any point in time in an agent. Once evaluation of a job starts, it must run to completion before evaluation of any other job starts in an agent. The abstract closure must return a normal completion, implementing its own handling of errors. ECMA International 2024 157. Note 1 host environments are not required to treat jobs uniformly with respect to scheduling. For example, Web browsers and Node.js treat promise handling jobs as a higher priority than other work. Future features may add jobs that are not treated at such a high priority. At any particular time, script or module, a script record, a module record, or null, is the active script or module if all of the following conditions are true. Get active script or module is script or module if script or module is a script record or module record. Let EC be the topmost execution context on the execution context stack whose script or module component is script or module. The realm component of EC is script or module. At any particular time, an execution is prepared to evaluate ECMA script code if all of the following conditions are true. The execution context stack is not empty. The realm component of the topmost execution context on the execution context stack is a realm record. Particular kinds of jobs have additional conformance requirements. 5.1 Job callback records. A job callback record is a record value used to store a function object and a host-defined value. Function objects that are invoked via a job enqueued by the host may have additional host-defined context. To propagate the state, job abstract closures should not capture and call function objects directly. Instead, use host make job callback and host call job callback. Job callback records have the fields listed in Table 28. Table 28. Job callback record fields. 5.2 Host make job callback. Callback, the host-defined abstract operation host make job callback takes argument callback, a function object, and returns a job callback record. An implementation of host make job callback must conform to the following requirements. It must return a job callback record whose field is callback. Note: 2 host environments may prepare an execution to evaluate code by pushing execution contexts onto the execution context stack. The specific steps are implementation defined. The specific choice of realm is up to the host environment. This initial execution context and realm is only in use before any callback function is invoked. When a callback function related to a job, like a promise handler, is invoked, the invocation pushes its own execution context and realm. Note the WHATWG.html specification, https://html.spec.whatwg.org/ for example, uses the host-defined value to propagate the incumbent settings object for promise callbacks. Field name value meaning callback, a function object, the function to invoke when the job is invoked. Host-defined, anything default value is empty. Field reserved for use by hosts. 158. ECMA International 2024. The default implementation of host make job callback performs the following steps when called. 1. Return the job callback record. Callback empty. ECMA script hosts that are not web browsers must use the default implementation of host make job callback. 5.3 Host call job callback. Job callback v arguments list. The host-defined abstract operation host call job callback takes arguments job callback, a job callback record, v, an ECMA script language value, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or a throw completion. An implementation of host call job callback must conform to the following requirements. It must perform and return the result of call job callback v arguments list. The default implementation of host call job callback performs the following steps when called. Assert is callable. Job callback is true. Return call job callback v arguments list. ECMA script hosts that are not web browsers must use the default implementation of host call job callback. 5.4 Host enqueue generic job realm. The host-defined abstract operation host enqueue generic job takes arguments job, a job abstract closure, and realm, a realm record, and returns unused. It schedules job in the realm in the agent signified by realm to be performed at some future time. The abstract closures used with this algorithm are intended to be scheduled without additional constraints, such as priority and ordering. An implementation of host enqueue generic job must conform to the requirements in 9.5. 9.5. 5 Host enqueue promise job Realm. The host-defined abstract operation host enquire promise job takes arguments job, a job abstract closure, and realm, a realm record or null, and returns unused. It schedules job to be performed at some future time. The abstract closures used with this algorithm are intended to be related to the handling of promises, or otherwise, to be scheduled with equal priority to promise handling operations. An implementation of host enquire promise job must conform to the requirements in 9.5 as well as the following. If realm is not null, each time job is invoked, the implementation must perform implementation-defined steps such that execution is prepared to evaluate ECMA script code at the time of job's invocation. Let script or module be get active script or module at the time host enquire promise job is invoked. If realm is not null, each time job is invoked, the implementation must perform implementation-defined steps such that script or module is the active script or module at the time of job's invocation. Jobs must run in the same order as the host enquire promise job invocations that scheduled them. Note this is called at the time that the callback is passed to the function that is responsible for its being eventually scheduled and run. For example, promise then action, calls make job callback on then action at the time of invoking promise prototype then, not at the time of scheduling the reaction job. Note this requirement means that hosts cannot change the behavior of function objects defined in this specification. ECMA International 2024 159. Note the realm for jobs returned by new promise resolved thenable job is usually the result of calling get function realm on the then function object. The realm for jobs returned by new promise reaction job is usually the result of calling get function realm on the handler if the handler is not undefined. If the handler is undefined, realm is null. For both kinds of jobs, when get function realm completes abnormally, that is called on a revoked proxy, realm is the current realm record at the time of the get function realm call. When the realm is null, no user ECMA script code will be evaluated and no new ECMA script objects, for example, error objects, will be created. The WHATWG-HTML specification, https://html.spec.whatwg.org/ for example, uses realm to check for the ability to run script and for the entry, https://html.spec.whatwg.org/ /entry concept, 5.6 host enquire timeout job, realm, milliseconds. The host-defined abstract operation host enquire timeout job takes arguments timeout job, a job abstract closure, realm, a realm record, and milliseconds, a non-negative finite number, and returns unused. It schedules timeout job in the realm in the agent signified by realm to be performed after at least milliseconds. An implementation of host enquire timeout job must conform to the requirements in 9.5. 9.6 Initialize host-defined realm. The abstract operation initialize host-defined realm takes no arguments and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. Let realm be create realm. Let new context be a new execution context. Set the function of new context to null. Set the realm of new context to realm. Set the script or module of new context to null. Push new context onto the execution context stack. New context is now the running execution context. If the host requires use of an exotic object to serve as realm's global object, let global be such an object created in a host-defined manner. Otherwise, let global be undefined, indicating that an ordinary object should be created as the global object. If the host requires that this binding in realm's global scope return an object other than the global object, let this value be such an object created in a host-defined manner. Otherwise, let this value be undefined, indicating that realm's global this binding should be the global object. Perform set realm global object, realm, global. This value 0. Let global obj be. Set default global bindings. Realm 1. Create any host-defined global object properties on global obj 2. Return unused. 0.7 Agents. An agent comprises a set of ECMA script execution contexts, an execution context stack, a running execution context, an agent record, and an executing thread. Except for the executing thread, the constituents of an agent belong exclusively to the agent. An agent's executing thread executes algorithmic steps on the agent's execution contexts independently of other agents, except that an executing thread may be used as the executing thread by multiple agents, provided none of the agents sharing the thread have an agent record whose field is true. Note 1. Some web browsers share a single executing thread across multiple unrelated tabs of a browser window. For example, 60, copyright sign, ECMA International 2024. While an agent's executing thread is executing algorithmic steps, the agent is the surrounding agent for those steps. The steps use the surrounding agent to access the specification-level execution objects held within the agent, the running execution context, the execution context stack, and the agent records fields. An agent signifier is a globally unique opaque value used to identify an agent. Table 29. Agent record fields. Field name, value, meaning, little endian, a boolean. The default value computed for the is little endian parameter when it is needed by the algorithm's get value from buffer and set value in buffer. The choice is implementation defined and should be the alternative that is most efficient for the implementation. Once the value has been observed, it cannot change. Can block. A boolean determines whether the agent can block or not. Signifier. An agent signifier uniquely identifies the agent within its agent cluster. Is lock-free 1. A boolean, true if atomic operations on 1 byte values are lock-free. False otherwise. Is lock-free 2. A boolean, true if atomic operations on 2 byte values are lock-free. False otherwise. Is lock-free 8. A boolean, true if atomic operations on 8-byte values are lock-free. False otherwise. Candidate execution. A. Candidate execution record. See the memory model. Kept alive. A list of either objects or symbols, initially a new empty list, representing the list of objects and or symbols to be kept alive until the end of the current job. Once the values of and have been observed by any agent in the agent cluster, they cannot change. Note 2. The values of and are not necessarily determined by the hardware, but may also reflect implementation choices that can vary over time and between ECMA script implementations. There is no field. 4-byte atomic operations are always lock-free. In practice, if an atomic operation is implemented with any type of lock, the operation is not lock-free. Lock-free does not imply wait-free. There is no upper bound on how many machine steps may be required to complete a lock-free atomic operation. That an atomic access of size n is lock-free does not imply anything about the perceived atomicity of non-atomic accesses of size n. Specifically, non-atomic accesses may still be performed as a sequence of several separate memory accesses. See Read Shared Memory and Write Shared Memory for details. ECMA International 2024 161. Note 3. An agent is a specification mechanism and need not correspond to any particular artifact of an ECMA script implementation. 7.1 Agent signifier. The abstract operation agent signifier takes no arguments and returns an agent signifier. It performs the following steps when called. Let AR be the agent record of the surrounding agent. Return AR, 7.2 Agent can suspend. The abstract operation agent can suspend takes no arguments and returns a boolean. It performs the following steps when called. 2.8 Let AR be the agent record of the surrounding agent. Return AR, agent clusters. Note in some environments it may not be reasonable for a given agent to suspend. For example, in a web browser environment, it may be reasonable to disallow suspending a document's main event handling thread, while still allowing workers' event handling threads to suspend. An agent cluster is a maximal set of agents that can communicate by operating on shared memory. Every agent belongs to exactly one agent cluster. All agents within a cluster must have the same value for the field in their respective agent records. All agents within a cluster must have the same values for the field in their respective agent records. Similarly for the field, all agents within a cluster must have different values for the field in their respective agent records. An embedding may deactivate, stop forward progress, or activate, resume forward progress, an agent without the agent's knowledge or cooperation. If the embedding does so, it must not leave some agents in the cluster active while other agents in the cluster are deactivated indefinitely. Note 1. Programs within different agents may share memory by unspecified means. At a minimum, the backing memory for shared array buffers can be shared among the agents in the cluster. There may be agents that can communicate by message passing that cannot share memory. They are never in the same agent cluster. Note 2: the agents in a cluster need not all be alive at some particular point in time. If agent A creates another agent B, after which A terminates and B creates agent C, the three agents are in the same cluster if A could share some memory with B and B could share some memory with C. Note 3: if different agents within an agent cluster have different values of it becomes hard to use shared memory for multi-byte data. 62. Copyright sign, ECMA International 2024. Note 4. The purpose of the preceding restriction is to avoid a situation where an agent deadlocks or starves because another agent has been deactivated. For example, if an HTML shared worker that has a lifetime independent of documents in any windows were allowed to share memory with the dedicated worker of such an independent document, and the document and its dedicated worker were to be deactivated while the dedicated worker holds a lock, say, the document is pushed into its Windows history, and the shared worker then tries to acquire the lock, then the shared worker will be blocked until the dedicated worker is activated again, if ever. Meanwhile, other workers trying to access the shared worker from other windows will starve. The implication of the restriction is that it will not be possible to share memory between agents that don't belong to the same suspend wake collective within the embedding. An embedding may terminate an agent without any of the agent's cluster's other agents' prior knowledge or cooperation. If an agent is terminated not by programmatic action of its own or of another agent in the cluster but by forces external to the cluster, then the embedding must choose one of two strategies: either terminate all the agents in the cluster, or provide reliable APIs that allow the agents in the cluster to coordinate so that at least one remaining member of the cluster will be able to detect the termination, with the termination data containing enough information to identify the agent that was terminated. Each of the following specification values, and values transitively reachable from them, belong to exactly one agent cluster. Candidate execution record, shared data block, waitlist record. Prior to any evaluation of any ECMA script code by any agent in a cluster, the field of the agent record for all agents in the cluster is set to the initial candidate execution. The initial candidate execution is an empty candidate execution whose field is a list containing, for each agent, an agent events record whose field is that agent's agent signifier, and whose fields are empty lists. Note 5 examples of that type of termination are operating systems or users terminating agents that are running in separate processes, the embedding itself terminating an agent that is running in process with the other agent's WinPer. Agent resource accounting indicates that the agent is runaway. Note 6: all agents in an agent cluster share the same candidate execution in its agent records field. The candidate execution is a specification mechanism used by the memory model. Note 7: an agent cluster is a specification mechanism and need not correspond to any particular artifact of an ECMA script implementation. Point 9: forward progress. For an agent to make forward progress is for it to perform an evaluation step according to this specification. An agent becomes blocked when its running execution context waits synchronously and indefinitely for an external event. Only agents whose agent records field is true can become blocked in this sense. An unblocked agent is one that is not blocked. Implementations must ensure that every unblocked agent with a dedicated executing thread eventually makes forward progress. In a set of agents that share an executing thread, one agent eventually makes forward progress. Capital E, CMA International 2024 163. An agent does not cause another agent to become blocked except via explicit APIs that provide blocking. Point 10: processing model of weak ref and finalization registry targets 9.10. 1 objectives. This specification does not make any guarantees that any object or symbol will be garbage collected. Objects or symbols which are not live may be released after long periods of time, or never at all. For this reason, this specification uses the term may when describing behavior triggered by garbage collection. The semantics of weak refs and finalization registries is based on two operations which happen at particular points in time. When weak ref prototype derf is called, the referent, if undefined is not returned, is kept alive so that subsequent synchronous accesses also return the same value. This list is reset when synchronous work is done using the clear-kept objects abstract operation. When an object or symbol which is registered with the finalization registry becomes unreachable, a call of the finalization registry's cleanup callback may eventually be made after synchronous ECMA script execution completes. The finalization registry cleanup is performed with the cleanup finalization registry abstract operation. Neither of these actions, clear-kept objects or cleanup finalization registry, may interrupt synchronous ECMA script execution. Because hosts may assemble longer, synchronous ECMA script execution runs, the specification defers the scheduling of clear-kept objects and cleanup finalization registry to the host environment. Some ECMA script implementations include garbage collector implementations which run in the background, including when ECMA script is idle. Letting the host environment schedule cleanup finalization registry allows it to resume ECMA script execution in order to run finalizer work, which may free up held values, reducing overall memory usage. 10.2 Liveness. For some set of objects and or symbols S, a hypothetical weak ref oblivious execution with respect to S is an execution whereby the abstract operation weak ref deriv of a weak ref whose referent is an element of S always returns undefined. This, along with the liveness guarantee in the memory model, ensures that all sec.cst writes note eventually become observable to all agents. Note 1 weak ref obliviousness, together with liveness, capture two notions. 1. That a weak ref itself does not keep its referent alive. 2. That cycles in liveness does not imply that a value is live. To be concrete, if determining V's liveness depends on determining the liveness of a weak ref referent, R's liveness cannot assume V's liveness, which would be circular reasoning. Note 2 weak ref obliviousness is defined on sets of objects or symbols instead of individual values to account for cycles. If it were defined on individual values, then a weak ref referent in a cycle will be considered live even though its identity is only observed via other weak ref referents in the cycle. Note 3 colloquially, we say that an individual object or symbol is live if every set containing it is live. At any point during evaluation, a set of objects and or symbols S is considered live if either of the following conditions is met. Any element in S is included in any agents list 164. ECMA International 2024, there exists a valid future hypothetical weak ref oblivious execution with respect to S that observes the identity of any value in S. Note 4 the second condition above intends to capture the intuition that a value is live if its identity is observable via non-weak ref means. A value's identity may be observed by observing a strict equality comparison or observing the value being used as key in a map. Note 5. Presence of an object or a symbol in a field, an internal slot, or a property does not imply that the value is live. For example, if the value in question is never passed back to the program, then it cannot be observed. This is the case for keys in a weak map, members of a weak set, as well as the infields of a finalization registry cell record. The above definition implies that, if a key in a weak map is not live, then its corresponding value is not necessarily live either. Note 6 liveness is the lower bound for guaranteeing which weak refs engines must not empty. Liveness is defined here as undecidable. In practice, engines use conservative approximations such as reachability. There is expected to be significant implementation leeway. 10.3 Execution. At any time, if a set of objects and or symbols S is not live, an ECMA script implementation may perform the following steps atomically. For each element value of S, do a for each weak ref such that ref is value. Do I set ref to empty. B for each finalization registry FG such that FG contains a record cell such that cell is value. Do I set cell to empty. 2. Optionally, perform capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R F G. C for each weak map such that map contains a record R such that R value. Do I set R to set R to empty. D for each weak set such that set contains value. do, I replace the element of set whose value is value with an element whose value is empty. ECMA International 2024 165.
Visual Studio sucks. I wrote this program 7 years ago. There was no chatbot. There might have been. I didn't know about it. If it was, I don't know how old chatbot is. I've just known the last 2 years maybe. But now, the chatbot's a thing. I was kind of hoping they could like ask chatbot a question and then get some kind of like helpful information that I can't find on Google myself. So this 0x0001, that's 1. 0x FLE, that's -2, which is the invert of 1. It's the -2 signs complement. Or 2's complement, whatever. So we paste this into the calculator. I got 0x1. I'm going to invert it with a not. Or 1's complement. That's inverted. Now I'm going to shift left 32 bits, then shift right 32 bits to get rid of the top 32 bits because this is a 64-bit number. It's a 63, whatever. I want it to be a 32-bit number because this is a 32-bit program. I'm making it 64-bit. So I'm going to shift left 32 and right 32. It's shifted left 32. It's kind of blurry, but whatever. The bottoms are 0. I'm going to shift it back right 32. And that's the invert of 1. Copy it. I don't know, this says AA. So I'm going to copy this, paste it to prove that, I don't know. I copied that number, it's not pasted. So clearly, I have AA in the clipboard. It's not that other number, it's literally whatever. So I'm going to copy this number. This is literally what it was. I'm just proving that what the heck is going on. I'm going to paste. I remember dealing with this before, but I don't remember the solution. I don't want to waste time figuring it out. I could probably look at all this shit, but then I gotta like find other stuff to look at and compare and figure out. So, this should be true. This way I asked chatbot. Copy it. Copy the question and paste it. do Control F. These two are the same. These two lines. No typos, literally. They should be equal. This should flip the bits, make it positive, which would be 0x 001. XOR should be 0. 0. Let's check out this.
In MSVC, how is the FULZ? How do I test the HEXDEC literals to compare for equality? Is this not true? What even? If 0 times 0, 0, 0, 0, 0, 0, 0, 1, 0's fair error. CNDOPR2 is neck, the NX must be an inverse def, and if you're absolutely right to be confused. That expression is pretty twisted. Let's break it down and make some MSVCC preprocessor sense out of it. This is a preprocessor conditional that checks whether 0 times 0, 0, 0, 0, 0, 0, 0, 1, 0's fair. Evaluates to true, that is, non-zero, in which case it throws an error. Brain, step-by-step breakdown. Let's evaluate. N32-bit unsigned. Bitwise not. Flips the bits. So 0 x ff ff capital E equals 0 x 0 0 0 0 0 0 0 1 0 times 0 0 0 0 0 0 0 1 circumflex 0 times 0 0 0 0 0 0 0 1. XOR of identical numbers is always 0. 0 times 0 0 0 0 0 0 0 1. Capital X, or 0 times 0 0 0 0 0 0 0 1 equals sign. 0 times 0 0 0 0 0 0 0 0. If 0 times 0 0 0 0 0 0 0 1, 0's fair. XOR 0 capital X FFE becomes if 0, which does not trigger the error, meaning the values are equal and the test passes. Face with open eyes and mouth with head exploding. Why is this weird? The logic is backward. The error suggests the test is there to fail if n x and z x are not equal, but since the condition evaluates to 0, it doesn't throw an error, indicating z x equals nx, which is the intended match. No, it's throwing an error. I was saying the result is false, not that it is 0. Ah, got it. Thanks for clarifying. You're saying the expression is evaluating as true, non-zero, when it shouldn't. It enters the error branch, even though you're logically expecting it to be false, 0, because 0's fair should equal 0 times 0,000,000,001. So yes, you're right to be mad. Let's dig into why this happens specifically in MSVC's preprocessor. Firecracker. The root problem. Preprocessor integer math is not standard C. The C preprocessor doesn't work exactly like the C compiler. It only deals with literal integer expressions, and behavior like bitwise not can be weird due to sign extension and type assumptions.
That's fucking stupid.
Evaluation. 0's fair is a 32-bit value, but in preprocessor math it may be treated as signed, because literals like 0's fair are not automatically unsigned. On a 32-bit system, 0's fair is unsigned. 4,294,967,294, signed, minus 2, minus 2, in 2's complement equals 1 that works in C code. But Broom. Preprocessor quirk. Signed interpretation wrecks this if MSVC's preprocessor treats 0's fair as signed, int, then 0's fair becomes minus 2 equals 1 expected. But it might interpret 0 times 0,000,000,001 as unsigned, and 0's fair as signed, and then use signs or unsigned integer promotion kicks in, causing the expression to evaluate incorrectly. Tick. Try this. Force unsigned constants. Try rewriting the expression to force everything to be unsigned.
I fucking hate this motherfucking compiler. These stupid fucking idiots, for fuck's sake. That's probably why I have so many things defined in the program with the U. That is literally why now I'm starting to remember how much fun it was to write this 7 years ago. That's why I have so many things defined with the fucking U. This is so dumb. Freaking 1970s and broken ass logic, for fuck's sake. I want a solution where I don't have to define one side with the fucking U to make it unsigned, because then there's a whole different world of different issues.
Give me a working solution that does not involve making one of them unsigned. I'm not going to make one of them they need to be tested as is. If I make another value, it's not the value being tested. Understood. You're testing whether zeros for equals 0 times 0.000000001, exactly as written, with no changes to the literals, and inside an if preprocessor directive, in MSVC, and it's failing, throwing the error. Even though it should logically be 0, so let's tackle it head on, while keeping everything signed, and using only preprocessor safe tricks.
Oh my god, this is so stupid.
But in preprocessor math, intermediate results can become signed 64-bit, especially when literals overflow signed 32-bit.
This is the dumbest shit ever.
Tick. Working solution. Reinterpret using equality test only.
I doubt this is gonna work. Did you look at that? It did not fucking work. Wow. No surprise. The other thing that doesn't work is this freaking zoom tool. Like, it's shit. It's literal shit. Like, it's literal as a literal can be. Like that depth of shit. Oh, I forgot the 0x. That's why. Maybe it'll work. Wow. It works. Hooray. This is some fucking shit, for fuck's sake. That's intentional. They just don't want you using the XOR operator. Like, check for equality. Don't use XOR. Just because you know how to do math doesn't mean you should. Use XOR like everyone else. I mean, don't use XOR. It's not working. It's great. So, apparently, now I think I remember. This is a 32-bit build. This is 64-bit to 32-bit. But even though it's a 32-bit build, I need to mask to keep only 32 bits. How did I forget the 0x? It might not work. I gotta check it again. It works. So, even though the build is 32-bit, the preprocessor is doing 64-bit comparisons, which is fucking ridiculous. So we get rid of the mask. So now it's not masking, it's just the value itself. Rebuild, and rebuild. It's an error. Doesn't click. This is an error because it's not being masked. Because it's a 64-bit number. That's ridiculous. So, problem solved. I just need to mask every place I do a 32-bit comparison. So I'm going to mask with the define I make that has a sign bit, and I'll subtract 1. I can't do that then. I'm gonna have to make a define that's a mask specifically, whatever. Otherwise I gotta like shift a bit and shift it back. That's a lot of work. So I'll just make another define for the mask. Okay, I have a macro, and I'll just wrap every comparison with the macro to clamp it or mask it to 32 bits, because it ends up being 64-bit, even though it's a 32-bit build. Problem solved. I really wish fucking audio software sucks ass.
Semantics. The production with statement with expression statement is evaluated as follows. Let val be the result of evaluating expression. Let obj be to object. Get value. Val. Let old env be the running execution context's lexical environment. Let new env be the result of calling new object environment passing obj and old env as the arguments. Set the provide this flag of new env to true. Set the running execution context's lexical environment to new env. Let C be the result of evaluating statement, but if an exception is thrown during the evaluation, let C be throw v empty, where v is the exception. Execution now proceeds as if no exception were thrown. Set the running.
I need to get this program, JavaScript Engine, done now. I don't know. I could wait. But if I get done now, the sooner the better. Because this thing has a lot of opportunity to mess with the market. If JavaScript was released and was as fast as C, it'd make a big splash in the bucket. In the bucket. This mic, the software, I gotta get some new shit. Everything is shit.
List ops.
It shouldn't be shit. This is a Blue Yeti microphone.
Case block is evaluated.
It's not cheap. Nothing is cheap. It just doesn't fucking work because of Windows or something. I don't even know.
Get value.
I wonder if the Logitech software works. There's an update. It got stuck in the loop where the L just keeps like flipping around the logo.
Case block. Case clause is opt.
I wonder if they fixed that yet.
And is evaluated as follows. Let v equals empty. Let be the list of case clause items in source text order. Let searching be true. Repeat. While searching is true, let C be the next case clause and A if there is no.
Nope. It's probably just me then.
B. Empty. Let clause select be the result of evaluating C. If input is equal to clause selector as defined by the equals operator, then set searching to false. If C has a statement list, then evaluate C's statement list and let R be the result. If R is an
Like, no wonder
equals R value.
the software isn't working.
Clause and A if there is no such case clause, return normal.
No wonder the mic has issues.
List. Then evaluate.
Not only does Windows suck, but like the drivers, they don't work fully. Or I would assume that's why the mic sounds bad. And it has a bunch of bugs. Who knows? It's just technology is so damn advanced that they can't make shit that works.
Parameter. Input and is evaluated.
Or they don't know what they're doing.
Case clauses. In source text order, let B be the list of case clause items in the second case clauses. In source text order, let found be false. Repeat letting C be in order each case clause in A. If found is false, Then, let clause selector be the result of evaluating C. If input is equal to clause selector as defined by the equals operator, then set found to true. If found is true, then if C has a statement list, then evaluate C's statement list and let R be the result. If R value is not empty, then let V equals R value. R is an abrupt completion, then return R type V R target. Let found INB be false. If found is false, then A repeat. While found INB is false and all elements of B have not.
Does this mean I have to like invest my time to like uninstall it, then reinstall it, then do the whole whatever, just do everything again? I had to take my time to do that out of my day. I'm trying to like seriously, why is everything shit? How could things be this shitty? Like seriously, like what the fuck?
And the default clause has a statement list. Then, evaluate the default clause's statement list and let R be the result. If R value is not empty, then let V equals R value. If R is an abrupt completion, then return R type V R target. Repeat. Note that if step 7AI has been performed, this loop does not start at the beginning of B. Let C be the next case clause in B. If there is no such case clause, return normal V empty. If C has a statement list, then evaluate C's statement list and let R be the result. If R value is not empty, then let V equals R value. If R is an abrupt completion, then return R type V R target. The production case clause, case expression, statement list opt is evaluated as follows. Let expref be the result of evaluating expression. Return get value expref. Note evaluating case clause does not execute the associated statement list. It simply evaluates the expression and returns the value, which the case block algorithm uses to determine which statement list to start executing. 2.12 Labeled statement syntax. Labeled statement, identifier. Statement semantics. A statement may be prefixed by a label. Labeled statements are only used in conjunction with labeled break.
Is that why there was a price drop?
No go-to statement. Any CMA script program is considered syntactically incorrect if it contains a labeled statement that is enclosed by a labeled statement with the same identifier.
Minus 30%?
Labels appearing within the body of a function declaration that is nested, directly or indirectly, within a labeled statement. The production identifier statement is evaluated by adding identifier to the label set of statement and then evaluating statement. If the labeled ST,
I think it was like 150 when I got it.
labels are also added to the label set of statement.
That must be why there's a price drop.
Break.
Because Logitech bought Blue Yeti, whoever the company name was. They made new microphones, and they don't know how to make software.
Empty label set, unless it is an.
This doesn't even sound as good as the gray, the original Blue Yeti. I got this to replace that one. Like, yeah. Like, quality control. For real. Quality control. I don't think modern companies know what that means. Quality is very, very, very pathetic. For fuck's sake. Alright, I gotta focus and just ignore everything doesn't work. I can make things that work, so I don't have to deal with this stuff that doesn't work forever. I don't know. Things change.
Clause provides the exception handling code.
This is ridiculous, though. I gotta like uninstall this or some shit. It's so annoying.
My statement. Try block catch is evaluated as follows. Let B be the result of evaluating block. If B type is not throw, return B. Return the result of evaluating catch with parameter B. The production try statement. Try block finally is evaluated as follows. Let B be the result of evaluating block. Let F be the result of evaluating finally. If F type
That's why Windows 11 is updating their Windows 11 gaming experience. Because their OS sucks so bad.
Result of evaluating catch with parameter B. Else. B type is not throw. A let CBE.
Alright, I'm gonna focus. I'm gonna get something done. I get all these masks replaced. And then the shifts, I'm gonna see how much I can get done as quick as possible. This is getting so old. This is so boring.
Execution context's lexical environment. Let catch env be the result of calling new declarative environment passing.
And like every little thing so far has been the dumbest little like fucking technicality with this, technicality with that. Oh, this is this, but in this case it's that. Oh, you can't do that, but you can do this. It's such a pain in the ass to fucking remember all this dumbass shit. It's really dumb.
Waiting block. Set the running execution context's lexical environment to ODM.
So I'm gonna focus on whatever.
Leaves the block. The lexical environment is ELW. Is restored to its former state. The production finally block is evaluated as follows. Return the result of evaluating block. 2.1.4. 1 strict mode restrictions. It is an syntax error if a try statement with a catch occurs within strict code and the identifier of the catch production is either eval or arguments. 2.15 debugger statement syntax. Debugger statement. Debugger semantics. Evaluating the debugger statement production may allow an implementation to cause a breakpoint when run under a debugger. If a debugger is not present or active, this statement has no observable effect. The production debugger statement, debugger, is evaluated as follows. If an implementation-defined debugging facility is available and enabled, then perform an implementation-defined debugging action. Let result be an implementation-defined completion value. Else, a let result be normal, empty, empty. Return result. 3 function definition. Syntax function declaration. Function identifier. Formal parameter list opt. Function body. Function expression. Function identifier opt. Formal parameter list opt. Function body. Formal parameter list. Identifier. Formal parameter list. Identifier function body. Source elements opt. ECMA International 2009-97. Semantics. The production. Function declaration. Function identifier. Formal parameter list opt. Function body is instantiated as follows during declaration binding instantiation. 10.5. Return the result of creating a new function object as specified in 13.2 with parameters specified by formal parameter list opt and body specified by function body. Pass in the variable environment of the running execution context as the scope. Pass in true as the strict flag if the function declaration is contained in strict code or if its function body is strict code. The production, function expression, function, formal parameter list opt, function body is evaluated as follows. Return the result of creating a new function object as specified in 13.2 with parameters specified by formal parameter list opt and body specified by function body. Pass in the lexical environment of the running execution context as the scope. Pass in true as the strict flag if the function expression is contained in strict code or if its function body is strict code. The production, function expression, function identifier, formal parameter list opt, function body is evaluated as follows. Let func-env be the result of calling new declarative environment passing the running execution context's lexical environment as the argument. Let env-rec be func-envs environment record. Call the create immutable binding n concrete method of env-rec passing the string value of identifier as the argument. Let closure be the result of creating a new function object as specified in 13.2 with parameters specified by formal parameter list opt and body specified by function body. Pass in func-env as the scope. Pass s in true as the strict flag if the function expression is contained in strict code or if its function body is strict code. Call the initialize immutable binding n v concrete method of envrec passing the string value of identifier and closure as the arguments. Return closure. Note the identifier in a function expression can be referenced from inside the function expression's function body to allow the function to call itself recursively. However, unlike in a function declaration, the identifier in a function expression cannot be referenced from and does not affect the scope enclosing the function expression. The production function body source elements opt is evaluated as follows. The code of this function body is strict mode code if it is part of a function declaration or function expression that is contained in strict mode code, or if the directive prologue 14.1 of its source elements contains a use strict directive, or if any of the conditions in 1.0.1.1 apply. If the code of this function body is strict mode code, source elements is evaluated in the following steps as strict mode code. Otherwise, source
Okay, so apparently, after extra thinking, because I really gotta think this through, because I'm gonna do it everywhere, whatever I apply here, I'm gonna carry out everywhere else.
It is a syntax error if any identifier function declaration or function expression.
So I'm doing the non-zero sign extended value, which is negated, XOR machine word type, keep mask, I don't know, KN, whatever. The invert of the 0 sign extended hexadecimal pin. This way, this is not modified, which means the bits are set up to whatever the sign bit is to negate it based on if it's 32-bit or 64-bit. And then the preprocessor is checking for 64-bit. This way, if I don't modify this, then it is basically tested against. So like, when it does the keep mask of this result, if the keep mask is going to keep only what's keep. If I flip this number, basically, this number is uncontaminated. This number will be contaminated. Bleh. It's going to end up being 64-bit. It needs to be flipped, but then I keep mask, and now it's whatever it's supposed to be, 32-bit or 64-bit, depending on the build mode. And then that way, this can be whatever it is, as it is. So if this side doesn't match up with this side, it's known. But if I keep mask this side too, it could be defined as 32-bit when it's supposed to be 64-bit or whatever. This way, I can avoid some possible issues, but I'm sure there's other issues and shit, so whatever. I'm gonna try this. I'll use the negated value as it is, XOR that with the 0 extended value, not flipped with the not operator or whatever, and then using the keep mask to contain it or whatever.
False.
That's the plan. I'm going to do this in a whole bunch of other places. Lots of fun.
Descriptor, thrower, false, false, and false.
Unlike Bill Gates, who doesn't actually code, who didn't write Windows, who stole DOS, who stole Netscape, who took everything and called it business. No, it's not business. But I'd be happy. I don't know. I'm gonna show. You know what? Doesn't matter. There's a way to do business, and I'll set an example.
If f does not have an internal property, or if its value is an empty function body, then result is normal.
It's gonna be fun.
Set the execution context func
And if my engine doesn't sell, then it's gonna be really fun. they can compete on a whole new level.
Type must be normal. Return
No matter what, it's a win-win.
99. 3, 2, 2. When the internal method for a function object f is called with a possibly empty list of arguments, the following steps are taken. Let obj be a newly created native ECMA script object. Set all the internal methods of obj as specified in 8.12. Set the internal property of obj to object. Set the internal property of obj to true. Let proto be the value of calling the if type. Proto is object. Set the internal property of obj to proto. If type proto is not object, set the internal property of obj to the standard built-in object prototype object as described in 1.5.2.4. Let result be the result of calling the internal property of f, providing obj
It'll take forever to build.
list passed into as args. If type result is object, then return result. Return obj 3, 2, 3. The function object. The object is a unique function object that is defined once as follows. Create a new native ECMA script object and let f be that object. Set all the internal methods of f as described in 8.12. Set the internal property of f to function. Set the internal property of f to the standard built-in function prototype object as specified in 1.5.3.3.1. Set the internal property of f as described in 1.3.2. 1. Set the internal property of f to the global environment. Set the internal property of f to an empty list. Set the internal property of f to be a function body that unconditionally throws a type error exception and performs no other action. Call the internal method of f with arguments length.
Some nice shot at this.
How beneficial would it be if JavaScript were as performant as C language in relation to video game development?
I don't know if it said it. I clicked the button too late.
How beneficial would it be if JavaScript were as performant as C language in relation to video game development? How beneficial would it be if JavaScript were as performant as C language in relation to video game development? Would JavaScript, if it were run natively as a C program, and wasn't the classic ancient older than grandparents aged retired molasses slow riddled with classic bugs that web developers become accustomed to and accept as JavaScript since nothing ever changes? If JavaScript were as fast as C, how quickly would game developers switch to JavaScript, and if the new SteamOS on their new handheld? Would it make an impact in the market if Valve had a JavaScript engine that was as performant as C? What impact would that make on Microsoft, who stopped developing their handheld Xbox because they are updating the user's Windows 11 gaming experience to account for the new SteamOS? This is a fascinating what-if scenario. Let's break down the core points and explore the implications in game development and the market. This is not a what-if scenario. I'm serious. Got it. You're speaking from a serious, practical perspective about JavaScript's potential if it were truly as performant as C and natively compiled rather than just a scripting or web language. Let me dig deeper into the realistic implications and what would be required for that to happen, and how it would really shake up game development in the market today. Why JavaScript today is seen as slow, and what would need to change. 1. Runtime and
It's not seen as slow. JavaScript is not perceived as slow. When compared where it can't compete, JavaScript gets its ass beat because it is slow. There's nothing seen or perceived or observed that is incorrect with the perception of the user. The user knows that JavaScript is very slow. And when you pay someone to make a website and you want a website, lots of times they're limited and they say, it doesn't matter, whatever. Chatbot is full of it.
runtime and environment. JavaScript typically runs in a sandboxed environment with garbage collection (GC), dynamic typing, and heavy abstractions. Even with JIT compilers, V8, SpiderMonkey, it can't match C's predictable, low-level control over memory and CPU. Language design. JS prioritizes flexibility and safety over raw speed or manual memory management, which limit JS prioritizes flexibility and safety.
Is that why when you open an email, you get a virus? Yeah, they really care about.
JS prioritizes flexibility and safety.
No, they don't. That's not why JavaScript is slow.
Overall speed.
They don't have a JavaScript engine that runs for raw speed. I don't know, because they got no balls. They don't know how to write a program. They literally don't know what they're doing. Exactly why, when you click an email, you create a virus. They don't know what they're doing. If they did, all the security stuff that they put in place would work, but it doesn't, because they don't know what they're doing. That's why they don't prefer raw speed, because they don't know how to write fast code. By they, I mean the web browser developers, like everyone related to web design, not design, development of the engine, of the browser, whatever. It makes no sense how that many people can get involved to make a web browser, and it just doesn't work very good. Well, it does make sense, because there's that many people who don't know what they're doing, making whatever. More heads don't mean smarter. It just means more heads.
Or manual memory management, which limits optimizations for system-level tasks like graphics rendering or physics.
Yeah, no one writes a physics engine with JavaScript. I wonder why. Is it because it's
Seen as slow.
No, it's not because it's seen as slow. It's because JavaScript is slow.
So most don't write physics engines in JavaScript because it is seen as slow. Exactly. That's one of the key reasons physics engines, and other heavy, compute-intensive systems like graphics rendering, AI, or audio processing, demand consistent, very high performance with low latency and predictable timing. So JavaScript seems like it is not demand consistent, very high performance with low latency and predictable timing, but you are saying that the modern JavaScript is demand consistent, very high performance with low latency and predictable timing. Great question. Let me clarify the nuance here, because it can definitely seem contradictory at first.
Yeah, no, it's bullshit.
What JavaScript is today, and what it demands versus what it provides. JavaScript as a language and runtime does not inherently demand consistent, low latency, high performance timing in the same way a physics engine or game.
My JavaScript engine will, and is going to, and it is basically. That's the whole reason I'm fucking writing it.
Modern JS engines, V8, SpiderMonkey, etc., try to provide as high performance as possible. Try to provide. Try to provide. Try to provide. Try to provide. Try to provide.
Like I said, they don't know what the fuck they're doing.
However, JavaScript cannot guarantee predictable timing or avoid pauses caused by garbage collection. This is a fundamental limitation in classic JS engines. That makes JS less suitable for workloads that need strict frame-by-frame consistency like physics or audio processing.
LOL, that's exactly the reason why garbage collection is the dumbest thing ever. Imagine trying to process audio in JavaScript. Holy shit, that'd be horrible.
So, JavaScript engines want to be fast and responsive, optimizing aggressively for typical web apps, but they do not provide real-time guarantees. Physics engines or game loops demand predictable, low latency, consistent performance. What would change if JS were truly as performant as C, with predictable timing? It would mean JS engines evolved to handle memory deterministically, avoid GC pauses, and have static typing or compilation to native machine code, essentially redefining the runtime. This would close the gap, letting JS be used for real-time, latency-critical tasks like physics engine. I'm closing the gap. ChatGPT said, "Love the energy." Closing the gap between JavaScript and C-level performance, especially for real-time. This is not a what-if scenario. I'm serious. Tooling and ecosystem. C has decades of highly optimized compilers, debuggers, profiling tools, and hardware-specific intrinsics for SIMD, GPU, etc. JS doesn't currently have that low-level access.
Yeah, and the SIMD stuff, intrinsics and C, they suck ass, but it's still better than JavaScript. But that's why I'm writing assembly, because C compiler sucks.
What if JS became a native compiled language with C-level performance? Technological shifts needed. A new, radically optimized JS engine, or a new flavor of JS that supports manual memory management or deterministic resource handling. Native bindings to graphics APIs, Vulkan, DirectX, Metal, with zero overhead. Predictable performance. No GC pauses or soft real-time behavior.
This is actually kind of useful. I could reuse these sentences, because I gotta meet these anyways, but like, it's good wording.
Zero overhead.
But the whole zero overhead, I don't know how that's even possible. Technically, the code has to be computed, and then it has to be sent. So maybe it's talking about the extra in between layers, which I won't have to deal with in the first place. But that's not even related to JavaScript. That's related to the CSS and the browser DOM and the DOM tree, not really the JavaScript. So, I don't know. Where JavaScript starts and the browser begins is kind of complicated, because now they do a shadow DOM in the JavaScript, or they've been doing that for a while now. So you can populate a shadow DOM and then append the nodes to the HTML node tree and all that good stuff. And it's way, way faster. Like manipulating the DOM tree in the browser through the DOM. So fucking slow. The only way to make it performant in any way is to like loop through the nodes, make a shadow DOM, and then move the nodes in and out between JavaScript and the browser DOM.
Static typing or advanced type inference to enable aggressive compiler optimizations. Robust multi-threading and SIMD support. How would this change game development? For AAA and mid-tier studios, the biggest friction is not just raw speed, but tool chains, platform support, and control. If JS matched C on performance and low-level control, it would definitely disrupt.
I was gonna add a bunch of like attributes. So if you know it's like integer addition or integer operation, you could tag it with the attribute. I don't know, like maybe like braces, or there's something that's standard. I gotta look it up. But you could tag areas of code or whatever with that, and then when it compiles it in C, I can take that and then apply the whatever optimization, whatever, or the intrinsic, or the hint that it'll mostly be numbers, or mostly strings, or all numbers, or all strings. I can set up the jumps, the branches, the loops, everything optimal for whatever the scenario is. Unity has a burst, so I can look at burst. Because, I don't know, I tried burst, and it did get faster performance, but C# is so slow, it's the worst. But they did actually write, whoever's on burst in C#, they did write some good optimization stuff. So I could like, I don't know, take a peek at what other people are doing, and then do that too. Just like I did with Tumblr. Like, I don't know. It's not copying, it's not stealing. It's an idea, and then I can make it myself. I don't even need the code, and I make a better idea, and I add to it, and it's creative, and it's better and different than the original. So, I don't know. Or I could just not look at the competition and come up with my own ideas. That's what I normally do. I try not to copy, because then it's like obvious that you like got the idea from someone else. So, I don't know.
Rapid iteration cycles with a more approachable language would reduce development time. Cross-platform deployment becomes trivial.
That's also why I'm streaming live. I've been in art contests before, in middle school and up or whatever, and I always got disqualified. They thought I was cheating, or that I had outside influence helping me with my art projects, and I always got disqualified, and it pissed me the fuck off, because I did not cheat. They'd say, oh, this is too good for someone of your age, you must have had outside help, and they put it off to the side. And it's like, motherfucker, you son of a bitch. Fuck. So, I'm streaming all of this live. So, if anyone wants to claim that I didn't do anything, that I like copied it, or that none of it's my idea, yeah, right. No. Not again. It's like a compliment to be accused of like copying or getting help because it's too good. But then it's not, because I never, ever got the satisfaction of getting first. Ever. Fucking disqualified. I made an African mask at a Southfield public school. And the teacher, she took the African mask and she worked at a hair salon. And she had like art showing whatever, all the kids in her class. And there was a couple kids that were from Africa. And she said, which of these masks is the best? And then everyone picked my mask. And she's like, are you guys so you think this is the best one, whatever. And everyone was like, yeah, that's amazing. Is that one of the interns from Africa? Like, what I think Cape Horn, whatever it is. And then she said that, she told me that she smiled, and she like laughed, and said, you know who made that? The whitest kid in my class. And it's the funniest thing ever. I am so freaking white, but I made the most African looking mask compared to the kids from Africa that are actually African. They thought that the white kid's mask looked more African than all the other masks that we made in Detroit schools for, it was like Black History Month or something. I'm not even black. I am literally the whitest freaking... Do you know what it's like to be white in an all-black school in Detroit? Like, 2 other white kids, a fat white kid, a skinny white kid, and a chubby white girl. Yeah, no, it's not fun. So, I don't know where I'm going with this. This time, I'm gonna win. And it's gonna be like... I gotta think of something. I don't know. My JavaScript engine is gonna kick ass.
Scripting layers could merge into the core language, simplifying codebases.
I might be black though. Maybe I'm like 1% black or something. I'm pretty sure I'm like French and Texan or something. I probably have a tiny bit of blackness. And then it comes out during Black History Month. And I end up just like making the most black mask out of all the other kids in the Detroit public school system. Well, for that school, not the whole system, whatever. I don't know.
Easier integration of web technologies UI, networking into games. For indie devs, lower barriers for high-performance native games would democratize creation even more, with fewer painful toolchain setups and faster prototyping. Engines and middleware. Major engines would adapt or rewrite parts to harness this JS tech, possibly becoming more open and flexible. On Valve's SteamOS handheld with a native JS engine. Valve's SteamOS with a high-performance JS runtime would make the handheld very developer-friendly, potentially attracting huge volumes of devs, especially indies and web developers. This could complement traditional native game development instead of replacing it immediately, expanding the range of available games. It would also empower cross-platform games that run on desktop, handheld, and web seamlessly. Competitive impact on Microsoft and others. Microsoft's strategy of Windows 11 gaming experience may be challenged by a more open, portable, and developer-friendly SteamOS. Valve's handheld could become a hub for quick-to-market, performant games with much lower development overhead. Realistic adoption timeline and challenges. Even if the JS engine existed today with native C-like performance, adoption would take years. Studios need time to rebuild pipeline. Performance edge must be proven across complex, large-scale projects. Ecosystem tooling, profilers, debuggers, asset pipelines, needs maturity. Platform support, consoles, mobile GPUs, must align with JS.
the web browser exists, so that stuff doesn't really even have to do with JavaScript itself.
Summary.
I don't know. When the art teacher in Detroit public schools is like, that white kid is the blackest kid in my class. I don't know why she thought it was so funny, but it was hilarious to her. It seemed a little racist, and it probably pissed off all the other black kids. That's probably why they hated me. Because I was better at being black during Black History Month. And then during Black History Month, you had to read a book. It was
What is a common book read in Detroit public schools that covers slavery and whipping?
That's probably why I can't spell, because I went to Detroit public schools. You know what? Everything is starting to make sense now.
What is a common book read in Detroit public schools over Black History Month that covers slavery and whipping? I had to read a book during English class, popcorn style, and the book had the N-word in it all over the place. What book would you assume it was that the English teacher made me read?
And during popcorn, they never picked me. I went through 2 classes for 2 days. Nobody would popcorn John. They kept skipping me. I don't know why. But then, on the 3rd day, during this book, whatever, I had to get popcorned because, I don't know, the day was longer or something. It's like, the school year was messed up. We had like vacations and shit all the time, so some school days would be longer than others. So, it was near the end of class. There's probably like 10 more minutes left. It wasn't at the very end. But everyone was popcorned, and everyone looked at each other. And then he had, I don't want to say his name, had to pick me, the white kid, to read from the book. And I don't know, the N-word was in there. I just fucking read it. It was the funniest thing ever. after that, this one girl named, she had a name, I'm not gonna say it. She bitched out the teacher, saying, "Why is this white boy in our class? Why is he saying the N-word? He's not supposed to say the N-word." And I was like, I didn't say anything, but I was thinking, bitch, why the fuck, during Black History Month, is a Detroit public school reading books on slavery that have the N-word, that talk about whipping, and like, what the hell? What world do I live in? That is the Detroit public school system, at least a while ago. I doubt it's changed. The art teacher had to spend money to buy supplies for the class. I don't know. Pretty bad in Detroit.
Given the details you provided, an English class reading during Black History Month.
It wasn't Huckleberry Finn. It was like some off, strange book that was really graphic. And it was like, whoa, what the hell? And it was in like middle school. Like, what even?
Popcorn style reading. It's commonly assigned for read aloud sessions in class. It was not Huckleberry Finn, it was some other book that was really graphic, and it was disturbing.
I don't know. It could have been this book. Maybe not. But it was like, there's like a bunch of like really, like, what, it was middle school. And it was like, what the heck?
Incidents in the Life of a Slave Girl by Harriet Jacobs. It's a first-person slave narrative that covers the brutal realities of slavery, including physical abuse and psychological torment. The book doesn't shy away from
Psychological torment is making a white kid read a book like this, popcorn style, in Detroit public schools. That is,
psychological torment.
for fuck's sake. To be fair, the teacher did say that I could sit out while we're reading the book. But I'm not going to sit out. If someone's uncomfortable, it shouldn't be happening. The teacher's face, when I said the N-word, it was like 10, 12 times in a row. It was like N. It was like whip, N. It was, I don't know. She stopped reading the book after that, and she changed it. We never finished the book. So, I don't know why we didn't finish the book. But, if anyone got
Psychological torment.
it, definitely wasn't me.
The book doesn't shy away from graphic details about whipping, sexual abuse, and the horrors of slavery. It uses period-appropriate language, which can include racial slurs. Black History Month. Curricula.
This might be it. I'm not sure. I don't even know what it was.
It's often included in Black History Month curricula to give students first-hand perspectives on slavery's cruelty.
Yeah. Have, I'm asked Chatbot if, it makes sense to read this book popcorn style in Detroit public schools. It doesn't matter if there's white kids in the class. I don't know. Freaking agendas and stuff.
Is it not odd that Detroit public schools would have middle schoolers read Incidents and the Life of a Slave Girl by Harriet Jacobs out loud for English class to honor Black History Month, especially if there are white kids in the class? Yes, that is a very intense and mature choice for middle schoolers.
Yeah, it is.
Especially for a read aloud format with a racially mixed class.
Of course.
Incidents and the Life of a Slave Girl is a powerful and important work, but it contains graphic descriptions of sexual abuse, violence, and trauma that might not be age appropriate for younger students.
So I don't know.
Read aloud format for mature content can be tricky. Reading such graphic material aloud in a classroom with diverse students can be uncomfortable or even harmful if not handled carefully, with proper context and support.
It doesn't matter how much context. When the white kid has to get popcorned during reading time in Black History Month, the white kid that made the blackest mask, African tribal mask, out of all the other kids in the school, even the, what do you call them? The kids that, come in from out of state, whatever, out of a country. Whatever it's called. I don't know. No wonder people were uncomfortable.
On Valve's SteamOS handheld with a native JS engine, Valve's SteamOS with a high-performance JS runtime would make the handheld very developer-friendly, potentially attracting huge volumes of devs, especially indies and web developers. This could complement traditional native game development instead of replacing it immediately, expanding the range of available games. It would also empower cross-platform games that run on desktop, handheld, and web seamlessly. Competitive impact on Microsoft and others. Microsoft's strategy of Windows 11 gaming experience may be challenged by a more open, portable, and developer-friendly SteamOS. Valve's handheld could become a hub for quick-to-market, performant games with much lower development overhead. Summary: if JavaScript became as fast and native as C, it would be more than just a what-if. It would transform game development workflows and democratize high-performance game creation. Valve pushing such a runtime on SteamOS handheld would be a major market disruptor, especially for indies and cross-platform games. Microsoft and others would have to respond to a new paradigm blending web text flexibility with native performance.
Okay, so, in summary, I guess this is my point. I gotta put together. Okay, so my point is, my point. I don't have to be black to make the most African, authentic, tribal mask. Out of the whole school. I don't even have to be black to be black, because I am black, basically. I went to school for typography. I don't need to go to school for programming or any of that, because I am a programmer. And I can do whatever I can do, and that's quite a bit. It's more than quite a bit. You don't know how humble I am being. Anyways, I think that, summarizes everything, whatever. So I'm gonna, try to get back to work and stuff. I don't know. This will be fun.
Semantics. The production with expression statement is evaluated as follows. Let val be the result of evaluating expression. Let obj be to object. Get value. val. Let old-env be the running execution context's lexical environment. Let new env be the result of calling new object environment passing obj and old-env as the arguments. Set the provide this flag of new env to true. Set the running execution context's lexical environment to new env. Let C be the result of evaluating statement, but if an exception is thrown during the evaluation, let C be throw v empty, where v is the exception. Execution now proceeds as if no exception were thrown. Set the running execution context's lexical environment to old-env. Return C. Note, no matter how control leaves the embedded statement, whether normally or by some form of abrupt completion or exception, the lexical environment is always restored to its former state. 2.1.0. 1. Strict mode restrictions. Strict mode code may not include a with statement. The occurrence of a with statement in such a context is treated as a syntax error. 2.11. The switch statement syntax. Switch statement. Switch. Expression. Case block. Case block. Case clause assopt. Case clause assopt. Default clause. Case clause assopt. ECMA International 2009-93. Case clauses. Case clause. Case clauses. Case clause. Case clause. Case expression. Statement list op. Default clause. Default. Statement list op. Semantics. The production switch statement. Switch. Expression. Case block is evaluated as follows. Let expref be the result of evaluating expression. Let R be the result of evaluating case block. Passing it get value. Expref. As a parameter. If R type is break and R target is in the current label set, return normal. A value. Empty. Return R. The production case block. Case clause assopt is given an input parameter, input, and is evaluated as follows. Let v equals empty. Let A be the list of case clause items in source text order. Let searching be true. Repeat. While searching is true, let C be the next case clause and A if there is no such case clause. Return normal. V. Empty. Let clause selector be the result of evaluating C. If input is equal to clause selector as defined by the equals operator, then set searching to false. If C has a statement list, then evaluate C's statement list and let R be the result. If R is an abrupt completion, then return R. Let V equals R value. Repeat. Let C be the next case clause and A if there is no such case clause. Return normal. V. Empty. If C has a statement list, then evaluate C's statement list and let R be the result. If R value is not empty, then let V equals R value. If R is an abrupt completion, then return R type V. R target. The production case block. Case clause assopt. Default clause case clause assopt is given an input parameter, input, and is evaluated as follows. Let V equals empty. Let A be the list of case CL or items in the first case clauses in source text order. Let B be the list of case clause items in the second case clauses in source text order. Let found be false. Repeat. Letting C be in order each case clause in A. If found is false, then let clause selector be the result of evaluating C. If input is equal to clause selector as defined by the equals operator, then set found to true. If found is true, then if C has a statement list, then evaluate C's statement list and let R be the result. If R value is not empty, then let V equals R value. R is an abrupt completion, then return R type V. R target. Let found INB be false. If found is false, then A repeat. While found INB is false and all elements of B have not been processed. 4. ECMA International 2009. Let C be the next case clause in B. Let clause selector be the result of evaluating C. If input is equal to clause selector as defined by the equals operator, then set found INB to true. If C has a statement list, then evaluate C's statement list and let R be the result. B. If R value is not empty, then let V equals R value. C. R is an abrupt completion, then return R type V. R target. If found INB is false and the default clause has a statement list, then evaluate the default clause's statement list and let R be the result. If R value is not empty, then let V equals R value. If R is an abrupt completion, then return R type V. R target. Repeat. Note that if step 7AI has been performed, this loop does not start at the beginning of B. Let C be the next case clause in B. If there is no such case clause, return normal, V, empty. If C has a statement list, then evaluate C's statement list and let R be the result. If R value is not empty, then let V equals R value. If R is an abrupt completion, then return R type, V, R target. The production case clause, case expression, statement list opt is evaluated as follows. Let expref be the result of evaluating expression. Return get value, expref. Note evaluating case clause does not execute the associated statement list. It simply evaluates the expression and returns the value, which the case block algorithm uses to determine which statement list to start executing. 2.12 Labeled statement syntax. Labeled statement, identifier. Statement semantics. A statement may be prefixed by a label. Labeled statements are only used in conjunction with labeled break and continue statements. ECMA script has no go-to statement. An ECMA script program is considered syntactically incorrect if it contains a labeled statement that is enclosed by a labeled statement with the same identifier as label. This does not apply to labels appearing within the body of a function declaration that is nested, directly or indirectly, within a labeled statement. The production identifier statement is evaluated by adding identifier to the label set of statement and then evaluating statement. If the labeled statement itself has a non-empty label set, these labels are also added to the label set of statement before evaluating it. If the result of evaluating statement is break, v, l, where l is equal to identifier, the production results in normal, v, empty. Prior to the evaluation of a labeled statement, the contained statement is regarded as possessing an empty label set, unless it is an iteration statement or a switch statement, in which case it is regarded as possessing a label set consisting of the single element, empty. 2.13 Throw statement syntax. Throw statement. Throw, no line terminator here. Expression. ECMA International 2009-95. Semantics. The production throw statement, throw, no line terminator here. Expression, is evaluated as let expref be the result of evaluating expression. Return, throw, get value, expref. Empty. 2.14 Try statement syntax. Try statement. Try block catch. Try block finally. Try block catch finally. Catch. Catch. Identifier. Block. Finally. Finally block. The try statement encloses a block of code in which an exceptional condition can occur, such as a runtime error or a throw statement. The catch clause provides the exception handling code. When a catch clause catches an exception, its identifier is bound to that exception. Semantics. The production try statement, try block catch is evaluated as follows. Let B be the result of evaluating block. If B type is not throw, return B. Return the result of evaluating catch with parameter B. The production try statement, try block finally is evaluated as follows. Let B be the result of evaluating block. Let F be the result of evaluating finally. If F type is normal, return B. Return F. The production try statement, try block catch finally is evaluated as follows. Let B be the result of evaluating block. If B type is throw, then let C be the result of evaluating catch with parameter B. Else, B type is not throw. Let C be Let F be the result of evaluating finally. If F type is normal, return C. Return F. The production catch identifier block is evaluated as follows. Let C be the parameter that has been passed to this production. Let old-env be the running execution context's lexical environment. Let catch-env be the result of calling new declarative environment passing old-env as the argument. Call the create mutable binding concrete method of catch-env passing the identifier string value as the argument. 6. ECMA International 2009. Call the set mutable binding concrete method of catch-env passing the identifier C and false as arguments. Note that the last argument is immaterial in this situation. Set the running execution context's lexical environment catch-env. Let B be the result of evaluating block. Set the running execution context's lexical environment to old-env. Return B. Note no matter how control leaves the block, the lexical environment is ELW is restored to its former state. The production finally Finally, block is evaluated as follows. Return the result of evaluating block. 2.1.4. 1. Strict mode restrictions. It is an syntax error if a try statement with a catch occurs within strict code and the identifier of the catch production is either eval or arguments. 2.15 The debugger statement syntax. Debugger statement. Debugger semantics. Evaluating the debugger statement production may allow an implementation to cause a breakpoint when run under a debugger. If a debugger is not present or active, this statement has no observable effect. The production debugger statement, debugger, is evaluated as follows. If an implementation-defined debugging facility is available and enabled, then perform an implementation-defined debugging action. Let result be an implementation-defined completion value. Else, a let result be normal, empty, empty. Return result. 3. Function definition. Syntax function declaration. Function identifier. Formal parameter list opt. Function body. Function expression. Function identifier opt. Formal parameter list opt. Function body. Formal parameter list. Identifier. Formal parameter list. Identifier function body. Source elements opt. ECMA International 2009-97. Semantics. The production. Function declaration. Function identifier. Formal parameter list opt. Function body is instantiated as follows during declaration binding instantiation. 10.5. Return the result of creating a new function object as specified in 13.2 with parameters specified by formal parameter list opt and body specified by function body. Pass in the variable environment of the running execution context as the scope. Pass in true as the strict flag if the function declaration is contained in strict code or if its function body is strict code. The production, function expression, function, formal parameter list opt, function body is evaluated as follows. Return the result of creating a new function object as specified in 13.2 with parameters specified by formal parameter list opt and body specified by function body. Pass in the lexical environment of the running execution context as the scope. Pass in true as the strict flag if the function expression is contained in strict code or if its function body is strict code. The production, function expression, function identifier, formal parameter list opt, function body is evaluated as follows. Let func-env be the result of calling new declarative environment passing the running execution context's lexical environment as the argument. Let env-rec be func-envs environment record. Call the create immutable binding n concrete method of env-rec passing the string value of identifier as the argument. Let closure be the result of creating a new function object as specified in 13.2 with parameters specified by formal parameter list opt and body specified by function body. Pass in func-env as the scope. Pass s in true as the strict flag if the function expression is contained in strict code or if its function body is strict code. Call the initialize immutable binding n v concrete method of env-rec passing the string value of identifier and closure as the arguments. Return closure. Note the identifier in a function expression can be referenced from inside the function expression's function body to allow the function to call itself recursively. However, unlike in a function declaration, the identifier in a function expression cannot be referenced from and does not affect the scope enclosing the function expression. The production function body source elements opt is evaluated as follows. The code of this function body is strict mode code if it is part of a function declaration or function expression that is contained in strict mode code or if the directive prologue 14.1 of its source elements contains a use strict directive or if any of the conditions in 1.0.1.1 apply. If the code of this function body is strict mode code, source elements is evaluated in the following steps as strict mode code. Otherwise, source elements is evaluated in the following steps as non-strict mode code. If source elements is present, return the result of evaluating source elements. Else return normal, undefined, empty. 3.1 Strict mode restrictions. It is a syntax error if any identifier value occurs more than once within a formal parameter list of a strict mode, function declaration or function expression. It is a syntax error if the identifier eval or the identifier arguments occurs within a formal parameter list of a strict mode function declaration or function expression. 8. Copyright sign. ECMA International 2009. It is a syntax error if the identifier eval or the identifier arguments occurs as the identifier of a strict mode function declaration or function expression. 3.2 Creating function objects. Given an optional parameter list specified by formal parameter list, a body specified by function body, a lexical environment specified by scope, and a Boolean flag strict, a function object is constructed as follows. Create a new native ECMA script object and let f be that object. Set all the internal methods, except for set the internal property of f to function. Set the internal property of f to the standard built-in function prototype object as specified in 1.5.3.3.1. Set the internal property of f as described in 1.3.2.1. Set the internal property of f as described in 1.3.2.2. Set the internal property of f as described in 1.5.3.5.3. Set the internal property of f to the value of scope. Let names be a list containing, in left to right textual order, the strings corresponding to the identifiers of formal parameter list. Set the internal property of to names. Set the internal property of f to function body. Set the internal property of f to true. Let len be the number of formal parameters specified in formal parameter list. If no parameters are specified, let len be 0. Call the internal method of f with arguments length. Property descriptor len false, 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 and false. Let proto be the result of creating a new object as would be constructed by the expression new object, where object is the standard built-in constructor with that name. Call the internal method of proto with arguments constructor. Property descriptor f, true, false, true, and false. Call the internal method of f with arguments prototype. Property descriptor proto, true, false, false, and false. If strict is true, then let thrower be the function object. 1.3.2.3. Call the internal method of f with arguments caller. Property descriptor thrower. False, false, and false. Call the internal method of f with arguments. Property descriptor thrower. False, false, and false. Return f. Note: a prototype property is automatically created for every function, to allow for the possibility that the function will be used as a constructor. 3, 2, 1. When the internal method for a function object f is called with this value and a list of arguments, the following steps are taken. Let functx be the result of establishing a new execution context for function code using the value of f's internal property, the passed arguments list args, and this value is described in 1.0.4.3. Let result be the result of evaluating the function body that is the value of f's internal property. If f does not have an internal property, or if its value is an empty function body, then result is normal, undefined, empty. Exit the execution context functx, restoring the previous execution context. If result type is throw, then throw result value. If result type is return, then return result value. Otherwise result type must be normal. Return undefined. ECMA International 2009-99. 3, 2, 2. When the internal method for a function object f is called with a possibly empty list of arguments, the following steps are taken. Let obj be a newly created native ECMA script object. Set all the internal methods of obj as specified in 8.12. Set the internal property of obj to object. Set the internal property of obj to true. Let proto be the value of calling the if type proto is object. Set the internal property of obj to proto. If type proto is not object, set the internal property of obj to the standard built-in object prototype object as described in 1.5.2.4. Let result be the result of calling the internal property of f, providing obj as this value and providing the argument list passed into as args. If type result is object, then return result. Return obj. 3, 2, 3. The function object. The object is a unique function object that is defined once as follows. Create a new native ECMA script object and let f be that object. Set all the internal methods of f as described in 8.12. Set the internal property of f to function. Set the internal property of f to the standard built-in function prototype object as specified in 1.5.3.3.1. Set the internal property of f as described in 1.3.2. 1. Set the internal property of f to the global environment. Set the internal property of f to an empty list. Set the internal property of f to be a function body that unconditionally throws a type error exception and performs no other action. Call the internal method of f with arguments length. Property descriptor 0, false, 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 and false. Set the internal property of f to false. Let be f. For program syntax. Program. Source elements opt. Source elements. Source element. Source element. Source element. Source element. Statement. Function declaration. Semantics. The production program. Source elements opt is evaluated as follows. The code of this program is strict mode code if the directive prologue 14.1 of its source elements contains a use strict directive or if any of the conditions of 1 apply. If the code of this program is strict mode code, source elements is evaluated in the following steps as strict mode code. Otherwise, source elements is evaluated in the following steps as non-strict mode code. 00. Copyright sign. ECMA International 2009. If source elements is not present, return normal, empty, empty. Let proxy XT be a new execution context for global code as described in 1. Let result be the result of evaluating source elements. Exit the execution context proxy XT. Return result. Note the processes for initiating the evaluation of a program and for dealing with the result of such an evaluation are defined by an ECMA script implementation and not by the specification. The production source elements. Source element is evaluated as follows. Let head result be the result of evaluating source elements. If head result is an abrupt completion, return head result. Let tail result be result of evaluating source element. If tail result value is empty, let v equals head result value. Otherwise let v equals tail result value. Return tail result type v. Tail result target. The production source element statement is evaluated as follows. 1. Return the result of evaluating statement. The production source element function declaration is evaluated as follows. 1. Return normal, empty, empty. 4.1 Directive prologues and the use strict directive. A directive prologue is the longest sequence of expression statement productions occurring as the initial source element productions of a program or function body and where each expression statement in the sequence consists entirely of a string literal token followed a semicolon. The semicolon may appear explicitly or may be inserted by automatic semicolon insertion. A directive prologue may be an empty sequence. A use strict directive is an expression statement in a directive prologue whose string literal is either the exact character sequence as use strict or use strict. A use strict directive may not contain an escape sequence or line continuation. A directive prologue may contain more than one use strict directive. However, an implementation may issue a warning if this occurs. Note the expression statement productions of a directive prologue are evaluated normally during evaluation of the containing source elements production. Implementations may define implementation-specific meanings for expression statement productions which are not a use strict directive and which occur in a directive prologue. If an appropriate notification mechanism exists, an implementation should issue a warning if it encounters in a directive prologue an expression statement that is not a use strict directive or which does not have a meaning defined by the implementation. 5. Standard built-in ECMA script objects. There are certain built-in objects available whenever an ECMA script program begins execution. 1. The global object is part of the lexical environment of the executing program. Others are accessible as initial properties of the global object. Unless specified otherwise, the internal property of a built-in object is function if the built-in object has an internal property, or object if that built-in object does not have an internal property. Unless specified otherwise, the internal property of a built-in object initially has the value true. Many built-in objects are functions. They can be invoked with arguments. Some of them furthermore are constructors. They are functions intended for use with the new operator. For each built-in function, this ECMA International 2009 101 specification describes the arguments required by that function and properties of the function object. For each built-in constructor, The specification furthermore describes properties of the prototype object of that constructor and properties of specific object instances returned by a new expression that invokes that constructor, unless otherwise specified in the description of a particular function. If a function or constructor described in this clause is given fewer arguments than the function is specified to require, the function or constructor shall behave exactly as if it had been given sufficient additional arguments, each such argument being the undefined value, unless otherwise specified in the description of a particular function. If a function or constructor described in this clause is given more arguments than the function is specified to allow, the extra arguments are evaluated by the calling, then ignored by the function. However, an implementation may define implementation-specific behavior relating to such arguments as long as the behavior is not the throwing of a type error exception that is predicated simply on the presence of an extra argument. Note: implementations that add additional capabilities to the set of built-in functions are encouraged to do so by adding new functions rather than adding new parameters to existing functions. Every built-in function and every built-in constructor has the function prototype object, which is the initial value of the expression function prototype, 1, 5, 3, 4, as the value of its internal property. Unless otherwise specified, every built-in prototype object has the object prototype object, which is the initial value of the expression object prototype, 1, 5, 2, 4, as the value of its internal property, except the object prototype object itself. None of the built-in functions described in this clause that are not constructors shall implement the internal method unless otherwise specified in the description of a particular function. None of the built-in functions described in this clause shall have a prototype property unless otherwise specified in the description of a particular function. This clause generally describes distinct behaviors for when a constructor is called as a function and for when it is called as part of a new expression. The called as a function behavior corresponds to the invocation of the constructor's internal method, and the called as part of a new expression behavior corresponds to the invocation of the constructor's internal method. Every built-in function object described in this clause, whether as a constructor, an ordinary function, or both, has a length property whose value is an integer. Unless otherwise specified, this value is equal to the largest number of named arguments shown in the subclause headings for the function description, including optional parameters. Note, for example, the function object that is the initial value of the slice property of the string prototype object is described under the subclause heading string prototype slice, start, end, which shows the two named arguments start and end. Therefore the var_lu, the length property of that function object, is 2. In every case, the length property of a built-in function object described in this clause has the attributes false, false, false. Every other property described in this clause has the attributes true, false, true unless otherwise specified. 5.1 The global object. The unique global object is created before control enters any execution context. Unless otherwise specified, the standard built-in properties of the global object have attributes true, false, true. The global object does not have an internal property. It is not possible to use the global object as a constructor with the new operator. 02, copyright sign, ECMA International 2009. The global object does not have an internal property. It is not possible to invoke the global object as a function. The values of the and internal properties of the global object are implementation dependent. In addition to the properties defined in this specification, the global object may have additional host-defined properties. This may include a property whose value is the global object itself. For example, in the HTML document object model, the window property of the global object is the global object itself. 5. 1. 1 value properties of the global object 1 5 1 1 1 nan. The value of nan is nan. See 8.5. This property has the attributes false, false, false. 5 1 1 2 infinity. The value of infinity is plus. See 8.5. This property has the attributes false, false, false. 1 5 1 1 3 undefined. The value of undefined is undefined. See 8.1. This property has the attributes false, false, false. 5 1 2 function properties of the global object 5 1 2 1 eval x. When the eval function is called with one argument x, the following steps are taken. If type x is not string, return x. Let prog be the ECMA script code that is the result of parsing x as a program. If the parse fails, throw a syntax error exception, but see also clause 16. Let eval ctx be the result of establishing a new execution context. 1042. For the eval code prog, let result be the result of evaluating the program prog. Exit the running execution context eval ctx, restoring the previous execution context. If result type is normal and its completion value is a value v, then return the value v. If result type is normal and its completion value is empty, then return the value undefined. Otherwise, result type must be throw. Throw result value as an exception. 5, 1, 2, 1. 1 direct call to eval. A direct call to the eval function is one that is expressed as a call expression that meets the following two conditions. The reference that is the result of evaluating the member expression in the call expression has an environment record as its base value and its reference name is eval. The result of calling the abstract operation get value at that reference as the argument is the standard built-in function defined in 1.5.1.2. 1. ECMA International 2009 103. 5. 1. 2. 2 parse int. String. Radix. The parse int function produces an integer value dictated by interpretation of the contents of the string argument according to the specified radix. A leading white space in string is ignored. If radix is undefined or 0, it is assumed to be 10 except when the number begins with the character pairs 0x or 0x, in which case a radix of 16 is assumed. If radix is 16, number may also optionally begin with the character pairs 0x or 0x. When the parse int function is called, the following steps are taken. Let input string be to string. String. Let s be a newly created substring of input string consisting of the first character that is not a str white space char and all characters following the character. In other words, remove leading white space. Let sign be 1. If s is not empty and the first character of s is a minus sign, let sign be 1. If s is not empty and the first character of s is a plus sign plus or a minus sign, then remove the first character from s. Let r equals to int 32. Radix. Let strip prefix be true. IFR 0. Then IFR 2 or 36. Then return nan BFR 16. Let strip prefix be false. Else our equals 0. A letter equals 10. If strip prefix is true, then if the length of s is at least 2 and the first two characters of s are either 0x or 0x, then remove the first two characters from s and let r equals 16. If s contains any character that is not a radix r digit, then let z be the substring of s consisting of all characters before the first such character. Otherwise, let z be s. If z is empty, return nan. Let math int be the mathematical integer value that is represented by z in radix r notation, using the letters z and az for digits with values 10 through 35. However, if r is 10 and z contains more than 20 significant digits, every significant digit after the 20th of may be replaced by a 0 digit, at the option of the implementation. And if r is not 2, 4, 8, 10, 16, or 32, then math int may be an implementation-dependent approximation to the mathematical integer value that is represented by z in radix r notation. Let number be the number value for math int. Return sign number. Note parse int may interpret only a leading portion of string as an integer value. It ignores any characters that cannot be interpreted as part of the notation of an integer, and no indication is given that any such characters were ignored. 5, 1, 2, 3 parse float. String. The parse float function produces a number value dictated by interpretation of the contents of the string argument as a decimal literal. When the parse float function is called, the following steps are taken. Let input string be to string. String. Let trimmed string be a substring of input string consisting of the leftmost character that is not a str white space char and all characters to the right of that character. In other words, remove leading white space if neither trimmed string nor any prefix of trimmed string satisfies the syntax of a str decimal literal. C, 3.1, Return nan. Let number string be the longest prefix of trimmed string, which might be trimmed string itself. That satisfies the syntax of a str decimal literal. Return the number value for the MV of number string. 04 copyright sign. ECMA International 2009. Note parse float may interpret only a leading portion of string as a number value. It ignores any characters that cannot be interpreted as part of the notation of an decimal literal, and no indication is given that any such characters were ignored. 5, 1, 2, 4 is nan. Number returns true if the argument coerces to nan, and otherwise returns false. If the number is nan, return true. Otherwise, return false. Note a reliable way for ECMA script code to test if a value x is a nan is an expression of the form x equals x. The result will be true if and only if x is an an. 5, 1, 2, 5 is finite. Number returns false if the argument coerces to nan, plus, or, and otherwise returns true if the number is nan, plus, or, return false. Otherwise, return true. 5, 1, 3 URI handling function properties. Uniform resource identifiers, or URIs, are strings that identify resources, for example web pages or files, and transport protocols by which to access them, for example HTTP or FTP, on the internet. The ECMA script language itself does not provide any support for using URIs except for functions that encode and decode URIs as described in 1.5, 1, 3, 1, 1.5, 1, 3, 2, 1.5, 1, 3, 3 and 1.5, 1, 3, 4. Note many implementations of ECMA script provide additional functions and methods that manipulate web pages. These functions are beyond the scope of this standard. A URI is composed of a sequence of components separated by component separators. The general form is scheme, first, second, third, fourth, where the italicized names represent components and the semicolon and reserved characters used as separators. The encode URI and decode URI functions are intended to work with complete URIs. They assume that any reserved characters in the URI are intended to have special meaning and so are not encoded. The encode URI component and decode URI component functions are intended to work with the individual component parts of a URI. They assume that any reserved characters represent text and so must be encoded so that they are not interpreted as reserved characters when the component is part of a complete URI. The following lexical grammar specifies the form of encoded URIs. URI character sopt, URI characters, URI character, URI character sopt, URI character, URI reserved, URI unescaped, URI escaped, URI reserved. One of at and equals plus $sign. ECMA International 2009 105. URI unescaped. URI alpha decimal digit URI mark URI escaped hex digit URI alpha. One of abdefgijamnopgrestavwexes URI mark. One of comma. When a character to be included in a URI is not listed above or is not intended to have the special meaning sometimes given to the reserved characters, that character must be encoded. The character is transformed into its UTF-8 encoding, with surrogate pairs first converted from UTF-16 to the corresponding code point value. Note that for code units in the range 0,127, this results in a single octet with the same value. The resulting sequence of octets is then transformed into a string with each octet represented by an escape sequence of the form %XX. The encoding and escaping process is described by the abstract operation encode taking two string arguments string and unescape set. Let strlen be the number of characters in string. Let r be the empty string. Let 0, 4. Repeat. 06. ECMA International 2009. ABC. D. If k equals strlen, return r. Let c be the character at position k within string. If c is an unescaped set, then let s be a string containing only the character c. Let r be a new string value computed by concatenating the previous value of r and s. Else, c is not an unescaped set if the code unit value of c is not less than 0xdc00 and not greater than 0xdfff. Throw a URI error exception if the code unit value of c is less than 0xd800 or greater than 0xdbff. Then, let v be the code unit value of c. Else, increase k by 1. If k equals strlen, throw a URI error exception. Let kchar be the code unit value of the character at position k within string. If kchar is less than 0xdc00 or greater than 0xdfff, throw a URI error exception. Let v be the code unit value of c, 0xd800. 0 times 400 plus kchar 0xdc00 plus 0 times 10,000. Let octets be the array of octets resulting by applying the UTF-8 transformation to v. And let L be the array size. Let 0 repeat. While j, L, E, 2. Increase k by 1. Let j octet be the value at position j within octets. Let s be a string containing 3 characters %xy where xy2 uppercase hexadecimal digits encoding the value of j octet. Let r be a new string value computed by concatenating the previous value of r and s. Increase j by 1. The unescaping and decoding process is described by the abstract operation decode taking 2 string arguments string and reserved set. Let strlen be the number of characters in string. Let r be the empty string. Let 0, 4. Repeat. If k equals strlen, return r. Let c be the character at position k within string. If c is not %, then I let s be the string containing only the character cd else c is %. Let's start bk. If k plus 2 is greater than or equal to strlen, throw a URI error exception. If the characters at position k plus 1 and k plus 2 within string do not represent hexadecimal digits, throw a URI error exception. Let b be the 8-bit value represented by the 2 hexadecimal digits at position k plus 1 and k plus 2. Increment k by 2. If the most significant bit in b is 0, then let c be the character with code unit value b. If c is not in reserved set, then let s be the string containing only the character c3. Else, c is in reserved set. Let s be the substring of string from position start to position k included 7. Else, the most significant bit in b is 1. Let n be the smallest non-negative number such that b, n, and 0 times 80 is equal to 0. If n equals 1 or n is greater than 4, throw a URI error exception. Let octets be an array of 8-bit integers of size n. Put b into octets at position 0. If k plus 3, n1, is greater than or equal to strlen, throw a URI error exception. Let 1 repeat. While j, n, increment k by 1. b if the character at position k is not %, throw a URI error exception. c if the characters at position k plus 1 and k plus 2 within string do not represent hexadecimal digits, throw a URI error exception. d let b be the 8-bit value represented by the 2 hexadecimal digits at position k plus 1 and k plus 2. e if the 2 most significant bits in b are not 10, throw a URI error exception. f increment k by 2. g put b into octets at position j. h increment j by 1. Let v be the value obtained by applying the UTF-8 transformation to octets. That is, from an array of octets into a 32-bit value. If octets does not contain a valid UTF-8 encoding of a Unicode code point, throw a URI error exception. If v is less than 0 times 10,000, then let c be the character with code unit value v. b if c is not in reserved set, then I let s be the string containing only the character cc else c is in reserved set. I let s be the substring of string from position start to position k included 0. Else, v is 0 times 10,000. If v is greater than 0 times 10ff, throw a URI error exception. b let l be v 0 times 10,000 and 0 times 3ff plus 0xdc00. c let h be v 0 times 10,000, 10, and 0 times 3ff plus 0xd800. d let s be the string containing the 2 characters with code unit values h. ECMA International 2009, 07, and l. f. Let r be a new string value computed by concatenating the previous value of r and s. Increase k by 1. The syntax of uniform resource identifiers is given in RFC 2396. A formal description and implementation of Note UTF-8 is given in RFC 3629. In UTF-8, characters are encoded using sequences of 1 to 6 octets. The only octet of a sequence of 1 has the higher order bits set to 0, the remaining 7 bits being used to encode the character value. In a sequence of n octets, n1, the initial octet has the n higher order bits set to 1, followed by a bit set to 0. The remaining bits of that octet contain bits from the value of the character to be encoded. The following octets all have the higher order bits set to 1 and the following bits set to 0, leaving 6 bits in each to contain bits from the character to be encoded. The possible UTF-8 encodings of ECMA script characters are specified in Table 21. Table 21. UTF-8 encodings. Code unit value 0 times 00000 times 007 F 0 times 00800 times 07 FF 0 times 0800 0xd7 FF 0 xd800 0xdbFF followed by 0 xdc 000 xdFFF 0 xd800 0xdbFF not followed by 0 xdc 000 xdFFF 0 xdc 000 xdFFF 0 000 xFF where representation 0000000 0 ZZ00000 years Zixi I is 110,110 VVVVWWXX followed by 110,111 years causes Uri error Xi years first octet 0 Zs ed 110 y 1110 XX 11,110 UUU 1110 XX second octet third octet fourth octet 10s ed z 10 y 10s ed z 10 u 10s xi 10s ed z 10 y 10s ed z
yhtä suuruusmerkki www plus 1.
To account for the addition of 0 times 10,000 as in surrogates, section 3.7 of the Unicode standard, the range of code unit values 0xd800-0xdFFF is used to encode surrogate pairs. The above transformation combines a UTF-16 surrogate pair into a UTF-32 representation and encodes the resulting 21-bit value in UTF-8. Decoding reconstructs the surrogate pair. RFC 3629 prohibits the decoding of invalid UTF-8 octet sequences. For example, the invalid sequence C080 must not decode into the character U plus 0000. Implementations of the decode algorithm are required to throw URI error when encountering such invalid sequences. 5, 1, 3, 1 decode URI, encoded URI. The decode URI function computes a new version of a URI in which each escape sequence and UTF-8 encoding of the sort that might be introduced by the encode URI function is replaced with the character that it represents. Escape sequences that could not have been introduced by encode URI are not replaced. When the decode URI function is called with one argument encoded URI, the following steps are taken. Let URI string be to string. Encoded URI. Let reserved URI set be a string containing one instance of each character valid in URI reserved plus. Return the result of calling decode. URI string. Reserved URI set. Note the character is not decoded from escape sequences even though it is not a reserved URI character. 8 copyright sign. ECMA International 2009. 5, 1, 3, 2 decode URI component. Encoded URI component. The decode URI component function computes a new version of a URI in which each escape sequence and UTF-8 encoding of the sort that might be introduced by the encode URI component function is replaced with the character that it represents. When the decode URI component function is called with one argument encoded URI component, the following steps are taken. Let component string be to string. Encoded URI component. Let reserved URI component set be the empty string. Return the result of calling decode. Component string. Reserved URI component set. 5, 1, 3, 3 encode URI. The encode URI function computes a new version of a URI in which each instance of certain characters is replaced by 1, 2 or 3 escape sequences representing the UTF-8 encoding of the character. When the encode URI function is called with one argument URI, the following steps are taken. Let URI string be to string. URI. Let unescaped URI set be a string containing one instance of each character valid in URI reserved and URI unescaped plus. Return the result of calling encode. URI string. Unescaped URI set. Note the character is not encoded to an escape sequence even though it is not a reserved or unescaped URI character. 5, 1, 3, 4 encode URI component. URI component. The encode URI component function computes a new version of a URI in which each instance of certain characters is replaced by 1, 2 or 3 escape sequences representing the UTF-8 encoding of the character. When the encode URI component function is called with one argument URI component, the following steps are taken. Let component string be to string. URI component. Let unescaped URI component set be a string containing one instance of each character valid in URI unescaped. Return the result of calling encode. Component string. Unescaped URI component set. 5, 1. 4 constructor properties of the global object 1 5, 1, 4, 1 object C1 5, 2, 1 and 1 5, 2, 2, 5, 1, 4, 2 function C1 5, 3, 1 and 1 5, 3, 2, 5, 1, 4, 3 array C1 5, 4, 1 and 1 5, 4, 2 ECMA International 2009 109 5, 1, 4, 4 string C1 5, 5, 1 and 1 5, 5, 2 5, 1, 4, 5 boolean C1 5, 6, 1 and 1 5, 6, 2 5, 1, 4, 6 number C1 5, 7, 1 and 1 5, 7, 2 5, 1, 4, 7 date C1 5, 9, 2 5, 1, 4, 8 Reggie XP C1 5, 1 0, 3 and 1 5, 1 0, 4 5, 1, 4, 9 error C1 5, 1 1, 1 and 1 5, 1 1, 2 5, 1, 4, 1 0 eval error C1 5, 1 1, 6, 1 5, 1, 4, 1 1 range error C1 5, 1 1, 6, 2 5, 1, 4, 1 2 reference error C1 5, 1 1, 6, 3 5, 1, 4, 1 3 syntax error C1 5, 1 1, 6, 4 5, 1, 4, 1 4 type error C1 5, 1 1, 6, 5 5, 1, 4, 1 5 URI error C1 5, 1 1, 6, 6, 5, 1, 5 other properties of the global object 1 5, 1, 5, 1 math C15.8, 10, copyright sign, ECMA International 2009, 5, 1, 5, 2 JSON C15.12, 5.2 objects, 5, 2, 1 the object constructor called as a function. When object is called as a function rather than as a constructor, it performs a type conversion 1 5, 2, 1, 1 object, value. When the object function is called with no arguments or with one argument value, the following steps are taken. If value is null, undefined or not supplied, create and return a new object exactly as if the standard built-in object constructor had been called with the same arguments. 1 5, 2, 2, 1. Return to object, value, 5, 2, 2 the object constructor. When object is called as part of a new expression, it is a constructor that may create an object. 5, 2, 2, 1 new object, value. When the object constructor is called with no arguments or with one argument value, the following steps are taken. If a value is supplied, then if type, value, is object, then if the value is a native ECMA script object, do not create a new object but simply return value. If the value is a host object, then actions are taken and a result is returned in an implementation-dependent manner that may depend on the host object. B if type, value, is string, return to object, value. C if type, value, is boolean, return to object, value. D if type, value, is number, return to object, value. Asset, the argument value was not supplied or its type was null or undefined. Let obj be a newly created native ECMA script object. Set the internal property of obj to the standard built-in object prototype object. 1 5, 2, 4. Set the internal property of obj to object. Set the internal property of obj to true. Set all the internal methods of obj as specified in 8.12. Return obj. 5, 2, 3 properties of the object constructor. The value of the internal property of the object constructor is the standard built-in function prototype object. Besides the internal properties and the length property, whose value is 1, the object constructor has the following properties: 5, 2, 3, 1 object prototype. The initial value of object prototype is the standard built-in object prototype object. 1, 5, 2, 4. ECMA International 2009 111. This property has the attributes false, false, false. 5, 2, 3, 2 object get prototype of O. When the get prototype of function is called with argument O, the following steps are taken. If type O is not object, throw a type error exception. Return the value of the internal property of O. 5, 2, 3, 3 object get own property descriptor O. P. When the get own property descriptor function is called, the following steps are taken. If type O is not object, throw a type error exception. Let name be to string P. Let desc be the result of calling the internal method of O with argument name. Return the result of calling from property descriptor desc 8, 1, 0, 4, 5, 2, 3, 4 object get own property names O. When the get own property names function is called, the following steps are taken. If type O is not object, throw a type error exception. Let array be the result of creating a new object as if by the expression new array, where array is the standard built-in constructor with that name. Let name 0 for each named own property P of O. Let name be the string value that is the name of P. Call the internal method of array with arguments to string N. The property descriptor name true, 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 and false. Increment N by 1. Return array. Note if O is a string instance, the set of own properties processed in step 4 includes the implicit properties defined in 1, 5, 5, 5, 2 that correspond to character positions within the object string. 5, 2, 3, 5 object create O. Properties. The create function creates a new object with a specified prototype. When the create function is called, the following steps are taken. If type O is not object or null, throw a type error exception. Let obj be the result of creating a new object as if by the expression new object, where object is the standard built-in constructor with that name. Set the internal property of obj to O. If the argument properties is present and not undefined, add own properties to obj as if by calling the standard built-in function object define properties with arguments obj and properties. Return obj. 5, 2, 3, 6 object define property O. P. Attributes. The defined property function is used to add a known property and or update the attributes of an existing own property of an object. When the defined property function is called, the following steps are taken. If type O is not object, throw a type error exception. Let name be to string P. Let desc be the result of calling to property descriptor with attributes as the argument. Call the internal method of O with arguments name, desc, and true. Return O. 12. Copyright sign ECMA International 2009. 5, 2, 3, 7 object defined properties O. Properties. The defined properties function is used to add own properties and or update the attributes of existing own properties of an object. When the defined properties function is called, the following steps are taken. If type O is not object, throw a type error exception. Let props be to object properties. Let names be an internal list containing the names of each enumerable own property of props. Let descriptors be an empty internal list for each element P of names in list order. Let desc obj be the result of calling the let desc be the result of calling to property descriptor with desc obj as the argument. Append desc to the end of descriptors for each element desc of descriptors in list order. Call the internal method of O with arguments P, desc, and true. Return O. If an implementation defines a specific order of enumeration for the foreign statement, that same enumeration order must be used to order the list elements in step 3 of this algorithm. 5, 2, 3, 8 object seal O. When the seal function is called, the following steps are taken. If type O is not object, throw a type error exception. For each named own property name P of O, let desc be the result of calling the internal method of O with P. If desc is true, set desc to false. Call the internal method of O with P, desc, and true as arguments. Set the internal property of O to false. Return O. 5, 2, 3, 9 object freeze O. When the freeze funct ion is called, the following steps are taken. If type O is not object throw a type error exception. For each named own property named P of O, let desc be the result of calling the internal method of O with P. If is data descriptor, desc, is true, then I if desc is true, set desc to false. See if desc is true, set desc to false. D call the internal method of O with P, desc, and true as arguments. Set the internal property of O to false. Return O. 5, 2, 3, 1, 0. Object prevent extensions. O. When the prevent extensions function is called, the following steps are taken. If type O is not object throw a type error exception. Set the internal property of O to false. Return O. 5, 2, 3, 1, 1. Object is sealed. O. When the is sealed function is called with argument O, the following steps are taken. If type O is not object throw a type error exception. For each named own property named P of O. ECMA International 2009 113. Let desc be the result of calling the internal method of O with P. If desc is true, then return false. If the internal property of O is false, then return true. Otherwise, return false. 5, 2, 3, 1, 2. Object is frozen. O. When the is frozen function is called with argument O, the following steps are taken. If type O is not object throw a type error exception. For each named own property named P of O, let desc be the result of calling the internal method of O with P. If is data descriptor, desc, is true then I if desc is true, return false. See if desc is true, then return false. If the internal property of O is false, then return true. Otherwise, return false. 5, 2, 3, 1, 3. Object is extensible. O. When the is extensible function is called with argument O, the following steps are taken. If type O is not object throw a type error exception. Return the Boolean value of the internal property of O. 5, 2, 3, 1, 4. Object keys. O. When the keys function is called with argument O, the following steps are taken. If the type O is not object, throw a type error exception. Let n be the number of own enumerable properties of O. Let array be the result of creating a new object as if by the expression new array, n, where array is the standard built-in constructor with that name. Let index be 0. For each own enumerable property of O whose name string is P, call the internal method of array with arguments to string, int x, the property descriptor, P, true, 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 and false. Increment index by 1. Return array. If an implementation defines a specific order of enumeration for the for-in statement, that same enumeration order must be used I. And step 5 of this algorithm. 5, 2, 4. Properties of the object prototype object. The value of the internal property of the object prototype object is null. The value of the internal property is object, and the initial value of the internal property is true. 1, 5, 2, 4, 1. Object prototype constructor. The initial value of object prototype constructor is the standard built-in object constructor. 5, 2, 4, 2. Object prototype toString. When the toString method is called, the following steps are taken. Let O be the result of calling to object passing the this value as the argument. Let class be the value of the internal property of O. 14. Copyright sign. ECMA International 2009. Return the string value that is the result of concatenating the 3 strings, object, class, and 5, 2, 4, 3. Object prototype to locale string. When the to locale string method is called, the following steps are taken. Let O be the result of calling to object passing the this value as the argument. Let toString be the result of calling the if is callable. toString is false. Throw a type error exception. Return the result of calling the internal method of toString passing O as the this value and no arguments. Note 1. This function is provided to give all objects a generic to locale string interface, even though not all may use it. Currently, array, number, and 8 provide their own locale sensitive to locale string methods. Note to the first parameter to this function is likely to be used in a future version of this standard. It is recommended that implementations do not use this parameter position for anything else. 5, 2, 4. 4. Object prototype value of. When the value of method is called, the following steps are taken. Let O be the result of calling to object passing the this value as the argument. If O is the result of calling the object constructor with a host object, 1, 5, 2, 2, 1, then a return either O or another value such as the host object originally passed to the constructor. The specific result that is returned is implementation defined. Return O. 5, 2, 4, 5. Object prototype his own property, v. When the hasOwnProperty method is called with argument v, the following steps are taken. Let p be to string v. Let o be the result of calling to object passing the this value as the argument. Let desc be the result of calling the internal method of o passing p as the argument. If desc is undefined, return false. Return true. Note 1. Unlike 8, 1, 2, 6, this method does not consider objects in the prototype chain. Note 2. The ordering of steps 1 and 2 is chosen to ensure that any exception that would have been thrown by step 1 in previous editions of this specification will continue to be thrown even if the this value is undefined or null. 5, 2, 4, 6. Object prototype is prototype of v. When the is prototype of method is called with argument v, the following steps are taken. If v is not an object, return false. Let o be the result of calling to object passing the this value as the argument. Repeat. ABC. Let v be the value of the internal property of v if v is null. Return false. If o and v refer to the same object, return true. The ordering of steps 1 and 2 is chosen to preserve the behavior specified by previous editions of this. Note, specification for the case where v is not an object and the this value is undefined or null. ECMA International 2009 115. 5, 2, 4, 7. Object prototype property is enumerable. V. When the property is enumerable method is called with argument v, the following steps are taken. Let p be to string v. Let o be the result of calling to object passing the this value as the argument. Let desc be the result of calling the internal method of o passing p as the argument. If desc is undefined, return false. Return the value of desc. Note 1. This method does not consider objects in the prototype chain. Note 2. The ordering of steps 1 and 2 is chosen to ensure that any exception that would have been thrown by step 1 in previous editions of this specification will continue to be thrown even if the this value is undefined or null. 1, 5, 2. 5. Properties of object instances. Object instances have no special properties beyond those inherited from the object prototype object. 5.3. Function objects. 5, 3, 1. The function constructor called as a function. When function is called as a function rather than as a constructor, it creates and initializes a new function object. Thus, the function call function is equivalent to the object creation expression new function with the same arguments. 5, 3, 1. 1 function, page 1, page 2, pn, body. When the function is called with some arguments page 1, page 2, pn, body where n might be 0. That is, there are no p arguments, and where body might also not be provided, the following steps are taken. Create and return a new function object as if the standard built-in constructor function was used in a new expression with the same arguments. 1, 5, 3, 2, 1, 5, 3, to the function constructor. When function is called as part of a new expression, it is a constructor. It initializes the newly created object 1, 5, 3, 2, 1 new function, page 1, page 2, pn, body. The last argument specifies the body executable code of a function. Any preceding arguments specify formal parameters. When the function constructor is called with some arguments page 1, page 2, pn, body where n might be 0. That is, there are no p arguments, and where body might also not be provided, the following steps are taken. Let argCount be the total number of arguments passed to this function invocation. Let p be the empty string. If argCount equals 0, let body be the empty string. Else if argCount equals 1, let body be the t argument. Else, argCount 1. 16. ECMA International 2009. ABCD. Let first arg be the first argument. Let p be to string, first arg. Let 2. Repeat. Okay, argCount. I let next arg be the kth argument. Let p be the result of concatenating the previous value of p, the string, a comma, and to string, next arg. Increase k by 1. Let body be the kth argument. Let body be to string, body. If p is not parsable as a formal parameter list opt then throw a syntax error exception. If body is not parsable as function body then throw a syntax error exception. If body is strict mode code, C10, 1, 1, then let strict be true, else let strict be false. If strict is true, Throw any exceptions specified in 13.1 that apply. Return a new function object created as specified in 13.2. Passing p is the formal parameter list and body is the function body. Pass in the global environment as the scope parameter and strict as the strict flag. A prototype property is automatically created for every function to provide for the possibility that the function will be used as a constructor. Note it is permissible but not necessary to have one argument for each formal parameter to be specified. For example, all three of the following expressions produce the same result. New function a, b, c, return a plus b plus c. New function a, b, c, return a plus b plus c. New function a, b, c, return a plus b plus c. 5, 3. Three properties of the function constructor. The function constructor is itself a function object and it says function. The value of the internal property of the function constructor is the standard built-in function prototype object. 1, 5, 3, 4. The value of the internal property of the function constructor is true. The function constructor has the following properties. 5, 3, 3. 1. Function prototype. The initial value of function prototype is the standard built-in function prototype object. 1, 5, 3, 4. This property has the attributes false, false, false. 5, 3, 3, 2. Function length. This is a data property with a value of 1. This property has the attributes false, false, false. 5, 3, 4. Properties of the function prototype object. The function prototype object is itself a function object. It says function that, when invoked, accepts any arguments and returns undefined. The value of the internal property of the function prototype object is the standard built-in object prototype object. 1, 5, 2, 4. The initial value of the internal property of the function prototype object is true. The function prototype object does not have a value of property of its own. However, it inherits the value of property from the object prototype object. The length property of the function prototype object is 0. ECMA International 2009 117. 5, 3, 4. 1. Function prototype constructor. The initial value of function prototype constructor is the built-in function constructor. 1, 5, 3, 4. 2. Function prototype to string. An implementation-dependent representation of the function is returned. This representation has the syntax of a function declaration. Note in particular that the use and placement of white space, line terminators, and semicolons within the representation string is implementation dependent. The toString function is not generic. It throws a type error exception if this value is not a function object. Therefore, it cannot be transferred to other kinds of objects for use as a method. 5, 3, 4. 3. Function prototype apply. This arg-array, when the apply method is called on an object func with arguments this arg and arg-array, the following steps are taken. If this callable func is false, then throw a type error exception. If arg-array is null or undefined, then return the result of calling the internal method of func, providing this argues this value in an empty list of arguments. If type arg-array is not object, then throw a type error exception. Let len be the result of calling the. If len is null or undefined, then throw a type error exception. Let n be 32. Len. If n is not equal to number, len, then throw a type error exception. Let arglist be an empty list. Let index be 0. Repeat while index n. Let index name be toString index. Let next arg be the result of calling the argument. Append next arg as the last element of arglist. Set index to index +1. Return the result of calling the internal method of func, providing this argues this value and arglist as the list of arguments. The length property of the apply method is 2. Note that this arg value is passed without modification as this value. This is a change from addition. 3. Where a undefined or null this arg is replaced with the global object and to object is applied to all other values and that result is passed as this value. 5, 3, 4. 4. Function prototype call. This arg1, arg2. When the call method is called on an object func with argument this arg and optional arguments arg1, arg2 etc. The following steps are taken. If this callable func is false, Then throw a type error exception. Let argList be an empty list. If this method was called with more than one argument, then in left to right order starting with arg1 append each argument as the last element of argList. Return the result of calling the internal method of func, providing this arg as the this value and argList as the list of arguments. The length property of the call method is 118. Copyright sign, ECMA International 2009. Note that this arg value is passed without modification as the this value. This is a Chang, E from edition 3, where a undefined or null this arg is replaced with the global object and to object is applied to all other values and that result is passed as the this value. 5, 3, 4, 5 function prototype bind. This arg1, arg2. The bind method takes one or more arguments. This arg and, optionally, arg1, arg2, etc. and returns a new function object by performing the following steps. Let target be the this value. If this callable target is false, throw a type error exception. Let it be a new, possibly empty, internal list of all of the argument values provided after this arg1, arg2, etc. In order, let f be a new native ECMA script object. Set all the internal methods, except for set the internal property of f to target, set the internal property of f to the value of this arg, set the internal property of f to a, set the internal property of f to function, set the internal property of f to the standard built-in function prototype object as specified in 5, 3, 3, 1. Set the internal property of f as described in 1, 5, 3, 4, 5, 1. Set the internal property of f as described in 1, 5, 3, 4, 5, 2. Set the internal property of f as described in 1, 5, 3, 4, 5, 3. If the internal property of target is function, then let L be the length property of target minus the length of A. Set the length own property of f to either 0 or L, whichever is larger. Else set the length own property of f to 0. Set the attributes of the length own property of f to the values specified in 1, 5, 3, 5, 1. Set the internal property of f to true. Let thrower be the function object. 1, 3, 2, 3. Call the internal method of f with arguments caller, property descriptor, thrower, false, false, and false. Call the internal method of f with arguments, property descriptor, thrower, false, false, and false. Return f. The length property of the bind method is 1. Note function objects created using function prototype bind do not have a prototype property or the code and internal properties. 5, 3, 4, 5, 1. When the internal method of a function object, f, which was created using the bind function is called with a this value and a list of arguments extra args, the following steps are taken. Let bound args be the value of f's internal property. Let bound this be the value of f's internal property. Let target be the value of f's internal property. Let args be a new list containing the same value s as the list bound args in the same order followed by the same values as the list extra args in the same order. Return the result of calling the internal method of target providing bound this as the this value and providing args as the arguments. 5, 3, 4, 5, 2. When the internal method of a function object, f that was created using the bind function is called with a list of arguments extra args, the following steps are taken. ECMA International 2009 119. Let target be the value of f's internal property. If target has no internal method, a type error exception is thrown. Let bound args be the value of f's internal property. Let args be a new list containing the same values as the list bound args in the same order followed by the same values as the list extra args in the same order. Return the result of calling the internal method of target providing args as the arguments. 5, 3, 4, 5, 3, v. When the internal method of a function object f that was created using the bind function is called with argument v. The following steps are taken. Let target be the value of f's internal property. If target has no internal method, a type error exception is thrown. Return the result of calling the internal method of target providing v as the argument. 5, 3, 5 properties of function instances. In addition to the required internal properties, every function instance has an internal property and in most cases use a different version of the internal property. The internal property, the internal property, the internal property, internal property, internal property, internal property, and internal property. The value of the internal property is function. Function instances that correspond to strict mode functions. 13.2, and function instances created using the function prototype bind method. 1, 5, 3, 4, 5, have properties named caller and arguments that throw a type error exception. Any JavaScript implementation must not associate any implementation-specific behavior with accesses of these properties from strict mode function code. 5, 3, 5, 1 length. The value of the length property is an integer that indicates the typical number of arguments expected by the function. However, the language permits the function to be invoked with some other number of arguments. The behavior of a function when invoked on a number of arguments other than the number specified by its length property depends on the function. This property has the attributes false, false, able, false, 5, 3, 5, 2 prototype. The value of the prototype property is used to initialize the internal property of a newly created object before the function object is invoked as a constructor for that newly created object. This property has the attribute true, false, false. Note function objects created using function prototype bind do not have a prototype property. 5, 3, 5, 3. V. Assume f is a function object. When the internal method of f is called with value v, the following steps are taken. If v is not an object, return false. Let o be the result of calling the if type. O is not object, throw a type error exception. Repeat. 20. ECMA International 2009. Let v be the value of the internal property of v, bc. If v is null, return false. If o and v refer to the same object, return true. Function objects created using function prototype bind have a different implementation of 1, 5, 3, 5, 4. Function objects use a variation of the assume f is a function object. When the let v be the result of calling the default. If p is caller and v is a strict mode function object, throw a type error exception. Return v. Note function objects created using function prototype bind use the default. Array objects give special treatment to a certain class of property names. A property name p, in the form of a string value, is an array index if and only if to string 232 p is equal to p and 232 p is not equal to 232 1. A property whose property name is an array index is also called an element. Every array object has a length property whose value is always a non-negative integer less than 232. The value of the length property is numerically greater than the name of every property whose name is an array index. Whenever a property of an array object is created or changed, other properties are adjusted as necessary to maintain this invariant. Specifically, whenever a property is added whose name is an array index, the length property is changed, if necessary, to be one more than the numeric value of that array index, and whenever the length property is changed, every property whose name is an array index whose value is not smaller than the new length is automatically deleted. This constraint applies only to own properties of an array object and is unaffected by length or array index properties that may be inherited from its prototypes. An object, O, is said to be sparse if the following algorithm returns true. Let len be the result of cali ng the. For each integer I in the range of 0 to 32, len, let elem be the result of calling the internal method of O with argument to string I. B if elem is undefined, return true 3. Return false 5, 4, 1. The array constructor called as a function. When array is called as a function rather than as a constructor, it creates and initializes a new array object. Thus, the function call array is equivalent to the object creation expression new array with the same arguments 5, 4, 1. 1 array, item 1, item 2. When the array function is called, the following steps are taken. Create and return a new array object exactly as if the standard built-in constructor array was used in a new expression with the same arguments 1, 5, 4, 2. Note has instance defined in 1, 5, 3, 4, 5, 3. ECMA International 2009 121 5, 4, 2. The array constructor. When array is called as part of a new expression, it is a constructor, It initializes the newly created object 5, 4, 2, 1 new array, item 0, item 1. This description applies if and only if the array constructor is given no arguments or at least 2 arguments. The internal property of the newly constructed object is set to the original array prototype object, the one that is the initial value of array prototype 1, 5, 4, 3, 1. The internal property of the newly constructed object is set to array. The internal property of the newly constructed object is set to true. The length property of the newly constructed object is set to the number of arguments. The 0 property of the newly constructed object is set to item 0. If supplied, the 1 property of the newly constructed object is set to item 1, if supplied, and, in general, for as many arguments as there are. The k property of the newly constructed object is set to argument k, where the first argument is considered to be argument number 0. These properties all have the attributes true, 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 5, 4, 2. To new array, len. The internal property of the newly constructed object is set to the original array prototype object, the one that is the initial value of array prototype 1, 5, 4, 3, 1. The internal property of the newly constructed object is set to array. Property of the newly constructed object is set to true if the
So, I got all the hexadecimal whatever to byte things or places stuff. And, I don't know.
len is a number.
I, get extra points if you think I'm crazy. Because, anyone who says so will look crazy for, like, saying I am.
Property
I'm just, going with my gut. And apparently it's, like, setting stage of stuff.
object is
So, like, this stream's almost at 12 hours.
5.
So I'm gonna, like, set the BRB screen, leave it for, like, 10 minutes, and then start another stream. So, I don't know. I'll, BRB. So now I can, like, finally get started on the shifts right here and stuff. So I don't know. I'll BRB
4.
in the next stream, whatever.
The initial value of array prototype is the array prototype object 1, 5, 4, 4. This property has the attributes false,
Starting on the shifts.
4, 3, 2. Array is array, arg, argument arg, and returns
Just getting started.
object, whose class internal property is array, otherwise it returns false. The following steps are taken. 22. Copyright sign, ECMA International 2009. If type, arg, is not object, return false. If the value of the internal property of arg is array, then return true. Return false. 5, 4, 4 properties of the array prototype object. The value of the internal
That's good enough, I guess.
object is the standard built-in object prototype object 1, 5, 2, 4. The array prototype object is itself an array, it's an array, and it has a length property, whose initial value is +0, and the special internal method described in 1, 5, 4, 5, 1. In following descriptions of functions that are properties of the array prototype object, the phrase "this object" refers to the object